Hey guys, welcome back to another video by Simplilearn. In today's video, we're going to be learning all about the two most commonly used databases, that is MongoDB and SQL. But before we begin, let's look at a quick introduction to database. Now, a database is information that is set up for easy access, management, and updation. Computer databases typically store aggregations of data records or files that contain information such as sales transactions, customer data, finances, and product information. Databases are used for storing, maintaining, and accessing any sort of data. They collect information on people, places, or things. That information is gathered in one place so that it can be observed and analyzed. Now, in short, databases can be thought of as an organized collection of information. Some of the main features of using database includes improving business processes, keeping track of customers, secure personal health information, and storage of personal data. Now, there are several different types of databases available. There's relational databases, NoSQL databases, object-oriented databases, distributed databases, and so on. In this video, we will learn about two commonly used databases, that is SQL, which is a relational database, and MongoDB, which is a NoSQL database. But before we begin, if you haven't subscribed to our channel already, make sure to hit the subscribe button and the bell icon to never miss an update. Now, without further ado, let's begin. First, let's look at what's in store for you with respect to SQL. This session will help you write SQL commands using MySQL, PostgreSQL, as well as SQL Server. Our highly experienced trainers will take you through this course. So here's what's in store for you. First, we'll start by learning the basics of SQL along with understanding entity relationship diagrams. Then you will learn how to install MySQL Workbench on Windows. We'll then look at the popular SQL commands to select, insert, update, delete records, and perform other operations on database tables. You will also see how to use the top numerical and text functions in SQL. Next, we'll cover how to use group by and having clauses in SQL, followed by joins. You'll learn the different types of join statements as well as subqueries in SQL. And moving further, we'll understand triggers, stored procedures, and window functions in MySQL. You will get an idea about another important topic, that is to write SQL queries with Python on the Jupyter Notebook. Then, we'll look at another free and open source relational database management system, that is Postgre hands-on demonstration. Finally, you'll learn how to become an SQL developer and see the top SQL interview questions that are frequently asked in the interviews. So these are the topics covered in SQL. Moving ahead, with respect to MongoDB, first you'll learn what exactly MongoDB is. Then you'll look at a simple demonstration to install MongoDB on your Windows system. Then we'll look at a detailed MongoDB tutorial that explains how to insert, create, update, and delete data. We'll look at how to connect MongoDB with different applications, and in this case, we'll be connecting MongoDB to Python. And lastly, we'll draw a comparison between MongoDB systems. But before we begin, if you haven't subscribed to our channel already, make sure to hit the subscribe button and the bell icon to never miss an update. So now let's dive right in.
In this session, we are going to learn about databases, how data is stored in relational databases, and we'll also look at some of the popular databases. Finally, we'll understand. So according to Oracle, a database is an organized typically stored electronically in a computer system. A database is usually controlled by a database management system or DBMS. So it is a storage system that has a collection of data. Relational databases store data in the form of tables that can be easily retrieved, managed, and updated. You can organize data into tables, rows, columns, and index it to make it easier to find relevant information. Now, talking about some of the popular databases, we have MySQL database, we also have Oracle database, then we have MongoDB, which is a NoSQL database. Next, we have Microsoft SQL Server. Next, we have Apache Cassandra, which is a free and open source NoSQL database. And finally, we have PostgreSQL. Now, let's learn what is SQL. So SQL is a domain-specific language to communicate with databases. SQL was initially developed by IBM. Most databases use structured query language or SQL for writing and querying data. SQL commands help you to store, process, analyze, and manipulate databases. With this, let's look at what a table is. Table in a database looks like. So here you can see the name of the table is players. On the top you can see the column names. So we have the player ID, the P2, and we also have the goals scored by each of the players. So these are also known as fields in a database. Here each row represents a record or a tuple. So you have the player ID, which is 103 here. The name of the player is.
It doesn't require much coding to manage databases. Now we will see applications of SQL. SQL is used to create a database, define its structure, implement it, and lets you perform many functions. SQL is also used for maintaining an already existing database. SQL is a powerful language for entering data, modifying data, and extracting data in a database. SQL is extensively used as a client-server language to connect the front end with the back end, thus supporting the client-server architecture. SQL, when deployed as Data Control Language (DCL), helps protect your database from unauthorized access.
In this session, we will learn who is a SQL developer and what are their responsibilities in a company. First, we will understand who is a SQL developer. SQL developer is a person who is accountable in creating and managing huge data assets of a company. In other terms, SQL developer is a person who can develop SQL databases as well as write and test code. Let's understand this with the help of an example. Let's say we want to search a particular product on Amazon website, and Amazon has stored all its data about products in a database. Now we will write the product name in the search bar, and when we click on the search button, it will run a SQL query that fetches all the information about the product and displays us on the website. So this is the basic task done by a SQL developer. Now we will understand the responsibilities of a SQL developer. All databases have a structure and logic behind how data is stored and retrieved. A SQL developer designs the database accordingly for businesses, that is called database modeling. After the database is created and deployed, it's the SQL developer who is responsible for fixing the general issues of the database. SQL developer should be well versed with structured query language to create optimized SQL queries and refines the existing ones to extract information from the database. SQL developers run several diagnostic tests to keep a check on the server and the database. In order to understand how to organize company's data, SQL developers must communicate with technical and non-technical persons from the business, and SQL developer also gathers client requirements and identifies the features that the database owners want. As data is an asset to a company, SQL developers backup and restore data for their clients. They also perform tasks like data management and data migration. That is, if a company has stored all its data on a local storage and now it wants its data to be stored in a cloud storage. So the safe transmission of the data from local storage to cloud storage is known as data migration, and that is done by the SQL developers. After knowing the responsibilities, now we should look for skill set required to be a good SQL developer. One should have a good knowledge of SQL commands, functions, joins and procedures. Let's have a look at few commands such as create, drop, alter and truncate. These commands come under data definition language. We also have insert, update and delete commands. These commands come under data manipulation language. We have grant and revoke commands. These commands come under data control language. We also have commit, rollback and save point commands. These come under transaction control language. These are the basic commands a SQL developer should be familiar with. And a SQL developer may have a little command on any one programming language. You don't have to be expert in programming. All you need is how to interface between application and your database. For example, you are using MySQL and your web application is based on PHP. Then you should know how to connect your application to the database and how to issue queries, how to fetch results, and then how to display it to the users. One should have a good understanding of various database management systems such as MySQL, Microsoft Access, Oracle, PostgreSQL, DBase, FoxPro, SQLite, IBM DB2, LibreOffice Base, MariaDB, and Microsoft SQL Server. One should know integration of databases with data visualization software such as Power BI and Tableau, which helps businesses to make better decisions and give you an add-on as a SQL developer. One should develop critical thinking and problem-solving skills to create optimized queries. Now we'll see how a SQL developer is compensated in both United States and India. In the United States, SQL developers draw an average salary of $72,282 per annum. In India, the average salary of a SQL developer is Rs 4,49,532. Now we'll see how a person can become a good SQL developer. For that, one should have a good command on structured query language and know how to interact with database management system and can issue queries to get the desired result. Earning industry-recognized SQL developer certifications such as Microsoft Certified Professional Developer (MCPD) or Oracle PL/SQL Developer Certified Associate, which usually require a passing score on an exam. And it's important to accumulate as much practical experience as possible. Start by designing, creating, and querying small databases connected with your hobbies and interests. For example, your favorite music, videos, or your personal finances. This will enable you to gain experience, test your knowledge, and build your project portfolio, which will be highly beneficial when you start applying for your first full-time position. Now we will see some major companies recruiting SQL developers. First we have the Multinational Financial Services Corporation, American Express, followed by the Multinational Professional Services Network, Ernst & Young. We also have the messaging company WhatsApp. Then we have the e-commerce giant Amazon, as well as the technology and computer solutions company Dell. Finally, in our list of companies, we have the multinational technology company Google.
In this session, we will learn about ER diagram. Have you ever wondered how these big e-commerce companies manage their tons of data that keeps updating every second? And these data sets keep on updating in their databases. To perform operations on this data, they should have a conceptual understanding of these databases. And this is done by understanding ER diagrams of the databases. So let's understand what an ER diagram is. An entity relationship diagram describes the relationship of entities that needs to be stored in a database. ER diagram is mainly a structural design for the database. It is a framework made using specialized symbols to define the relationship between entities. ER diagrams are created based on the three main components: entities, attributes, and relationships. Let's understand the use of ER diagram with the help of a real-world example. Here, a school needs all its student records to be stored digitally, so they approach an IT company to do so. A person from the company will meet the school authorities, note all their requirements, describe them in the form of ER diagram, and get it cross-checked by the school authorities. As the school authorities approve the ER diagram, the database engineers would carry further implementation. Let's have a view of an ER diagram. The following diagram showcases two entities, student and course, and their relationship. The relationship described between student and course is many-to-many, as a course can be opted by several students, and a student can opt for more than one course. Here, student is the entity and it possesses the attributes, that is, student ID, student name, and student age. And the course entity has attributes such as course ID and course name. Now we have an understanding of ER diagram. Let us see why it has been so popular. The logical structure of the database provided by ER diagram communicates the landscape of business to different teams in the company, which is eventually needed to support the business. ER diagram is a GUI representation of the logical structure of a database, which gives a better understanding of the information to be stored in a database. Database designers can use ER diagrams as a blueprint, which reduces complexity and helps them save time to build databases quickly. ER diagrams helps you identify the entities that exist in a system and the relationships between those entities. After knowing its uses, now we should get familiar with the symbols used in ER diagram. The rectangle symbol represents the entities, oval symbol represents attributes, a rectangle embedded in a rectangle represents a weak entity,
A dashed oval represents a derived attribute, a diamond symbol represents a relationship among entities, double oval symbol represents multi-valued attributes. Now we should dive in and learn about the components of ER diagram. There are three main components of ER diagram: entity, attribute, and relationship. Entities have weak entity. Attributes are further classified into key attribute, composite attribute, multi-valued attribute, and derived attribute. Relationships are also classified into one-to-one relationships, one-to-many relationships, many-to-one relationships, and many-to-many relationships. Let's understand these components of ER diagram, starting with entities. An entity can be either a living or a non-living component. An entity is showcased as a rectangle in an ER diagram. Let's understand this with the help of an ER diagram. Here, both student and course are in rectangular shape and are called entities, and they represent the relationship study in a diamond shape. Let's transition to weak entity. An entity that makes reliance over another entity is called a weak entity. The weak entity is showcased as a double rectangle in ER diagram. In the example below, the school is a strong entity because it has a primary key attribute, school number. Unlike the school, the classroom is a weak entity because it does not have any primary key, and the room number attribute here acts only as a discriminator and not a primary key. Now, let us know about attributes. Attribute. An attribute exhibits the properties of an entity. An attribute is illustrated with an oval shape in an ER diagram. In the example below, student is an entity and the properties of student such as address, age, name, and roll number are called its attributes. Let's see our first classification under attribute, that is key attribute. The key attribute uniquely identifies an entity from an entity set. The text of a key attribute is underlined. In the example below, we have a student entity and it has attributes name, address, roll number, and age. But here, roll number can uniquely identify a student from a set of students. That's why it is termed as a key attribute. Now, we will see composite attribute. An attribute that is composed of several other attributes is known as a composite attribute. An oval showcases the composite attribute, and the composite attribute oval is further connected with other ovals. In the example below, we can see an attribute name, which can have further subparts such as first name, middle name, and last name. These attributes with further classification is known as composite attribute. Now, let's have a look at multi-valued attribute. An attribute that can possess more than one value are called multi-valued attributes. These are represented as double oval shape. In the example below, the student entity has attributes phone number, roll number, name, and age. Out of these attributes, phone number can have more than one entry, and the attribute with more than one value is called multi-valued attribute. Let's see derived attribute. An attribute that can be derived from other attributes of the entity is known as a derived attribute. In the ER diagram, the derived attribute is represented by dashed oval, and in the example below, student entity has both date of birth and age as attributes. Here, age is a derived attribute as it can be derived by subtracting current date from the student date of birth. Now, after knowing attributes, let's understand relationship in ER diagram. A relationship is showcased by the diamond shape in the ER diagram. It depicts the relationship between two entities. In the below example, student, study, course. Here, both student and course are entities and study is the relationship between them. Now, let's go through the type of relationship. First is one-to-one relationship. When a single element of an entity is associated with a single element of another entity, this is called one-to-one relationship. In the example below, we have student and identification card as entities. We can see a student has only one identification card and an identification card is given to one student. It represents a one-to-one relationship. Let's see the second one, one-to-many relationship. When a single element of an entity is associated with more than one element of another entity is called one-to-many relationship. In the below example, a customer can place many orders, but a particular order cannot be placed by many customers. Now, we will have a look at many-to-one relationship. When more than one element of an entity is related to a single element of another entity, it is called many-to-one relationship. For example, students have to opt for a single course, but a course can be opted by a number of students. Let's see many-to-many relationship. When more than one element of an entity is associated with more than one element of another entity is called many-to-many relationship. For example, an employee can be assigned to many projects, and many employees can be assigned to a particular project. Now, after having an understanding of ER diagram, let us know the points to keep in mind while creating the ER diagram. First, identify all the entities in the system, embed all the entities in a rectangular shape and label them appropriately. This could be a customer, a manager, an order, an invoice, a schedule, etc. Identify relationships between entities and connect them using a diamond in the middle illustrating the relationship. Do not connect relationships. Connect attributes with entities and label them appropriately, and the attributes should be in oval shape. Assure that each entity only appears a single time, and eradicate any redundant entities or relationships in the ER diagram. Make sure your ER diagram supports all the data provided to design the database. Make effective use of colors to highlight key areas in your diagrams.
There are mainly 4 types of SQL commands. So first we have data definition language or DDL. So DDL commands change the structure of the table, like creating a table, deleting a table, or altering a table. All the commands of DDL are auto-committed, which means it permanently saves all the changes in the database. We have create, alter, drop, and truncate as DDL commands. Next, we have data manipulation language or DML. So DML commands are used to modify a database. It is responsible for all forms of changes in the database. DML commands are not auto-committed, which means it can't permanently save all the changes in the database. We have select, update, delete, and insert as DML commands. Now select command is also referred to as DQL or data query language. Third, we have data control language or DCL. So DCL commands allow you to control access to data within the database. These DCL commands are normally used to create objects related to user access and also control the distribution of privileges among users. So we have grant and revoke, which are the examples of data control language. Finally, we have something called as transaction control language or TCL. So TCL commands allow the user to manage database transactions. Commit and rollback are example of TCL. Now let's see the basic SQL command structure. So first, we have the select statement. So here you specify the various column names that you want to fetch from the table. We write the table name using the from statement. Next, we have the where clause to filter out our table based on some conditions. So you can see here where condition 1, condition 2, and so on. Then we have the group by clause that takes various column names. So you can write group by column 1, column 2, and so on. Next, we have the having clause to filter out tables based on groups. Finally, we have the order by clause to filter out the result in ascending or descending order. Now talking about the various data types in SQL. So we have exact numeric, which has integer, small int, bit, and decimal. Then we have approximate numeric, which are float and real. Then we have some date and time data types such as date, time, timestamp, and others. Then we have string data type, which includes char, the varchar, and text. Finally, we have binary data types, and binary data types have binary, var binary, and image. Now let's see some of the various operators that are present in SQL. So first we have our basic arithmetic operators. So you have addition, the subtraction, multiplication, division, and modulus. Then we have some logical operators like all, and, any, or, between, exists, and so on. Finally, we have some comparison operators such as equal to, not equal to, thus greater than, less than, greater than equal to, or less than equal to, not less than, or not greater than. Now let me take you to my MySQL workbench where we will learn to write some of the important SQL commands, use different statements, functions, data types, and operators that we just learned.
In this session, we will learn how to install MySQL Workbench
and then we will run some commands. Firstly, we will visit the official Oracle website, that is mysql.com, and now we'll move to the downloads page. Now scroll down and click on MySQL GPL downloads. Now under community downloads, click on MySQL installer for Windows. The current versions are available to download. I will choose this installer and click the download button. Now here just click on no thanks, just start my download. Once the installer has downloaded, open it. You may be prompted for permission. Click yes. This opens the installer. You will be asked to choose the setup type. We will go with custom. Click next. Now you have to select the products you want to install. We will install only the MySQL server, MySQL shell, and the MySQL workbench. Expand MySQL servers by double clicking on it. And choose the version you want to install and click on this arrow. Now you have to do the same thing for applications. Expand applications and choose the MySQL workbench version you want to install and click on the arrow. And we'll do the same thing for MySQL shell. We'll choose the latest version, click on the arrow. So these are the products that have to be installed in a system. Now we'll click next. I'll click execute to download and install the server. This may take a while depending on your internet speed. As the download is completed, click next. Now you see the product configuration. Click next. Now we will configure our SQL Server instance. Here we will go with the default settings and click next. And under authentication, select use strong password encryption for authentication, which is recommended, and click on next. Now here set the password for your root user. By the way, root is the default user. This user will have access to everything. I will set my password. Now I will click on next. And here also we'll keep the default settings and click on next. Now to apply configuration, we will execute the process. Once all the configuration steps are complete, click finish. Now you will see the installation is complete. It will launch MySQL Workbench and MySQL Shell after clicking on finish. Now the shell and workbench has started. Now we will connect by clicking on the root user. It will ask for a password. Enter the password and it will connect successfully. The workbench has started. Now we'll just connect the server. So first we'll open command prompt. Now we'll reach the path where MySQL files are present. We'll go into this PC, local disk C, program files, MySQL, MySQL Server 8.0, bin. And now we'll copy this path. Now we'll open the command prompt and write a command cd space and paste the link and press enter. Now we'll write another command that will be MySQL -u space root -p and press enter. Now it will ask for your password. Just enter the password and press enter. Now the server has started, and now we'll see some commands in MySQL Workbench. First we will open MySQL Workbench. Now we'll click on the local instance MySQL 80 and enter the password to connect to the local host. Now the MySQL Workbench has started. Now we will see some commands. The first command we will see is show databases. Show databases semicolon, and now we will select the whole command and click on this execute button, and here we will see the result in the result grid. These are the databases that are stored already in the database. Now there are 4 databases, that is Information Schema, MySQL, Performance Schema and SYS. Now we will select one of the database. We will use MySQL. Now we have selected the MySQL database, and now in this database we will see which tables are stored in this MySQL database. To see that, we will run a command show tables. We'll select the command and click on the execute button. These are the tables that are stored in this MySQL database, that is columns, underscore prive, component, DB and much more.
Now let me now go ahead and open my MySQL Workbench. So in the search bar I'll search for MySQL Workbench. You can see I'm using the 8.0 version. I'll click on it, and here it says welcome to MySQL Workbench, and below under connections you can see I have already created a connection which says local instance. Then you have the root, the local host and the port number. Let me click on it. You can see the service, the username is root, and I'll enter my password and hit OK. Now this will open the SQL editor. So this is how the MySQL Workbench looks like. Here we learn some of the basic SQL commands. So first let me show you the databases that are already present. So the command is show databases. You can hit tab to autocomplete. I'll use a semicolon. I'll select this, and here on the top you can see the execute button. So if I run this, below you can see the output. It says show databases, 7 rows are returned, which means currently there are 7 databases. You can see the names. Alright, now let's say I want to see the tables that are present inside this database called world. So I'll use the command use world, which is the database name. Now let me run it. So currently I'm using the world database. So to display the tables that are present in the world database, I can use the show command and write show tables. Give a semicolon, and I'll hit Control Enter this time to run it. Alright, so you can see the tables that are present inside this world database. So we have 3 tables in total: city, country and country language. Now if you are to see the rows that are present in one of the tables, you can use the select command. So I'll write select star, which basically means I want to display all the columns. So star here means to display all the columns. Then I'll write my from the table name, that is city. So this command is going to display me all the rows that are present inside the city table. So if I hit Control Enter, alright, you can see the message here. It says 1000 rows were returned, which means there were total 1000 records present inside the city table. So here you can see there's an ID column, a name column, this country code, district and population. Alright. Similarly, you can check the structure of the table by using the describe command. So I'll write describe and then I'll give the table name, that is city. Now let's just run it. There you go. The field shows the column names. So we have ID, name, country code, district, population. Type here shows the data type of each of the columns. So district is character 20, ID is an integer, population is also integer. Null says yes or no, which means if no, then there are no null values. If it's yes, which means there are null values in your table. Key here represents whether you have any primary key or foreign key, and these are some extra information. Now let's learn how to create a table in MySQL. So I'll use the create table command for this, and before that let me create a database and I'll name it as SQL intro. So the command is create database and I'll give my database name, that is SQL_intro. Let me give a semicolon and hit Control Enter. So you can see I have created a new database. Now if I run this command, that is show databases, you can see this newly created database, that is SQL intro. If I scroll down, there you go, you can see the name here, SQL intro. Okay, now within this database we'll create a table called employee details. Now this will have the details of some employees. So let me first show you how to create a table that will be present inside the SQL intro database. So I'll use the command create table and then I'll give my table name, that is going to be employee_details. Next, the syntax is to give the column names. So my first column would be the name column, which is basically the employee name, followed by the data type for this column. Since name is a text column, so I'll use varchar and I'll give a value of 25. So it can hold only 25 characters. Okay. Next, I also want the age of the employee. Now age is always an integer, so I'll give int. Okay. Then we can have the gender of the employee. So gender can be represented as F or M, F for female and M for male. So I'm using the char data type or character data type and I'll give the value as 1. Then let's have the date of join or DOJ, and this is going to be of data type date. Alright. Next, we'll have the city name, that is the city to which the employee belongs to. So again, this is going to be varchar 15. Finally, we'll have a salary column, and salary we'll keep it as float, since salary can be in decimal numbers as well. Now I'll give a semicolon. Alright, so let me just quickly run through it. So first I wrote my create command, then the table, which is also a keyword, followed by the table name, which is employee details here, and then we gave the column names such as name, age, this gender, date of join, city and salary. For each of the columns we also give the data type. Alright, so let me just run it. Okay, so here you can see we have successfully created our first table. Now you can use the describe command to see the structure of the table. I'll write describe emp_details. If I run this, there you go. So under field you can see the column names, then you have the data types. Null represents if the table can accept null values or not, and these are basically empty and we haven't set any default constraint. Alright, moving ahead. Now let's learn to add data to our table using the insert command. So on a notepad I have already written my insert statement, so let me just copy it and then I'll explain it one by one. Alright, so if you see this, so we have used an insert into statement or a command followed by the table name, that is emp details. Then this is the syntax. Using values, I have passed in all the records. So first we have Jimmy, which is the name of the employee. Then we have 35, which basically represents the age. Then M means the gender or the sex. Then we have the date of join. Next we have the city to which the employee belongs to. And finally we have the salary of the employee. So this particular information represents one record or a tuple. Similarly, the next employee we have is Shane. You can see the age and other information. Then we have Mary, this Dwayne, Sarah and Amy. Alright, so let me go ahead and run this. So this will help you insert the values in the table that you have created. You can see we have successfully inserted 6 records. Now to display the records, let me use the select statement. So I'm using select star from emp underscore details. If I run this, you can see my table here and the values it has. So we have the name column, the age column, the state of join, city, salary, and these are the values that you can see here. Moving ahead, now let's say you want to see the unique city names present in the table. So in this case, you can use the distinct keyword along with the column name in the select statement. So let me show you how you can print the distinct city names that are present in our table. Now if you notice this table clearly, we have Chicago, Seattle, Boston, Austin, there's New York, and there's Seattle repeated again. So I only want to print the unique values. So for that, I can write my select statement as select distinct. Then I'll give my column name, which is city, from my table name, that is emp details. If I run this, you can see my query has returned 5 rows and these are the values. So we have Chicago, Seattle, which was repeated twice, is just been shown once. Then we have Boston, Austin and New York. Now let's see how you can use inbuilt aggregate functions in SQL. So suppose you want to count the number of employees in the table. In that case, you can use the count function in the select statement. So let me show you how to do that. So I'll write select. I'll use my function name, that is count. Now since I want to know the total number of employees, I'm going to use their name inside the brackets from employee underscore details. Now if I run this, this will return the total number of employees that are present in the table. So we have 6 employees in total. Now if you see here in the result, it says count name. Now this column is actually not readable at all. So what SQL provides is something called as an alias name. So you can give an alias to the resultant output. So here I can write select count of name and use an alias as I can give an alias as count underscore name and run this statement again. There you go. You can see here in the resultant output we have the column name as count name, which was our alias name. Now suppose you want to get the total sum of salaries, you can use another aggregate function called sum. So I'll write my select statement, and this time instead of count I'm going to write sum. And since I want to find the sum of salaries, so inside the bracket I'll give my salary column from my table name, that is employee details. If I run this, this will result in the total sum of salaries. So basically it adds up all the salaries that were present in the salary column. Now let's say you want to find the average salary. So instead of sum, you can write the average function, which is avg. So this will give you the average salary from the column salary. So you can see it here, this says average salary. Now if you want, you can give an alias name to this as well. Now you can select specific columns from the table by using the column names in the select statement. So initially we were selecting all the columns. For example, like you saw here, the star represents that we want to see all the columns from the employee details table. Now suppose you want to see only specific columns, you can mention those column names in the select statement. So let's say I want to select just the name, age and the city column from my table, that is employee details. So this will result in displaying only the name, age and city column from the table. If I run it, there you go. It has given only 3 columns to me. Now SQL has a where clause to filter rows based on a particular condition. So if you want to filter your table based on specific conditions, you can use where clause. Now where clause comes after you give your table name. So suppose you want to find the employees with age greater than 30. In this case you can use a where clause. So let me show you how to do it. I'll write select star from my table name, that is employee details, and after this I'll use my where clause. So I'll write where age greater than 30. If I run this, it will give me the output where the age is only greater than 30. So it excluded everything that is less than 30. So we have 4 employees whose age is greater than 30 here. Now suppose you want to find only female employees from the table, you can also use a where clause here. So I'll write select, let's say I want only the name, the gender which is sex here, comma city from my table, that is employee details, where I'll give my column name, that is sex, is equal to, since I want only the female employees, I'll give F and run this statement. Okay, you can see here our employee table has 3 female employees. Now suppose you want to find the details of the employees who belong to Chicago or Austin. In this case you can use the OR operator. Now the OR operator in SQL displays a record if any of the conditions separated by OR is true. So let me show you what I mean. So since I want the employees who are from Chicago and Austin, I can use an OR operator. So I'll write select star from emp details, which is my table name. Then I'll give my where clause where city equal to, I'll give my city name as Chicago, and then I'm going to use the OR operator, or city equal to, I'll write Austin. I'll give a semicolon and let me run it. There you go. So in the output you can see all the employees who belong to the city Chicago and Austin. Now there is another way to write the same SQL query. So you can use an in operator to specify multiple conditions. So let me just copy this, and instead of using the OR operator, this time I'm going to use the in operator. So I'll delete this. After the where clause I'm going to write where city and use the in operator. Inside bracket I'll give my city names as Chicago and I want Austin. So I'll give a comma and write my next city name, that is Austin. So this query is exactly the same that we wrote on top. Let me run this. You will get the same output. There you go. So we have Jimmy and Dwayne who are from Chicago and Austin respectively. Now SQL provides the between operator that selects values within a given range. The values can be numbers, text or dates. Now suppose you want to find the employees whose date of join was between 1st of Jan 2000 and 31st of December 2010. So let me show you how to do it. I'll write select star from emp details where my date of join, that is DOJ, between, I'll give my two date values, that is 1st of Jan 2000 and I'll give my second value, the date value, that is 31st of December 2010. So every employee who has joined between these two dates will be displayed in the output. If I run it, we have two employees who had joined between 2000 and 2010. So we have Jimmy and Mary here who had joined in 2005 and 2009 respectively. Alright. Now in where clause, you can use the AND operator to specify multiple conditions. Now the AND operator displays a record if all the conditions separated by AND are true. So let me show you an example. I'll write select star from employee details table where I want the age to be greater than 30 and I want sex to be male. Alright, so here you can see I have specified two conditions. So if both the conditions are true, only then it will result in an output. If I run it, you can see there are two employees who are male and their age is greater than 30. Now let's talk about the group by statement in SQL. So the group by statement groups rows that have the same values into summary rows. Like for example, you want to find the average salary of customers in each department. Now the group by statement is often used with aggregate functions such as count, sum and average to group the result set into one or more columns. Let's say we want to find the total salary of employees based on their gender. So in this case you can use the group by clause. So I'll write select, let's say sex, comma, I want to find the total sum of salary as I'll give an alias name, let's say total salary from my table name, that is employee details. Next I'm going to group it by sex. Okay, let me run it. There you go. So we have two genders, male and female, and here you can see the total salary. So what this SQL statement did was, first it grouped all the employees based on the gender and then it found the total salary. Now SQL provides the order by keyword to sort the result set in ascending or descending order. Now the order by keyword sorts the records in ascending order by default. To sort the records in descending order, you can use the DESC keyword. So let's say I want to sort my employee details table in terms of salary. So I'll write select star from emp underscore details and I'll use my order by clause on the salary column. So this will sort all the records in ascending order of their salary, which is by default. You can see the salary column is sorted in ascending order. Now suppose you want to sort the salary column and display it in descending order, you can use this keyword, that is DESC. Let me run it. You can see the output. Now this time the salary is sorted in descending order and you have the other values as well. Now let me show you some basic operations that you can do using the select statement. So suppose I write select and do an addition operation, let's say 10 plus 20, and I'll give an alias name as addition. If I run this, it will give me the sum of 10 and 20, that is 30. Similarly, you can use the subtraction operator and you can change the alias name as, let's say, subtract. Let's run it. You get minus 10. Now there are some basic inbuilt functions. There are a lot of inbuilt functions in SQL, but here I'll show you a few. Suppose you want to find the length of a text or a string, you can use the length function. So I'll write select and then use the length function. I'll hit tab to autocomplete. Let's say I want to find the length of country India and I'll give an alias as total length. If I run it, you see here it returns 5 because there are 5 letters in India. There's another function called repeat. So let me show you how repeat works. So I'll write select repeat. Let's say I want to repeat the symbol that is at the rate. I'll put it in single quotes because it is a text character, and I want to repeat this character for 10 times. Close the bracket and let's run it. You can see here in the output it has printed @ 10 times. You can count it. Alright. Now let's say you want to convert a text or a string to uppercase or lowercase. You can do that as well. So I'll write select and use the function called upper. Let's say I want to convert my string, that is India, to uppercase. I'm not giving in any alias name. If I run this, see, my input was capital I and everything else was in small letter. In the output you can see it is converted my input to all caps. Similarly, you can change this. Let's say you want to print something in lowercase, you can use the lower function. Let's say this time everything is in uppercase. If I run it, it converts India to lowercase. Now let's explore a few date and time functions. Let's say you want to find the current date. There's a function called CUR, which stands for current, and this is the function I'm talking about, which is current date. If I run this, you will get the current date, that is 28th of Jan 2021. And let's say you want to extract the day from a date value, so you can use the day function. Let's say I'll use day and I want to find the day from my current date. If I run this, you get 28, which is today's day. Now similarly, you can also display the current date and time. So for that you can use a function that is called now. So this will return the current date and time. You can see this is the date value and then we have the current time. Alright, and this brings us to the end of our demo session. So let me just scroll through whatever we have learned. So first I showed you how you can see the databases present in MySQL. Then we used one of the databases and checked the tables in it. Then we created another database called SQL Intro for our demo purpose. We used that database and then we created this table called employee details with column names like name, integer, the sex, date of join, city and salary. I showed you the structure of the database. Let me run this again so you get an idea. You can see this was the structure of our table. Then we went ahead and inserted a few records. So we inserted records for 6 employees. So you have the employee name, the age, the gender, the date of join, the city to which the employee belongs to, and the salary of the employee. Then we saw how you can use the select statement and display all the columns present in the table. We learned how you can display the unique city names. We learned how to use different aggregate functions like count, average and sum. Then we learned how you could display specific columns from the table. We learned how to use where clause. Then we used an or operator. We learned about in operator, the between operator. Then we used an and operator to select multiple conditions. Finally, we learnt about group by, order by and some basic SQL operations. Now it's time to explore some string functions in MySQL. So I have given a comment, string functions. First, let's say you want to convert a certain string into uppercase. So I can write select. The function I'll use is upper, and within this function you can pass in the string. Let's say I'll write India. If you want, you can give an alias name as, let's say, uppercase. I'll give a semicolon and let's run it. There you go. So my input was in sentence case, and using the upper function we have converted everything into uppercase. Similarly, let me just copy this and I'll show you. If you want to convert a string into a lowercase, you can use the lower function. I'll run this. You can see the result. Everything is in lowercase now. Of course, I need to change the alias name to lowercase. Now instead of using lower as the function, there is another function that MySQL provides, which is called the L case. So I'll just edit this and write L case, and let's say I'll write India in uppercase. Let's run it. It returns me the same result. Cool. Now moving on, let's say you want to find the length of a string. You can use the character length function. I'll write select, use the function character length, and I'm again going to pass in my string as India as, let's say, total length. Let's run it. This time I'm going to hit Control Enter to run my SQL command. There you go. It has given us the right result, which is 5, because India has 5 characters in it. Now these functions you can also apply on a table. Now let me show you how to do it. Let's say we already have the students table and you want to find the length of each of the student names. So here you can pass stu underscore name, and you can give the same alias name, let's say total length, and then you can write from table name, that is students. If I run this, you can see the output. It has given me total 20 rows of information. This is not readable actually. Let me also display these student names so that we can compare their length. Alright, I'll run this again, and now you can see the result. So Joseph has 6 characters, Nilesh has 6, Vipul has 5, Anubhav has 7. Similarly, if you see, Akshay has 6, Tanishq has 7, Raghav has 6, Cummins has 7, Rabada has 6, so on and so forth. Now instead of using this character length, you can also use the function char length. It will work the same way. Let's see the result. There you go. It has given us the same result. You can either use character length or char length. Now there's another very interesting function called concat. So the concat function adds 2 or more expressions together. Let's say I'll write select. I'll use the function concatenate. The function is actually concat, and I'm going to pass in my string values. Let's say India is in Asia. Let's run this and see our result. You can see here it has concatenated everything. Let us make it more readable. I'll give a space in between so that you can read it clearly. Now this is much more readable. India is in Asia, and if you want, you can give an alias name as well, as let's say merged. There you go. Now the same concat operation you can also perform on a table. I'm going to use the same students table. Let's say I want to return the student ID followed by the student name, and then I am going to merge the student name followed by a space followed by the age of the student, and I can give an alias as, let's say, name underscore age from my table, that is students. Let's see how this works. Okay, you see here the result is very clear. We have the student ID, the student name, and the concatenated column that we created, which was name underscore age, where we have the student name with a space followed by the age of the student. If I scroll down, you can see the rest of the results. Cool. Now moving ahead, let's see how the reverse function works in MySQL. So the MySQL reverse function returns a string with the characters printed in reverse order. So suppose I write select reverse, I'll use the same string again. Let's say I have India. Let's run it. You will see all the characters printed in reverse order. Again, you can perform the same operation on a table as well. Let's say I'll write select reverse and I'll pass in the column as student name from my table, that is students. Let's run it. It gives you 20 students and all the names have been printed in reverse order. Okay. Now let's see what the replace function does. So the replace function replaces all occurrences of a substring within a string within a new substring. So let me show you what I mean. I'll write select replace. I'll pass in my input string, which is, let's say orange is a vegetable, which is ideally incorrect. I'm purposely writing this so that I can replace the word vegetable with fruit. Okay, so what this replace function does is it is going to find where my word vegetable is within the string, my input string, and it is going to replace my word vegetable with fruit. Let's run it and see the output. There you go. Now this is correct, which is orange is a fruit. Alright. Now MySQL also provides some trim functions. You can use the left trim, right trim, and just the trim function. So let me show you how this left trim works. Left trim or L trim removes the leading space characters from a string passed as an argument. So say I write select, I'll use the left trim function, which is L trim, and then I'm going to purposely give a few spaces in the beginning of the string. I'll give a word, let's say India, and then I'll give some space after the word India, and see how the L trim works. If I run this, it gives me India, which is fair enough. But before that, let's first find the length of my string. So I'll use my length function here, and within this function I am going to find the length of my string, which has India along with some leading and trailing spaces. I'll paste this here, give a semicolon, and I'll run it. Okay, so the entire string is 17 characters long, or the length of the string is 17. Now say I use ltrim on my same string, what it returns me is India, and if I run length over it, you can see the difference, as in you can see how many spaces were deleted from the left of the string. You can see here, now it says 17, and I'm going to use ltrim. Let's see the difference. It gives me 12. The reason being it has deleted 5 spaces from the left. You can count it, 1, 2, 3, 4 and 5. So 17 minus 5 is 12, which is correct. Similarly, you can use the rtrim function, which removes the trailing spaces from a string. Trailing spaces are these spaces. When you use left trim, it deletes the leading spaces, which is this. Now let me just replace ltrim with rtrim, which stands for right trim, and see the result. So the length is 10 now. The reason being it has deleted 7 spaces from the right of the string. If you can count it, 1, 2, 3, 4, 5, 6 and 7. Cool. You can also use the trim function, which will delete both the leading and the trailing spaces. So here, if I just write trim and I'll run it, it gives me 5. because India is total 5 characters long and it has deleted all the leading and the trailing spaces. Alright. There's also a function called position in MySQL. The position function returns the position of the first occurrence of a substring in a string. So if the substring is not found with the original string, the function will return 0. So let's say I'll write select position. I want to find where fruit is in my string, that is orange is a fruit. I'll give an alias as name. There's some error here. This should be within double quotes. Now let's run it and see the result. Okay, it says at the 13th place or at the 13th position we have the word fruit in our string, which is orange is a fruit. Now the final function we are going to see is called ASCII. So the ASCII function returns the ASCII value for a specific character. Let's say I write select ASCII of the letter small a. If I run this, it will give me the ASCII value, which is 97. Let's say you want to find the ASCII value of 4. Let's see the result. It gives me 52. Alright. In this session, we are going to learn two important SQL statements or clauses that are widely used, that is group by and having. First, we'll understand the basics of group by and having, and then jump into MySQL Workbench to implement these statements. So let's begin. First, what is group by in SQL? So the group by statement or clause groups records into summary rows and returns one record for each group. It groups the rows with the same group by item expressions and computes aggregate functions for the resulting group. A group by clause is a part of select expression. In each group, no two rows have the same value for the grouping column or columns. Now below, you can see the syntax of group by. So first we have the select statement, and then followed by the column names that we want to select. From, we have the table name, followed by the where condition, and next we have the group by clause, and here we include the column names. Finally we have the order by and the column names. Now here is an example of the group by clause. So we want to find the average salary of employees for each department. So here you can see we have the employees table. It has the employee ID, the employee name, the age of the employee, we have the gender, the date on which the employee had joined the company. Then we have the department to which each of these employees belong to. We have the city to which the employees belong to, and then we have the salary in dollars. So actually we'll be using this employees table on MySQL Workbench as well. So if you were to find the average salary of employees in each department, so this is how your SQL query with group by clause would look like. So we have selected department, and then we are using an aggregate function, that is AVG, which is average, and we have chosen the salary column, and here we have given an alias name, which is average underscore salary, which appears in the output. You can see here from employees, and we have grouped it by department. So here in the output you can see we have the department names and the average salary of the employees in each department. Now let me take you to my MySQL Workbench, where we will implement group by and solve specific problems. Okay, so I am on my MySQL Workbench. So let me make my connection first. I'll enter the password. So this will open my SQL editor. So first of all, let me check the databases that I have. So I'll use my query, that is show databases. Let's run it. Okay, you can see we have a list of databases here. I'm going to use my SQL underscore intro database. So I'll write use SQL underscore intro. So this will take us inside this database. I'll run it. Alright. Now you can check the tables that are present in SQL underscore intro database. If I write show tables, you can see the list of tables that are already present in this database. To do our demo and understand group by as well as having, let me first create an employee table. So I'll write create table employees. Next, I'll give my column name as employee underscore ID, which is the ID for each employee. I'll give my data type as integer and I'll assign employee ID as my primary key. Next, I'll give employee underscore name and my data type would be varchar. I'll give the size as 25. My third column would be the age column. Age would obviously be an integer. Then I have my gender column. I'll use character data type and assign a value of 1 or size of 1. Next, we have the date of join and the data type will be date. We have the department column as well. This is going to be of varchar and 20 will be the size. Next, we have the city column, which is actually the city to which the employee belongs to. And finally, we have the salary column, which will have the salary for all the employees. Okay, now let me select and run this. You can see here we have successfully created our table. Now to check if our table was created or not, you can use the describe command. I'll write describe employees. You can see the structure of the table so far. Alright, now it's time for us to insert a few records into this employees table. So I'll write insert into employees and I'll copy paste the records which I have already written on a notepad. So let me show you. So this is my EMP notepad and you can see I have already put the information for all the employees. So let me just copy this and we'll paste it here. Alright, let me go to the top and verify if all the records are fine. Alright, so let's run our insert query. Okay, so you can see here we have inserted 20 rows of information. And now let's check the table information or the records that are present in our employees table. I'll write select star from employees. If I run it, you can see here I have my employee ID, the employee name, age, gender, we have the city, salary, and in total we have inserted 20 records. Now let me run a few SQL commands to check how the structure of our table is. Let's say I want to see the distinct cities that are present in our table. So I'll write select distinct city from employees. If I run this, you see here there are total 8 different cities present in our employees table. So we have Chicago, there's Seattle, Boston, we have New York, Miami and Detroit as well. Now let's say you want to know the total number of departments that are present. So you can use distinct department. If I run this, alright, you can see we have 7 rows returned and here are the department names. So we have sales, marketing, product, tech, IT, finance and HR. Alright, now let me show you another SQL command. Now this is to use an aggregate function. So I want to find the average age of all the employees from the table. So I can write select avg, which is the aggregate function for average. Inside that I have passed my age column from employees. If I run this, So the average age of all the employees in our table is 33.35. Now, say you want to find the average age of employees in each department. So for this, you need to use the group by clause. I'll give a comment here. I want to find the average age in each department. So I'll write select department, comma, I'll write average of age from employees group by department. Now if I run this, you can see here we have our 7 departments on the left, and on the right you can see the average age of employees in each of these departments. Now you can see here in the output it says AVG of age, which is not readable, so I can give an alias name as average age. Alright, I can bring this down, and if you want you can round the values also. So you can round the decimal places, so I'll use a round function before the average function, and the round function takes 2 parameters. One is the variable and the decimal place you want to round it to. So if I run this, there you go. You can see here we have the average age of all the employees in each of these departments. Alright. Now suppose you want to find the total salary of all the employees for each department. So you can write select department, comma. Now I want the total salary, so I'll use the sum function and I'll pass my column as salary from employees group by department. Let's run this query. You can see here in the output we have the different departments, and on the right you can see the total salary of all the employees in each of these departments. Now here also you can give an alias name as total underscore salary. Let's run it again, and you can see the output here. Alright, now moving ahead, you can also use the order by clause along with the group by clause. Let's say you want to find the total number of employees in each city and group it in the order of employee ID. So to do this, I can use my select query. I'll write select count of, let's say, employee ID, and I want to know the city as well, from employees group by city, and next you can use the order by clause. I'll write order by count of employee ID, and I'll write DESC, which stands for descending. If I run this query, you can see here on the left you have the count of employees, and on the right you can see the city names. So in Chicago we had the highest number of employees working, that was 4. Then we had Seattle, Houston, Boston, Austin, and the remaining also had 2 employees. So in this case we have ordered our result based on the count of employee ID in descending order. So we have the highest number appearing at the top and then followed by the lowest. Okay, now let's explore another example. Suppose we want to find the number of employees that joined the company each year. We can use the year function on the date of joining column. Then we can count the employee IDs and group the result by each year. So let me show you how to do it. So I'll write select. I'm going to extract year from the date of join column. I'll give an alias as year. Next, I'll count the employee ID from my table name, that is employees, and I am going to group it by year, date of join. I give a semicolon. Alright, so let's run this. Great. You see here in the result we have the year that we have extracted from the date of join column, and on the right you can see the total number of employees that joined the company each year. So we have in 2005 there was 1 employee. Similarly, we have in 2009 there were 2 employees. If I scroll down, you have information of other years as well. Now if you want, you can order this as well based on year or count. Okay. Now you can also use the group by to join 2 or more tables together. So to show you this operation, let me first create a sales table. So I'll write create table sales, and the sales table will have columns such as the product ID, which is going to be of integer type. Then we have the selling price of the product. Now this will be a float value. Then we have the quantity sold for each of the products. So I'll write quantity will be of integer type. Next we have the state in which the item was sold, and state I'll put it as varchar and give the size as 20. Let's run this so that we'll create our sales table. Alright, so we have successfully created our sales table. Next we need to insert a few values to our sales table. So I have already written the records in a notepad. Let me show you. Okay, so here you can see I have my sales text file. Let me just copy these information. I'll just paste it on the query editor. Okay, now let me go ahead and run this insert command. Alright, so you can see here we have successfully inserted 9 rows of information. So let me just run it through what we have inserted. So the first column is the product ID column. Then we have the selling price at which this product was sold. Then we have the quantity that was sold and in which state it was sold. So we have California, Texas, Alaska. Then we have another product ID which is 123, and these are the states in which the products were sold. So let me just confirm with the select statement. I'll write select star from sales. If I run this, you can see we have successfully created our table. Okay. Now suppose you want to find the revenue for both the product IDs 1 to 1 and let's say 1 to 3, since we have just 2 product IDs here. So for that you can use the select query. So I'll write select product ID. Next I want to calculate the revenue. So revenue is nothing but selling price multiplied by the quantity. So I'll use the sum function to find the total revenue, and inside the sum function I'll use my selling price column multiplied by my quantity column. I'll give this an alias name as revenue from my table name, that is sales. Finally I'll group it by product ID. Let's run it. There you go. So here you can see we have the 2 product IDs 1 to 1 and 1 to 3, and here you can see the revenue that was generated from these 2 products. Alright, now let's say we have to find the total profit that was made from both the products 1 to 1 and 1 to 3. So for that I'll create another table. Now this table will have the cost price of both the products. So let me create the table first. I'll write create table. Let's say the table name is C product, which stands for the cost price of the products. I'll give my first column as product ID. This will be an integer, and I'll have my second column as cost price. Cost price will have floating type values. Let's run this. So we have successfully created our product cost table. Now let me insert a few values into the C product table. So I'll write insert into C underscore product. I'll give my values for 1 to 1. Let's say the cost price was $270 for each, and next we have my product as 1, 2, 3, and let's say the cost price for product 1, 2, 3 was $250. Let's insert these two values. Okay. Next, we'll join our sales table and the product cost table. So this will give us the profit that was generated for each of the products. So I'll write select C dot product underscore ID, comma, I'll write sum S dot sell underscore price. Now here C and S are alias names. So if I subtract my cost price from the selling price, that will return the profit that was generated. I'll multiply this with S dot quantity, close the bracket. I'll give an alias name as profit from sales as S. So here S stands for the sales table. I'm going to use inner join C underscore product table, as the alias name should be C, where S dot product underscore ID is equal to C dot product underscore ID. We are using product underscore ID because this column is the common column to both the tables. And finally, I am going to group it by C dot product underscore ID. Alright. So let me tell you what I have done here. So I am selecting the product ID. Next, I am calculating the profit by subtracting the cost price from the selling price, and I have multiplied the quantity column. I am using an inner join to connect my sales and the product cost table, and I am joining on the column that is product ID, and I have grouped it by C dot product ID. Let's run this. There you go. So here you can see for product ID 1 to 1, we made a profit of $1,100, and for product ID 1 to 3, we made a profit of $840. So now that we have learnt group by in detail, let's learn about the having clause in SQL. The having clause in SQL operates on grouped records and returns rows where aggregate function results matched with given conditions only. So now having and where clause are kind of similar, but where clause can't be used with an aggregate function. So here you can see the syntax of having clause. You have the select statement followed by the column names from the table name, then we have the where conditions, next we have the group by, finally we have having, and at last we have order by column names. So you can see here we have a question at hand. We want to find the cities where there are more than 2 employees. So you can see the employee table that we had used in our group by clause as well. So if you were to find the cities where there are more than 2 employees, so this is how your SQL query should look like. So we have selected the employee ID and we are finding out the count using the count function. Next we have selected the city column. From employees, we have grouped it by city and then we have used our having clause. So we have given our condition having count of employee ID should be greater than 2. So if you see the output, we have the different city names, and these were the cities where the count of employees was greater than 2. Alright, so let's go to our MySQL workbench and implement how having works. So suppose you want to find those departments where the average salary is greater than $75,000. You can use the having clause for this. So let me first run my table, which is employees. If I run this, you can see we had inserted 20 rows of information, and the last column we had was salary. So the question we have is, we want to find those departments where the average salary is greater than $75,000. So let me show you how to do it. So I'll write select department, comma, I'll use the aggregate function, that is average salary. I'll give an alias name as avg underscore salary from employees. Next, we'll use the group by clause, and I want to group it by each department, and then I'm going to write my having clause. So in having clause, I'll use my condition, that is having average of salary greater than $75,000. Let's run it and see the output. There you go. So here you can see there were total 3 departments in the company, that is sales, finance and HR, where the average salary is greater than $75,000. Okay. Next, let's say you want to find the cities where the total salary is greater than $200,000. So this will again be a simple SQL query. So I'll write select city, comma, I want to find the total salary, so I'll use the sum function, and I'll pass my column as salary, as I'll give a alias name as total from employees group by city, and then I am going to use my having clause. I'll pass in my condition as having sum of salary greater than $200,000. Alright, so let's run this query. There you go. So the different cities are Chicago, Seattle and Houston, where the total salary was greater than $200,000. Now suppose you want to find the departments that have more than 2 employees. So let's see how to do it. I'll write select department, comma, this time since I want to find the number of employees, I'm going to use the count function. I'll write count star as employee underscore count or emp underscore count, which is my alias name, from employees. Next, I'll group it by department, having, I'll give my condition count star greater than 2. Let's run this. Okay, so you have departments such as sales, product, tech and IT, where there are more than 2 employees. Okay, now you can also use a where clause along with the having clause in an SQL statement. So suppose I want to find the cities that have more than 2 employees apart from Houston. So I can write my query as select city, comma, count star as emp count from employees, where I'll give my condition city not equal to Houston. I'll put it in double quotes since I don't want to see the information regarding Houston. I'll group it by city having count of employees greater than 2. So if I run this query, you see we have information for Chicago and Seattle only, and we have excluded the information for Houston. Now you may also use aggregate functions in the having clause that does not appear in the select clause. So if I want to find the total number of employees for each department that have an average salary greater than $75,000, I can write it something like this. So select department, comma, count star as emp count from employees group by department, and in the having clause I am going to provide the column name that is not present in the select expression. So I'll write having average salary greater than 75,000. This is another way to use the having clause. Let's run this. Alright, you can see we have department sales, finance and HR, and you can see the employee count where the average salary was greater than 75,000. Okay. So let me run you from the beginning what we did in our demo. So first we created a table called employee, then we inserted 20 records to this table. Next we explored a few SQL commands like distinct, then we used average, and finally we started with our group by clause, followed by looking at how group by can be used along with another table, and we joined two tables, that was sales and product cost table, to find out the profit. Then you learned how to use the having clause. So we explored several different questions and learned how to use having in SQL. In this session we will learn about joins in SQL. Joins are really important when you have to deal with data that is present on multiple tables. I'll help you understand the basics of joins and make you learn the different types of joins with hands-on demonstrations on MySQL Workbench. So let's get started with what are joins in SQL. SQL join statement or command is often used to fetch data present in multiple tables. SQL joins are used to combine rows of data from two or more tables based on a common field or column between them. Now consider this example where we have two tables, an orders table and a customers table. Now the order table has information about the order ID, which is unique here. We have the order date, that is when the order was placed. Then we have the shipped date. This has information about the date on which the order was shipped. Then we have the product name, which basically is the names of different products. We have the status of delivery, whether the product was delivered or not, or whether it was cancelled. Then we have the quantity, which means the number of products that were ordered. And finally we have the price of each product. Similarly, we have another table called customers, and this customer table has information about the order ID, which is the foreign key here. Then we have the customer ID, which is the primary key for this table. We also have the phone number, customer name and address of the customers. Now suppose you want to find the phone numbers of customers who have ordered a laptop. Now to solve this problem, we need to join both the tables. The reason being, the phone numbers are present in the customers table, as you can see here, and laptop, which is the product name, is present in the orders table, which you can see it here. So using a join statement, you can find the phone numbers of customers who have ordered a laptop. Now let's see another problem where you need to find the customer names who have ordered a product in the last 30 days. In this case, we want the customer name present in the customers table and the last 30 days order information, which you can get from the order date column that is present in the orders table. Okay, now let's discuss the different types of joins one by one. So first we have an inner join. So the SQL inner join statement returns all the rows from multiple tables as long as the conditions are met. From the diagram above, you can see that there are two tables, A and B. A is the left table and B is the right table. The orange portion represents the output of an inner join, which means an inner join returns the common records from both the tables. Now you can see the syntax here. So we have the select command, and then we give the list of columns from table A, which you can see here is the left table, followed by the inner join keyword, and then the name of the table, that is B, on a common key column from both the tables A and B. Now let me take you to the MySQL workbench and show you how inner join works in reality. So here I'll type MySQL. You can see I have got MySQL workbench 8.0 version installed. I'll click on it. So it'll take some time to open. Okay, I'll click on this local instance, and here I'll give my password. Okay, so this is how an SQL editor on MySQL workbench looks like. So first of all, let me go ahead and create a new database. So I'll write create database. This is going to be my command, followed by the name of the database, that is going to be SQL_joins. If I give a semicolon and hit Ctrl Enter, this will create a new database. You can see here one row affected. Now you can check whether the database was created or not using show databases command. If I run it, here you can see I have SQL joins database created. Now I'll use this database, so I'll write use SQL_joins. Okay. Now to understand inner join, consider that there is a college, and in every college you have different teams for different sports such as cricket, football, basketball and others. So let's create two tables, cricket and football. So I'll write create table, and my table name is going to be cricket. Next, I'm going to create two columns in this table. The first column is going to be cricket ID. Then I'm going to give the data type as int and use the auto increment operator. I'm using auto increment because my cricket ID is going to be my primary key. Then I'm going to give the name of the students who are part of the cricket team, and for this I'll use varchar data type and give the length as 30. I'll give another comma and I'll assign my cricket ID as primary key. Within brackets I'll give cricket_ID. Cricket ID is nothing but a unique identifier for each of the players, like you have roll numbers in college. Okay, let me just run it. Alright, so we have successfully created our cricket table. Similarly, let me just copy this and I'll paste it here. I'll create another table called football. This will have the information of all the students who are part of the football team, and instead of cricket I am going to give this as football ID. Alright, and the name column will have the names of the students. I'll change my primary key to football ID. Alright, let me run this. Okay, so now we have also created our football table. The next step is to insert a few player names into both the tables. So I'll write my insert into command. First, let's load some data to our cricket table. So I'll write cricket and I'll give my name column followed by values, and here I'll give some names such as, let's say, Stuart. I'll give another comma. The next player I'll choose is, let's say, Michael. Similarly, I'll add a few more. Let's say we have Johnson. The fourth player I'll take is, let's say, Hayden. And finally we have, let's say, Fleming. Okay. Now I'll give a semicolon and run this. Okay, so let me just check if all the values were inserted properly. For this I'll use select star from table, that is cricket. If I run it, you can see I have created a table and have successfully inserted 5 rows of information. Now similarly, let's insert a few student names for our football table. So I'll change this to football, and obviously there would be students who will be part of both cricket and football team. So I'll keep a few repeated names. Let's say Stuart, Johnson, and let's say Hayden are part of both cricket and football team. Then we have, let's say, Langer, and let's say we have another player in the football team, that is Aston. I'll just run it. Okay, you can see there are no errors. So we have successfully inserted values to our football team as well. Let me just recheck it. I'll write select star from football. Alright, so we have 5 players in the football team as well. Okay, now the question is, suppose you want to find the students that are part of both the cricket and football team. In this case, you can use an inner join. So let me show you how to do it. So I'll write select star from cricket, as I'm using an alias name as C, which stands for cricket. Then I'm going to write inner join. My next table is going to be football as F, which is an alias name for the football table. Then I'm going to use the on command or operator, and then I'll give the common key, that is name here. So c.name is equal to f.name. So based on this name column from both the table, my inner join operation will be performed. So let's just run it. There you go. So Stuart, Johnson and Hayden are the only 3 students who are part of both the teams. Alright. Now you can also individually select each of the columns from both the tables. So let's say I write select c dot cricket underscore id, comma c dot name, comma f dot football underscore id, comma f dot name. From, I'll write cricket as C, inner join football as F on C dot name is equal to F dot name. Now if I run this, you see we get the same output here as well. Alright. Now let's explore another example to learn more about inner joins. So we have a database called classic models. Let me first use classic models. I'll run this. Okay, now let me just show the different tables that are part of classic tables. Alright, so here you can see there are tables like customers, there's employees, office, there's office details, orders, payments, products and product lines as well. Alright, so let me use my select statement to show what are the columns present in the products table. Okay, so this product table has information about different product names. You have the product code. Now this product code is unique here. We also have the product vendor, a little description about the product. Then we have the quantity in stock, buying price and MSRP. Let's see what we have in product lines. If I run it, you see here we have the product line, which is the primary key for this table. Then we have the textual description for each of the products. This is basically some sort of an advertisement. Alright, now suppose you want to find the product code, the product name and the text description for each of the products. You can join the products and product lines table. So let me show you how to do it. I'll write my select statement and choose my columns as product code. Then we have product name, and let's say I want the text description, so I'll write this column name. Okay, then I'll use from my first table, that is products, inner join product lines. I can use using the common key column, that is product line. Close the bracket, I'll give a semicolon, and if I run it, there you go. So you can see the different product codes. Then we have the different product names and the textual description for each of the products. So this we did by joining the products table and the product lines table. Alright. Now suppose you want to find the revenue generated from each product order and the status of the product. To do this task, we need to join three tables, that is orders, order details and products. So first let me show you what are the columns we have in these three tables. We have obviously seen for the products table. Now let me show you for orders and order details table. So I'll write select star from orders. If I run it, you can see it has information about the order number, the date on which the order was placed. We also have the shipment date. We also have the status column, which has information regarding whether the order was shipped or cancelled. Then we have some comments column. We also have the customer number who ordered this particular product. Similarly, let's check what we have under order details. So I'll write select star from order details. If I run it, you can see it has the order number, the product code, quantity of each product. We have the price of each product. Then we have the order line number. Okay. So using the product, orders and order details, let's perform an inner join. So I'll write select o dot order number, comma o dot status, comma I need the product name, which I'll take from the products table. So I'll write p dot product name. Now here O, P are all alias name for the tables, orders, products, and I'll use OD for order details, comma since we want to find the revenue, we actually need to find the product of quantity ordered into price of each product. So I'll use a sum function, and inside the sum function I'll give quantity ordered multiplied by the price of each item. I'll use an alias as revenue. Then I'll use my from clause, from orders as O, inner join order details as I'll use an alias name as OD, on I'll write O dot order number is equal to OD dot order number. I'll use another inner join, and this time we'll join the products table. So I'll write inner join products as P on P dot product code is equal to od dot product code. And finally, I'll use the group by clause and group it by order number. Alright, let me run this. Okay, there's some mistake here. We need to debug this. It says you have an error in your SQL syntax. Check the manual. Alright. Okay, I think the name of the tables is actually orders and not order. Alright, now let's run it. Okay, there's still some error. It says classic models dot product doesn't exist. So again, the product name is, the table name is products and not product. So let's run it again. Alright, there you go. So we have the order number, the status, the product name and the revenue. This we got it using inner join from 3 different tables. Now talking about left joins, the SQL left join statement returns all the rows from the left table and the matching rows from the right table. So if you see this diagram, you can see we have all the rows from the left table, that is A, and only the matching rows from the right table, that is B. So you can see this overlapped region, and the syntax for SQL left join is something like this. So you have the select statement and then you give the list of columns from table A, which is your left table. Then you use the left join keyword followed by the next table, that is table B, on the common key column. So you write A dot key is equal to B dot key. Okay, now in our classic models database we have 2 tables, customers and orders. So if you want to find the customer name and their order ID, you can use these 2 tables. So first let me show you the columns that are present in customers and orders. I think orders we have already seen. Let me first show you what's there in the customers table. Okay, so you can see we have the customer number, the name of the customer, then we have the contact last name, the contact first name, we have the phone number, then there's an address column. There are 2 address columns actually. We have the city name, the state, and we have other information as well. And similarly we have our orders table. So I'll write select start from orders. So I'll write select star from orders. If I run this, you can see these are the information available in the orders table. Okay, so let's perform a left join where we want to find the customer name and their order IDs. So I'll write select c dot customer name, or let's say first we'll choose the customer number, comma, then I want the customer name, so I'll write c dot customer name. Then we have the order number column which is present in the orders table, and let's say I also want to see the status. Then I'll give my left table, that is customers as C, left join, orders as O, on C dot customer number equal to O dot customer number. Let's run it. Okay, again there is some problem. Alright, so the table name is customers. Let's run it. So there's another mistake here. This is customer number, so B is missing. Cool. Let me run it. Alright, so here you can see we have the information regarding the customer number, then the respective customer names, we have the order number and the status of the shipment. So if I scroll down, you'll notice one thing. There are a few rows you can see which have null values. This means for customer number 125 and for this particular customer name there were no orders. And similarly, if I scroll down, you will find a few more null values. You can see here there are 2 null values here. For customer number 168 and 169, there were no orders available. Alright, Now to check those customers who haven't placed any orders, you can use the null operator. So what I'll do is here, I'll just continue with this. I'll use a where clause and write where order number is null. Now let me run this. Okay, so here you can see there are 24 customers from the table that don't have any orders in their names. Okay, now talking about right joins. So SQL right join statement returns all the rows from the right table and only matching rows from the left table. So here you can see we have our left table as A and the right table as B. So the right join will return all the rows from the right table and only the matching rows from the left table. Now talking about the syntax. So here you can see we have the select statement. Followed by the select statement, you will have the list of columns that you want to choose. From table A, right join table B on the common key column from both the tables. Alright. Now to show how right join works, I'll be using two tables, that is customers and employees. So let's see the rows of data that are present in the customer table first. So I'll write select star from customers. Let's run it. So here you have the customer number, the customer name. Then we have the phone number, the address of the customers. You also have the country to which the customer belongs to, the postal code, and the credit limit as well. Similarly, let's see for the employees table. Here I'll change customers to employees. Let's run it. Okay, so we have the employee number, the last name, the first name. We have the extension, the email ID, the job title, and also reports to here means the manager. Okay. So based on these two tables, we'll find the customer name, the phone number of the customer, and the email address of the employee, and join both the tables, that is customers and employees. So let me show you the command. So I'll write select c dot customer name, comma, then we have c dot phone. I'll give a space here. Next, I want the employee number from the employee table, so I'll write e dot employee number, comma, e dot email from customers as C, right join employees as E on e dot, my common key column is employee number here, so I'll write e dot employee number is equal to C dot, we have sales representatives employee number, and I'm also going to order it by the employee number column. Okay, so you can see I have my customer name selected from the customers table, the phone number of the customer, then we have the employee number and the email address. So let me run it. Okay, there's some problem. Alright, so the table name is customers actually. Let's run it once again. There you go. So you can see here we have all the values selected from our right table, which is the employees table. You can see right join employees, which means your employees table is to the right, and then we have the customer name and phone numbers of the customers from the customer table, which is actually your left table. So you have a few employee numbers such as 1002, there's 1056, which don't have any customer name or phone numbers. Okay, so there's another popular join which is very widely used in SQL, known as self joins. So self joins are used to join a table to itself. So in our database we have a table called employees. Let me show you the table first. Alright, so here you can see we have the employee number, the last name, the first name of the employee, we have the email ID, And here if you see, we have a column called reports 2. Now this you can think of as the manager column. So the way to read is, for example, for employee number 1056, the manager is 1002. So if you check for 1002, we have Dane Murphy. Then if I scroll down, let's say for employee number 1102, for employee number 1102, the manager is 1056. So here you can see who is at 1056. You have Mary Patterson. Similarly, if I scroll down, let's say for employee number 1188, we have the manager as 1143. Now if I check the table at 1143, we have Anthony Bow. So the employee Julie Firelli reports to Anthony Bow. Alright. Now suppose you want to know who is the reporting manager for each employee. So for that you can use a self join. So let me show you how to join this employees table. I'll write select, and then I'm going to use a function called concat. Within brackets I'll start with my alias name, that is m dot, then I'll write last name. I'm going to concat last name followed by a comma, then I'll have my first name. I'll close this bracket, and then I'm going to give my alias name, let's say manager, comma. Next I'm going to concat the same last name and first name, and this time I'm going to use a separate alias, let's say E, which stands for employee. So I'll write E dot last name, comma, and within single quotes I'll give my comma, and then I'll write E dot first name. I'll close this bracket. I'll give an alias as, let's say, employee. From, I'll write employees as E, inner join employees as M on M dot. I'll use my common key column as employee number, so I'll write M dot employee number is equal to E dot, here I'm going to use the reports 2 column, and then I'll order it by, let's say, manager. Okay, now let's run this. There you go. So you have your 2 columns as manager and employee. So for employee Louis Bonder, the manager is Gerard Bonder. Similarly, if I scroll down, you have there are multiple employees reporting to this particular manager. Similarly, we have our manager as Anthony Bow, and we have different employees who are reporting to this particular manager, and so on. Alright, now moving ahead. Now let's see what a full join is. So SQL full outer join statement returns all the rows when there is a match in either left or right table. Now you must remember that MySQL Workbench does not support full outer join by default, but there's a way to do it. So by default, this is how the syntax of full outer join looks like. Now this statement will work on other SQL databases like Microsoft SQL Server, but it won't work on MySQL Workbench. I'll show you the right way of using full outer join on MySQL Workbench. So to show full outer join, I'm going to first use a left join, and then we'll also use a right join, and finally we'll use a union operator. So the union operator is used to combine the result set of 2 or more select statements. So first of all, let me write C dot customer name. So for this example, I'm using the customer table and the order table, comma O dot order number. So I just want to know the customer name and the order number related to the customer. From I have customers as C, left join, I'll write orders as O on C dot customer number is equal to O dot customer number. Let me just copy this, and after this I am going to use my union operator. So union operator is used to merge results from two or more tables. So basically this performs a vertical join. And next I am going to use my right join operation. So here instead of left join I'll write right. Rest all looks fine. Let me just run it. There you go. So we have successfully run our full outer join operation. You can see we have the different customer names and the order that each customer had placed. Alright. So that brings us to the end of our demo session. So let me just run through whatever we did in this session. So first we created a database called SQL joins. Then we created two tables like cricket and football. Then we had inserted a few rows to each of these tables. Then we used this table to learn about inner join. Next we used a database called classic models. It had multiple tables, so we explored all of these tables like products, there was product lines, orders, customers and employees, and learned how to use inner join, left join, self join, right join as well as full outer join. In this video we will learn what is a subquery and look at the different types of subqueries. Then we'll learn subqueries with select statement followed by subqueries with insert statement. Moving further, we will learn subqueries with the update statement, and finally we look at subqueries with delete statement. All this we will be doing on our MySQL workbench. So before I begin, make sure to subscribe to the Simplilearn channel and hit the bell icon to never miss an update. So let's start with what is a subquery. So a subquery is a select query that is enclosed inside another query. So if I show you, this is how the basic structure of a subquery looks like. So here whatever is present inside the brackets is called as the inner query, and whatever is present outside is called the outer query. So first the inner query gets executed and the result is returned to the outer query, and then the outer query operation is performed. Alright, now let's see an example. So we have a question at hand, which is to write a SQL query to display department with maximum salary from employees table. So this is how our employees table looks like. It has the employee ID, the employee name, age, gender, we have the date of join, department, city and salary. Now to solve this query, my subquery would look like this. So I'll first select the department from my table, that is employees, where I'll use the condition salary equal to, and then I'll pass in my inner query, which is select max of salary from employees. So what this does is it will first return the maximum salary of the employees in the table. Then our outer query will get executed based on the salary returned from the inner query. So here the output is department sales has the maximum salary. So one of the employees from the sales department earns the highest or the maximum salary. If you see in our table, the employee is Joseph, who earns $115,000. Alright, and Joseph is from the sales department. Now let's see how this query works. So here we have another question, which is to find the name of the employee with maximum salary in the employees table. So this is our previous employees table that we saw, and to find the employee who has the maximum salary, my subquery would look something like this. So I'm selecting the employee name from my table, that is employees, where I'm using the condition salary equal to, and then I'm passing in my subquery or the inner query. So first I'm selecting the maximum salary. This will return a particular value that is the highest salary from the table. And if you see our table, the highest salary is $115,000. So our query becomes select employee name from employees where salary equal to $115,000. So the employee name is Joseph here, and that's the output. Now if you want to break it down, here you can see first the inner query gets executed. So our SQL query will first execute the inner query that is present inside brackets, select maximum salary from employees. The result is $115,000, and then based on the returned result, our outer query gets executed. So the query becomes select employee name from employees where salary equal to $115,000, and that employee is Joseph. Alright, now we'll learn the different types of subqueries. So you can write subqueries using select statement, update statement, delete, and insert statement. We'll explore each of this with the help of example on my MySQL workbench. So let's learn subqueries with the select statement. So subqueries are majorly used with the select statement, and this is how the syntax looks like. You select the column name from the table name, then you have the where condition followed by the columns that you want to pass, the operator, and inside that you have the subquery. So here is an example that we will perform on our MySQL workbench. So in this example, we want to select all the employees who have a salary less than average salary for all the employees. This is the output. So let's do this on my MySQL workbench. Alright, so let me log into my local instance. I'll give my password. Okay, so you can see I'm on my MySQL workbench. So let's start by writing our subquery using the select statement. Okay, so for this demo session, we'll be using a database that is subqueries. You can see it here. I have a database called subqueries. So I'll use this subqueries database, and we'll create a few tables as well. Okay, now if I run it, now we are inside the subqueries database. So let me just show you the tables that are present inside this database. I'll write show tables. If I run it, okay, there are two tables, employees and employees underscore B. We'll use this table throughout our demo session. Alright, now for our select subquery, we want to fetch the employee name, the department, and the salary whose salary is less than the average salary. So we will be using the employees table. So let me first show you the records and the columns we have in the employees table. So I'll write select star from employees and run it. Okay, you can see here we have 20 rows of information. We have the employee name, the employee ID, age, gender, date of join, department, city, and salary. So this is the same table that we saw in our slides. Okay, now for our subquery, I'll write select. I want to choose the employee name, the department, and the salary. There should be a comma here instead of a period. Next, I'll give my table name, that is employees, where my salary is less than, and after this I'll start my inner query or the subquery. I'll write select average salary. So I'm using the avg function to find the average salary of all the employees from my table, that is employees. If I give a semicolon and run this, you'll see the output. So we have total 12 employees in the table whose salary is less than the average salary. Now if you want, you can check the average salary. So the average salary is $75,350. Now the employees who have a salary less than the average salary, so these are the people. Alright, now moving back to our slides. Okay, now let's see how you can use subqueries with the insert statement. Now the insert statement uses the data written from the subquery to insert into another table. So this is how the syntax looks like. So you write insert into table name followed by select individual column. So star from the table, use the where clause, and then you give the operator followed by the inner query or the subquery. So here we will explore a table called products table. We are going to fetch few records from the products table based on a condition, that is the selling price of the product should be greater than $100. So only those records will fetch and put it in our orders table. Alright. So we are going to write this query on my MySQL workbench. So let's do it. I'll give my comment as update subquery. Alright. So first of all, let's create a table, that is products. So I'll write create table products. Then we'll give our column names. The first column would be the product ID of type integer. Then we have the column as item or the product, which is of type varchar 30. Next we have the selling price of that product. The selling price will be of type float. And finally we have another column which is called the product type. And again, product type is of the data type varchar. I'll give the size as 30, close the bracket and give a semicolon. Now let's just run it.
It's like an
okay, so we have successfully created our products table.
all the year that positive
Now
mind.
let's insert a few records to our products table. So I'll write insert into
Click here to watch
products,
similar. If you like here
followed
to
by
watch similar
values.
videos to nerd up and get certified, click
I'll
here.
give 4
Video.
records. The first product ID is 101. The product is, let's say, jewelry. Then the selling price is, let's say, $800, and the product type is, it's a luxury product. Next, let's insert one more product detail. The product ID is 102. The product is, let's say, t-shirt. The price is, let's say, $100, and the product type is non-luxury. Next, I'll just copy this to reduce our task. We'll edit this. The third product's ID is 103. The product is laptop, and let's say the price is $1,300, and it's a luxury product. I'll paste again, and finally I'll enter my fourth product, which is, let's say, table, and the price is $400, and it's a non-luxury product. I'll give a semicolon, and we'll insert these 4 records to our products table. You can see we have inserted 4 records. Let's just print it now. So I'll write select star from products. If I run it, you can see we have our 4 products ready. Now
there's a real need for innovation in cell therapy manufacturing. We see a tremendous benefit to bring parties together to collaborate. In this case, we're bringing together the academic excellence that exists in UCSF and Thermo Fisher's expertise in cell and gene therapies.
Compared to other therapy, cell therapy are curative. Instead of the other therapy like small molecules or antibody, they treat the symptom.
I believe it's the next big revolution in medicine, where we're going to move from drugs in vials to engineered cells that pinpoint disease and
finally we have the
reduction in the number of side effects that people with devastating diseases have.
Cell therapy is mostly used what we call for liquid tumors. But the next frontier is really getting into solid tumors.
Scientists at UCSF have developed very exciting therapies that may be effective against solid tumors. And so we're excited about the potential of these new therapies.
This is not a problem that can be addressed by one person or one company. It's something that needs to be done together.
Here at UCSF, we're one of the leading health research universities in the country.
While we are extraordinarily skilled at discovering new targets for therapeutic intervention and indeed actually discovering drugs, we are ill-prepared to actually develop those, let alone commercialize them.
We knew we needed a partner.
Thermo Fisher can work with our partners to help translate all of this exciting work done in the Collaboration Center into commercially available therapies.
The ability of those cell engineers to talk directly with the Thermo Fisher technicians and scientists who have the skills of taking those discoveries and manufacturing cells for human use, that close proximity can't be overstated. I think is going to be a unique collaboration, unlike virtually anything that I'm aware of, that will push this field further and faster.
Today, a lot of those cell therapy products are coming from patients. If the blood drawn, they're sent to a manufacturing facility, we produce the drug, we engineer the T cells, and we put them back in injects. So you can imagine the logistic takes.
So the ability to work closely with Thermo Fisher to take our inventions, optimize how they're manufactured, and then dose them into patients literally across the street at our Precision Cancer Hospital. That is truly unique.
This will be a resource for patients literally around the world, because we'll be doing first-in-kind human trials.
We've seen with many drugs from discovery to commercial, it takes many years.
Thermo Fisher is focused on addressing this challenge by working with our partners to develop more standardized approaches, with the ultimate goal of shortening therapeutic development timelines, driving down costs for customers, and helping to avoid failures on the path toward commercialization.
There's no better partner for us in this space than Thermo Fisher Scientific. I'm just incredibly excited to begin work on what I think is the next big revolution in medicine.
If I run it, there you go. So there were two products from our product table that were jewelry and laptop, which have a selling price greater than $1,000. So the selling price for jewelry was $1,800 and for laptop it was $1,300. So this is how you can use a subquery using the insert statement. Alright, now going back to our slides again. Alright, now let's see how you can use subqueries with the update statement. Now the subqueries can be used in conjunction with the update statement. So either single or multiple columns in a table can be updated when using a subquery with the update statement. So this is how the basic syntax of an update subquery looks like. So you write update table followed by the table name, you set the column name, you give the where operator, and then you write your inner subquery. So we are going to see an example where we will use this employees table, and using this employees table we will update the records of the salaries of the employees by multiplying it with a factor of 0.35 only for those employees which have age greater than 27. So we are going to use a new table called employees_b for this as well. So let's see how to do it. So I'll give my comment as update subquery. Before we see the subquery, let's see what we have in the table employees_b. This is basically a replica of the employees table. There you go. It has the same records that our employees table has. We are going to use both the employees table and the employees_b table to update our records. So I'll write update employees set salary equal to, let me bring this to the next line. I'll write set salary equal to salary multiplied by 0.35, where age in, then I'll write select age from my other table, that is employees_b, where age is greater than or equal to, let's say 27. Alright, so let me run through this query and tell you what we are going to do. So I'm going to update the records of the employees table specifically for the salary column. So I'm checking if the age is greater than 27, then we'll multiply the salaries of the employees with a factor of 0.35 in the employees table. Let me just run this, then we'll see our output. Okay, so it says 18 rows affected, which means there are total 18 employees in the table out of the 20 employees whose age is greater than 27. Now if you see, I'll write select star from employees. You can see the difference in the salaries. If I scroll to the right, you can see these are the updated salaries. Okay. Now if you check for employees who have an age less than or equal to 27, for example Marcus, whose age is 25, his salary is the same. We haven't updated his salary. Then if you see, if we have, okay, there is one more employee, Maya. We haven't updated the salary of Maya because the age is less than 27. Alright. Now let's go back to our slides again. As you can see, we got the same output on our MySQL workbench. Now let's explore how you can write subqueries with the delete statement. Now subqueries can again be used in conjunction with the delete statement. So this is how the basic syntax of a delete query using subquery would look like. You write delete from the table name, where clause, the operator value, followed by the inner query in within brackets. So here we are going to use the employees table, and what we are going to do is we'll delete the employees whose age is greater than or equal to 27. So let's see how you can do it. Alright, so I'll give my comment as delete subquery. So we'll follow the syntax that we saw. I'll write delete from my table name, that is employees. I'll write where age in, and then I'll start my inner query or the subquery. I'll write select age from employees underscore B, where age is, let's say, greater than or equal to 32, or let's say the age is less than or equal to 32. Close the bracket and I'll give my semicolon. Let me first run the inner query for you so that you get an idea of the employees who are less than 32 years of age. So there are 9 employees in the table who have an age less than or equal to 32. So we are going to delete their records. If I run this, okay, it says 9 records deleted. Now let's print or display what we have in the employees table. If I run this, there you go. So if you see the age table, we have total 11 employees now, and all their ages are greater than 32 because we have deleted all those employees who had an age less than or equal to 32. Okay, so let me show you from the beginning what we did. So first we used our subqueries database, then we used our employees table. So we started by looking at how you can use the subquery with a select statement. This should be insert instead of update. So we learned how to write an insert subquery. We use 2 tables, products and our orders table. Moving ahead, we saw how to write subqueries using the update command. So we updated the salaries of the employee by a factor of 0.35 for those who had an age greater than or equal to 27. And finally we saw how to use the subquery using the delete statement. So we deleted all those records for the employees whose age was less than or equal to 32. In this video, we will discuss an advanced SQL concept called triggers. We will learn what triggers are and how they can be used to solve problems. We'll look at how trigger queries are written on MySQL workbench. So let's get started. First, what are triggers in SQL? So a trigger is a user-defined SQL command that is invoked automatically when an event occurs. An event can be related to inserting, updating or deleting records in a table. In MySQL, triggers can be executed automatically by the Oracle server. Below is how the syntax of writing a trigger is. So you write create trigger followed by the trigger name. Now the trigger name should be a valid SQL name. Then we have the trigger time, the trigger event, and then on the name of the table. Then we write for each row begin followed by the list of SQL statements, and finally we write end. Now in the syntax, the trigger time represents either before or after an event, and a trigger event can be an insert, update or delete operation. Now let me take you to MySQL Workbench, where we will learn how to create triggers and explore more on how it works. So I am on MySQL Workbench. So first let me go ahead and create my connection. I'll give my password. Alright, now this will take you to my SQL editor. Okay, so first and foremost, let me create a new database called triggers. So I'll write my SQL command as create database triggers. Let me run this. Okay, so you can see here one row affected. I have created my database, that is triggers. Next, I'm going to move inside this database, so I'll write the command use triggers. Let's run this. Okay, now inside this triggers database we'll be creating our different tables. So let's check if we have any tables. I'll use the command show tables. Now you see there are no tables in this database. Alright, first let's see how before insert trigger works. So for before insert trigger, we'll create a table called customers and verify the age of each customer. So I'll give a comment before insert trigger. So let me go ahead and create my customers table. I'll write create table customers, and I'll give my column names as cust_id, which is customer ID. This is going to be an integer. Then we have the age of the customer. This is again an integer, and we'll have the name of the customer. The name of the customer will be of varchar type. I'll give the size as 30. Alright, let's create this table. Okay, so we have successfully created our customers table. Now moving ahead, I'm going to write my before insert trigger command. So we'll start with a delimiter. So a delimiter is a marker for the end of each command. Next, I'll write my create trigger followed by the trigger name. I'll give a valid trigger name such as age_verify. I'll write before trigger. It should be before insert on. My table name would be customers. Then I'll write for each row if new.age is less than 0, then set new.age equal to 0, which means while inserting your values to the age column, in case the age value is negative, we'll convert the age to 0. I'll give a semicolon and then I'll write end if. I'll give another semicolon and I'll close the delimiter. Now let me run this. Okay, so we have created our trigger. Now let's insert a few values onto customers. So I'll write insert into customers values 101, which is the customer ID. I'll give the age as 27 and let's say the name of the customer is James. Let's insert another record. Give the value as 102 and this time I'm purposely giving the age as -40, which is less than 0, so that you can see the output clearly. I've given the customer name as Amy. Let's insert 2 more records. The customer ID with 103 has an age of 32, and let's see the name is Ben. I'll give another comma, and finally we'll insert our 4th customer record. The customer ID is 104. The age I'm giving as -39, which is less than 0 again, and let's say the customer name is Angela. Alright, now let me run this. Okay, so we have successfully inserted 4 rows of information to our customers table. Now let's see the difference. Since we had created a age verify trigger which would change the values of the age column in case the age value is less than 0. So now that we have inserted 4 records to a customer, so let's see what we have in the customers table. Now let me run it. There you go. So if you see this, for those customers where the age was less than 0, such as 102 and 103, you can see here our trigger has automatically converted those values to 0. If you can see the trigger we had created, we had set our new age to 0 if the age was less than 0, and this is the output we get. So here we looked at how a before insert trigger works. Alright, now moving ahead, let's understand how an after insert trigger works. So I'll give a comment here as after insert trigger. Now in this example, we'll create 2 tables, customers and message. Now the trigger will be fired if the birthday column has a null value in the customers table. You will get a message to update your date of birth. Okay, so first let me create my customers table. Now since we already have one customers table, I'll name it as customers 1, and let me give the column names. So the first column would be the ID column. This is going to be an integer, and I'll use the auto increment parameter, and this will be my primary key as well. Next we'll have the name of the customer. This is going to be of type varchar, and I'll use not null constraint. Next we'll have the email ID of the customer. This is again going to be of varchar type, and the column we are interested in is the birthday column. So I'll write birth date. This is going to be of type date. Okay, so let's create our table. Alright, now we'll create our second table, which is going to be message. Let's create the columns. This will have ID, int, and I'll use the auto increment operator. Next we'll have the message ID. This is going to be of integer type. We'll have a column called message. This will be of varchar type, let's say 300 characters, and not null. And I'm going to set my primary keys as ID and message ID. Let's create our second table then. So we have some error here. Let's debug the error. Okay, so I forgot to close the bracket here. Alright, now let me run this table. Alright, so we have created our message table as well. Next I'll write my after insert trigger command. So I'll write delimiter, Next I'll use create trigger command. So I'll write create trigger. My trigger name would be check underscore null underscore date of birth. After insert on customers 1 for each row begin if new dot birth date is null, then we are going to insert into our message table. We'll give the columns as message ID and message values new.id, comma, I'm going to use the concat function where I'll give my message, let's say hi, followed by the name, followed by, let's say, please update your date of birth. Okay, now I'll write end if. I'll close the delimiter. Okay, so let me go to the top and recheck if we have created our trigger correctly. So I have my trigger name. After insert on customers 1 for each row begin if our new birthday has a null value, then we'll pass in a message saying hi, the name of the customer, then the message would be please update your date of birth. Alright, so let's run the trigger. Okay, now the next step is to insert a few records to customer table. So my name of the table is customers 1. Okay, I'll give the column names as name, email and birth. Okay, we'll pass in a few values. So our first customer's name, let's say, is Nancy, comma, I'll give my email ID, let's say nancy@abc.com. Now let's say I'm purposely passing the date of birth as null. I'll give a comma. My next customer, let's say the name of the customer is Ronald, and then I'll give the email ID such as ronald@xyz.com, and this time I'm going to pass in the date of birth, let's say 1998 November, and let's say 16th. Okay, now we'll add another customer, let's say Krish. We'll give the email ID of Krish, so krish@xyz.com, and let's say we'll give the date of birth as 1997 08/20, and finally we'll add one more record for another customer, let's say Alice. I'll give the email ID as alice@abc.com, and this time I'll purposely pass the date of birth as null. Alright, So let's run the insert query. Okay. Now let me display the message table for you so that you can see the output and how our after insert trigger works. There you go. So if you see this, we had inserted 4 rows of information, out of which the first customer ID and the fourth ID had null date of birth. So for those two values, you have the message as "Hi Nancy, please update your date of birth," and then you have "Hi Alice, please update your date of birth." Now you can give a space between hi and the name of the customer. Alright. Now moving ahead, let's understand how before update trigger works. So I'll give a comment here as before update. Okay. Now to show you how before update works, first we'll create a table called employees. Alright. So let me create my table, that is create table employees. I'll give my column as employee ID. This is going to be an integer type and it will be my primary key. Next we'll have the employee name. This will be of varchar type, and let's say the size would be 25, comma, then we'll have the age of the employee. Age will be of integer type, and finally we'll have the salary of the employee. Salary will be of type float. Let's create this table. Alright, now the next step is to insert a few records to our employees table. Okay, so here on the notepad I have already written my insert query. So I have inserted nearly 7 records. So let me paste it here. Alright, I'll just go ahead and run this insert query so that we'll insert 7 employees to our table. Okay. Next, we'll write our before update trigger command. So first and foremost, I'll write my delimiter followed by the create trigger command. I'll give my trigger name as update underscore trigger. Let's bring this to the top. Okay. I'll use before update on my table, that is employees. For each row I'll write begin. My condition would be if new dot salary is equal to, let's say, $10,000. I'll write then set new dot salary equal to $85,000. I'll give a semicolon. Then I'll use else if new dot salary is less than $10,000, then I'll set new dot salary to, let's say, $72,000. I'll give a semicolon. I'll end the if statement. I'll close the delimiter by giving a semicolon. Okay. So if you see the employees table, we have the salary values here. Now in case while updating the table, if the salary is equal to $10,000, we'll set the new salary to $85,000. Else, if the salary is less than $10,000, we'll set the salary column values to $72,000. So let's go ahead and run this trigger query. Alright. Now let me use my update command. So I'll write update employees. I'll write set salary is equal to, let's say, $8,000. Now if you see our trigger query, we are setting the salary to $8,000, which is clearly less than $10,000. So our new salary would be $72,000. So let me run this. Okay, so you can see here 6 rows affected. So I'll write now select star from employees. Let's run this. Okay, if you see this, we have converted our salary column to $72,000 since we updated the salary to $8,000, and according to our trigger query, if it's less than $10,000, the salary should be $72,000, which you can see here. Alright, now moving to our final demo. This time we are going to explore how before delete trigger command works. So in this example, we'll create a table called salary. We'll store the deleted record in a new table using the before delete trigger. So first, I'll give my comment as before trigger. Comments are always useful since they make your query more readable. So let me now create my salary table. So I'll write create table salary. I'll give my column names as EID, which is employee ID, and I'll set it as primary key, comma. I'll give another column, let's say valid from, which means the date from which this salary was effective. This is going to be of type date and not null. And then I'll have the amount. Amount will be of type float, and again not null constraint. Let me run the create table command. Okay, so we have created our salary table now. The next thing is to insert a few values. So I'll write insert into salary. I'll give my column names as EID, comma, valid from, comma, amount. I'll write values. My first employee ID would be 101, followed by a date, let's say 2005, May, and 01, which is 1st of May 2005. Let's say the amount is $55,000. I'll give another row of information. This time the employee ID is 102, and I'll give a valid from date. Let's say the amount is 68,000. I'll give another employee ID, let's say 103, 2006, 0901, and let's say the amount is $75,000. Okay, let's run this. Alright, you can verify also. So I'll write select star from salary. You can see here we have inserted 3 rows of information. Alright, the next step is to create another table that will store the deleted rows. So I'll write create table. Let's say the name of the table is create, or let's say salary delete. I'll write salary del. Now this will have the ID and the type will be integer and primary key. I'll also use the auto increment operator. Next we have the EID, which is of type integer. I'll write valid from date and not null. Then I have the amount column, which is of type float and not null. My final column would be deleted at. The data type will be timestamp. I'll use the default constraint as now. So this will return the time and the date at which the record was deleted. Alright. Let me create this table. Okay. Finally, let me write my before delete trigger command. So I'll first declare my delimiter. Let's say this time I'm using the dollar symbol. I'll write create trigger. My trigger name would be salary underscore delete before delete on my table, that is salary. For each row I'll write begin. Next, let's insert into salary delete. I'll give my columns as employee ID, valid from, and amount. Now we'll insert a few values. I'll write values old dot eid comma old dot valid from comma old dot amount. I'm going to close with the delimiters. Alright, so let's run our before delete trigger. Alright, now let me go ahead and delete one of the records from the salary table. So I'll write delete from salary where employee ID is, let's say, 103. Let me run this query. Okay, so you have successfully deleted one of the records in the table. Now if you see our other table, that is salary delete, you will find this information present in the salary delete column. So we had deleted one row of information, that is for employee ID 103, which you can find it here. Now the final column, that is delete at, shows the time at which the information was deleted or the row was deleted. Alright, so let me go to the top and just give you a recap of what we did in this demo. So first we created a database called triggers. Then we started with before insert trigger, where we inserted customer table, and then we verified the age of the customers. So we saw if the age was less than 0, then we set the age to 0. We inserted a few records to the customers table, and purposely we inserted some negative age records, and then we converted this age records to 0. Then we learned how an after insert trigger works. So we created two tables, customers 1 and message. So wherever the customer's date of birth was missing, we passed in a message saying, hi, the name of the customer, please update your date of birth. Alright, now moving ahead, we saw how before update trigger works, and finally we learnt about before delete trigger. So in this video we will learn subqueries in SQL. We'll also have a look at stored procedures and learn about triggers in SQL. We'll cover views in SQL and look at some of the important Windows functions in SQL. Now to learn all of these, we'll be using the MySQL workbench on Windows. So let's get started with subqueries in SQL. So let me head over to my MySQL workbench. So currently I am on my MySQL workbench. Let me connect to the local instance. So I'll give my password. I'll click on OK. Alright. So this is my MySQL workbench query editor. So first we are going to learn subqueries. Let me give a comment and write subqueries. Alright. So first of all, let's understand what a subquery is. So a subquery is a query within another SQL query that is embedded within the where clause, from clause or having clause. So we'll explore a few scenarios where we can use subqueries. So for that, I'll be using my database, that is SQL_intro. So I'll write my command use SQL_intro. Now this database has a lot of tables. I'll be using the employees table that is present inside SQL_intro. Let me just expand this, and you can see here we have an employees table. So let me first show you the contents within this table. I'll write select star from employees. Let me execute it. Okay, you can see here we have the employee ID, employee name, age, gender, there's date of join, department, city and salary, and we have information for 20 employees. If I scroll down, you can see there are 20 employees present in our table. So let's say you want to find the employees whose salary is greater than the average salary. In such a scenario, you can use a subquery. So let me show you how to write a subquery. I'll write the select statement. In the select statement, I'll pass my column names that I want to display. So the column names I want are the employee name. Then I want the department of the employee and the salary of the employee from my table name, that is employees. Next, I'll use a where condition where my salary should be greater than the average salary of all the employees. So I'll write salary greater than. After this, I'm going to write my subquery. So I'll give select average of salary from my table name, that is employees, and I'll close the bracket and give a semicolon. So what it does is, first it is going to find the average salary of all the employees that are present in our table. Once we get the average salary number, we'll use this where condition where salary is greater than the average salary number. So the inside subquery, let me run it first. If I run this gives you the average salary of all the employees, which is $75,350. Now I want to display all the employees who have salary greater than $75,350. So let's run our subquery. There you go. So there are 8 employees in our table who have a salary greater than the average salary of all the employees. Alright. Next, let's see another example. Suppose this time you want to find the employees whose salary is greater than John's salary. So we have one employee whose name is John. Let me run the table once again. Okay, if I scroll down, you see we have an employee as John. You see this? Our employee ID 116 is John and his salary is $67,000. I want to display all the employees whose salary is greater than John's salary. So basically all the employees who are earning more than $65,000, I want to print them. So let's see how to do it. I'll write select. I want the employee name, comma, the gender of the employee. I also want the department and salary from my table name, that is employees. I'll write where salary is greater than. I'll start my opening bracket. Inside the bracket, I'm going to give my inner query, that is select salary from employees where the employee name is John. So within single quotations, I'll give John as my employee. I'll end with a semicolon. So let me first run my inner query. So this will give us the salary that John has, which is $67,000. Now I want the employees who are earning more than $67,000. So let's run our subquery. Okay, so you can see 12 rows returned, which means there are 12 employees in our table who are earning more than $67,000. You see here, all these employees have a salary greater than $67,000. Okay. Now, you can also use subqueries with two different tables. So suppose you want to display some information that are present in two different tables, you can use subqueries to do that. So for this example, we'll use a database that is called classic models. You can see the first database. So let me use this database called classic models. I'll write use classic models. Now this database was actually downloaded from the internet. There's a very nice website. I'll just show you the website name. So this is the website, that is mysqltutorial.org. You can see here they have very nice articles, blogs from where you can learn MySQL in detail. So we have downloaded, they have a MySQL sample database. If you click on this, it will take you to the link where you can download the database. So they have this download link which says download MySQL sample database, and the name of the database is classic models. Alright, so we are going to use this classic models database throughout our demo session. If I expand the tables section, you can see there are a lot of tables that are present inside this classic models database. We have cricket, customers, there's employees, office, there's orders, order lines, and many more. So for our subquery, we'll be using two tables, that is order details and products table. First, let me show you the content that is present inside the products table first. If I run this, you see here it says 110 rows returned, which means there are 110 different products that are present in our table, which has the product code, the product name, product line. We have the product vendor, description, quantity in stock, buy price, MSRP. The other table we are going to use is order details, which has the details of all the orders. Let me show you the records order details tables has. Okay, so there are 1000 records present in this table. You have the order number, the product code, quantity ordered, price of each item. You have the order line number as well. Okay, now we want to know the product code, the product name, and the MSRP of the products whose price of each product is less than $100. For this scenario, we are going to use two different tables and we are going to write a subquery. Okay, so if you see here in the order details table, we have a column called price each. I want to display the product code, the product name, and the MSRP of the products which have a price of each product less than $100. So the way I'm going to do is, I'll write select product code, comma, product name. Now one thing to remember, that this product name is actually present inside our products table, and product code is present in both the tables, that is products and order details. Here you can see this is the product code column, comma, MSRP, which is present inside the products table again, from my table, that is products, where I'll write product code. I'm going to use the in operator. Next, I'll write my inner query, that is select product code from my table order details, where my price of each product is less than $100. Let me run this. Okay, so you can see there are total 83 products in our table which have a price less than $100. You can see the price here. Okay. Now we learn another advanced concept in SQL which is known as stored procedures. I'll just give a comment saying stored procedure. Okay. So first let's understand what is a stored procedure. A stored procedure is an SQL code that you can save so that the code can be reused over and over again. So if you want to write a query over and over again, save it as a stored procedure and then call it to execute it. So in this example, I want to create a stored procedure that will return the list of players who have scored more than 6 goals in a tournament. So I have a database called SQL_IQ. These are a few databases that I have already created. So this database has a table called players. If I expand the tables option, you see we have a table called players, and you can see the columns player ID, the name of the player, the country to which the player belongs to, and the number of goals each player has scored in a particular tournament. So I'll write a stored procedure that will return the list of top players who have scored more than 6 goals in a tournament. So first of all, let me begin by using my SQL_IQ database. We'll run it. So now we are inside the SQL_IQ database. Let me select star from players to show the values that we have in the players table. You can see there are 6 players in our table. We have the player ID, the names of the players, the country to which these players belong to, and the goals they have scored. So I'll write a stored procedure. So the stored procedure syntax is something like this. It should start with a delimiter. Okay. In the delimiter, I'll write &&. Next, I'll write create procedure followed by the procedure name. Let's say I want to name my procedure as top_players. Next statement is begin. After begin, I'll write my select statement. I want to select the name of the player, the country, and the goals each player has scored from my table, that is players, where I'll write goals is greater than 6. I'll give a semicolon. Then I'll end my procedure with a delimiter that was $. Next, I'll write delimiter and give a semicolon. Now the semicolon suggests this is a default delimiter. And there should be a space. Okay. Now let's run our stored procedure. There you go. So you have successfully created our stored procedure. Now the way to run a stored procedure is you need to use the call method and give the procedure name, that is top_players in our case, with brackets and a semicolon. Let's execute it. Okay, there is some problem here.
If it's going up or down in ranks in the past day or
so we made a mistake while creating a procedure. The name of the column is goals and not goal. Let me create that procedure again.
So let's just go right ahead.
Okay, it says the procedure top_player already exists. Let's just edit the procedure name. Instead of top player, we'll write it as top players, and similarly we'll edit here as well. Now let's create it again.
Alright, hey guys, my name is Ethan Folsom, and
now to call my procedure, I'll write call space followed by the procedure name, which is top_players. If I run this, you can see we have 2 players in our table who have scored more than 6 goals. So we consider them as the top players in a particular tournament. Alright. Now, there are other methods that you can use while creating a stored procedure. One of the methods is by using an in parameter. So when you define an in parameter inside a stored procedure, the calling program has to pass an argument to the stored procedure. So I'll give a comment, stored procedure using in parameter. Alright. So for this example, I'll create a procedure that will fetch or display the top records of employees based on their salaries. So we have a table in our SQL_IQ database which is called employee details. I'm going to use this table. You can see we have the name of the employee, the age, sex, then we have the date of join, city and salary. Using this table, I'll create a procedure that will fetch or display the top records of employees based on their salaries, and we'll use the in parameter. So let me show you how to do it. I'll write delimiter. This time I'm going to use /. I'll write create procedure.
Welcome to packages are
followed by the procedure name. Let's say SP for stored procedure, sort by salary is the name of my procedure, and inside this procedure I'll give my parameter in. I'll create a variable var and assign a data type integer. Then I'll write begin, followed by my select statement where I'll select the name, age, salary from my table name, that is EMP details or employee details. I'm going to order this by salary descending, and I want to display limited number of records, so I'm using this limit keyword and my variable var which I created here. I'll end my select statement. I'll end my stored procedure with /, and I'll go back to my default delimiter, that is semicolon. Alright, so let me run this. There should be a space here. Alright, so let's run this. Okay, you can see we have successfully created our second stored procedure, which is SP_sort by salary. Now you can also check whether the stored procedure was created or not. Here you have an option to see the stored procedures. Let me just refresh this, and you can see we have 3 stored procedures that we have created so far. One is SP_sort by salary, the other 2 were top_player and top_players. Okay, now let's call our stored procedure. I'll write call space followed by the stored procedure name, which is SP_sort by salary, and inside this I'll give my parameter, which was actually var, and this var we have used in limit. Let's say I want to display only the top 3 records of the employees who have the top 3 highest salaries. Okay, so let me run it. There you go. So Amy, Sarah and Jimmy were the top 3 employees who have the highest salary. So you saw how you could use the in parameter in a stored procedure. We created a variable, and that variable we used in our select statement, and we called our stored procedure and passed in that variable. Okay, now instead of a select statement inside a stored procedure, you can also use other statements. Let's say update. So I'll create a stored procedure to update the salary of a particular employee. So in this procedure, instead of select statement, we'll use the update command. In this example, we'll use the in operator twice. So let me show you how to do it. I'll write my delimiter first, which is going to be /. Then I'll write create procedure. My name of the procedure is going to be update salary, and inside the update salary name I'll write in, and then temp underscore name, which will be a temporary name variable, and the type I'll assign is varchar 20. I'll again use my in parameter. I'll write in. Next, my other variable would be new underscore salary, and the data type would be float. I'll write begin and write my update command or update statement. I'll write update table name, that is employee details, set salary equal to new underscore salary, where name is equal to my temporary variable, that is temp underscore name. So this is my update command, and I'll end the delimiter. Alright, so let's run this. Okay, we have successfully created our stored procedure. If I refresh this, you can see I have my stored procedure update underscore salary. Okay, now let's say, first of all, I'll display my records that are present inside employee underscore details table. Okay, so we have 6 rows of information. Let's say you want to update the salary of employee Jimmy, or let's say Mary, from 70,000 to let's say 72,000, or let's say 80,000. So I'll call my stored procedure, that is update underscore salary, and this time I'm going to pass in 2 parameters. The first parameter will be the employee name, and next with a comma I'll give my new salary that I want to. So my employee name, let's say, is Mary, and the salary I want to be updated is, let's say, $80,000. I'll give a semicolon and I'll run it. You can see it says 1 row affected. Now let's check our table once again. There you go. If you see this record, for Mary we have successfully updated the salary to $80,000. Now moving ahead, we learn to create a stored procedure using the out parameter. So I'll give a comment, stored procedure using out parameter. Okay, so suppose we want to get the count of total female employees. We will create total employees as an output parameter, and the data type would be an integer. The count of the female employees is assigned to the output variable, which is total underscore emps, using the into keyword. Let me show you how to write a stored procedure using the out parameter. So first I'll declare my delimiter 2/. I'll write create procedure followed by the procedure name. It is going to be sp underscore count employees, and inside this I am going to give my out parameter and the variable name, that is total underscore emps, which is total employees, and the data type will be integer. Next I am going to write begin followed by my select statement, that is select. I want the count of total employees, and the output I am going to put into my new variable, that is total underscore emps. From my table, that is emp underscore details where sex is equal to F, which means female. I'll give a semicolon. Next, I'll end it with the delimiter, and I'm going to change the delimiter to a default delimiter, that is colon. So let me tell you what I'm doing here. I'm creating a new stored procedure, that is sp_count employees. Using this stored procedure, I am going to count the total number of female employees that are present in our table emp_details. So I've used my out parameter and I'm creating a new variable called total_emps. The data type is integer. Here in the select statement, I'm counting the names of the employees, and the result I am storing it in total_emps. I have used my where condition where the gender or the sex is female. So let's run this. Okay, so we have created our stored procedure. Let's refresh this. Okay, you can see we have our new stored procedure sp_count employees. Now to call it, I'll write call the name of the procedure, that is sp_count employees. Within brackets, I'll pass in the parameter as @f_emp. I'll give a semicolon. Then I'll write select @f_emp as female employees. Okay, so as is an alias name. Let's run this one by one. First I'll call my procedure and then we'll display the total number of female employees. You can see in our table we have 3 female employees. Alright, now with this understanding, let's move on to our next topic in this tutorial on advanced SQL. Now we are going to learn about triggers in SQL. So I'll give a comment here, triggers in SQL. So first let's understand what is a trigger. So a trigger is a special type of stored procedure that runs automatically when an event occurs in the database server. Now there are mainly 3 types of triggers in SQL. We have the data manipulation trigger, we have the data definition trigger, and login triggers. In this example, we will learn how to use a before insert trigger. So we will create a simple students table that will have the student's roll number, the age, the name, and the student's marks. So before inserting the records to our table, we'll check if the marks are less than 0. So in case the marks are less than 0, our trigger will automatically set the marks to a random value, let's say 50. So let's go ahead and create our table, that is students. Alright. So I'll write create table student . Now this table will have the student roll number, the data type is integer, it will have the age of the students, again the data type is integer, we have the names of the students, so the third column would be name, the data type would be variable or varying character, size I am giving it as 30, finally we have the marks as floating type. So let's create this table, which is student. So we have created our table. Now I'll write my trigger command. So trigger command will start with delimiter like how our usual stored procedures have. Next, this time I'll write create trigger. Then you need to give the name of the trigger, that is mark_, let's say verify. I'm going to use a before insert trigger, so I'll write before insert on my table name, that is student. Next I'll write for each row if new dot marks is less than 0, then we'll set new dot marks equal to 50. So this is my condition. First we'll check before inserting if any student has marks less than 0, we'll assign a value 50 to that student, because usually the marks are not less than 0 in any exam. I'll write end if semicolon and I'll close the delimiter. So this is my trigger command. I'll run it. It says trigger already exists. So in this case we need to update the trigger name. Let's say I'll write marks underscore verify underscore student for ST. Let's run it again. Okay, there is an error here because in our table the column name is mark and not marks. So here we need to change it as mark instead of marks. Alright, let's run it. Okay, so we have created our trigger. Now let me insert a few records to the student table. So I'll write insert into student. I'll write values. I'll give the values as 501, which is the student roll number. The age is, let's say, 10. The name is, let's say, Ruth. And the marks is, let's say, 75.0. Give a comma. We'll insert our second student record. Student roll number is 502. Age is 12. The name is, let's say, Mike. And this time I'm purposely giving a value of minus 20.5. Give another comma. We'll insert the third record for student roll number 503. Age is 13. The name is Dave. And let's say the marks obtained by Dave is 90. Now we'll insert our final record for student number 504. The age is 10. Name I'll enter as Jacobs. And this time again I'm purposely giving the marks in negative 12. Let's say 5. I close the bracket and give a semicolon, and I'll run my insert statement. Okay, so we have inserted 4 rows of information to our student table. Now let me run the select query. I'll write select star from student. If I run this, you see the difference. There you go. So originally we had inserted for 502 the marks was minus 20.5, and for 504 for Jacobs the marks was minus 12.5. Our trigger automatically converted the negative marks to 50, because when we created our trigger we had set our marks to 50 in case the marks were less than 0. So this is how a trigger works. Now you can also drop a trigger or delete a trigger. You can just write drop trigger followed by the trigger name. In this case our trigger name is marks underscore verify underscore st. I'll just paste this here, and if you run this it will automatically delete your trigger. I'll give this as a comment. Okay, now moving on. Now we are going to learn about another crucial concept in SQL which is very widely used. This is known as views. So views are actually virtual tables that do not store any data of their own but display data stored in other tables. Views are created by joining one or more tables. I'll give a comment as views in SQL. Okay. Now to learn views I am going to use my table which is present inside classic models database. Now this database, as I mentioned, we had downloaded it from the internet. So first of all, let me write use classic models. So I'll switch my database first. Alright, now we are inside classic models. So here let me show you one of the tables which is called customers. So I'll write select star from customers. Okay, I missed S here. Let's run it again. So this is my customer table which is present inside classic models database. It has the contact last name, the contact first name, the customer name, customer number, we have the address, state, country, and other information. Now I'll write a basic view command using this customer table. The way to write is I'll write create view followed by the view name, which is cust_details. Then you write as select. I'm going to select a few column names from my original customer table, which is this one. So I need the customer name. Let's say I need the phone number and the city. So you have this information here. You have the phone number and the city. Alright, I'll write from my table, that is customers. If I run this, my view, that is cust details, will be created. Let's run it. There's some error here because the name of the table is customers and not customer. I'll give an S and I'll run it again. Alright, so you can see we have created our view, and to display the contents that are present inside our view, I can write select star from followed by the view name, that is cust_details. Let's run it. There you go. So we have the customer name, the phone number and the city of the different customers that we have in our table. Alright. Now let's learn how you can create views using joins. So we'll join two different tables and create a view. So for that, I'm going to use my products table and the products lines table. I'm talking about the products table and the product lines table present inside classic models database. So before I start, let me display the records that are present inside the products table. Let's run it. So these are the different products you can see here. Now let's see what we have in product lines table. So we have the product line, the text description, and there's some HTML description and image. So I'll create a view by joining these two tables and will fetch specific records that are present in both the tables. So let me first start by writing create view followed by the view name, that is product_description, as I'll write select product name, comma, then I'll write quantity in stock. I also want the MSRP. Now these three columns are present inside the products table, and next from the product lines table I want the text description of the products. So I'll write from products table. I'll give an alias as P followed by inner join my other table, that is product lines, as let's say PL on the common column, that is product line. So P dot product line is equal to, I'll give a space, PL dot product line. Okay, so here we have used an inner join to fetch specific columns from both the tables, and our view name is product_description. Let us run it. Alright, so we have our view ready. Now let me view or display what is present inside our product underscore description view. I'll write select star from product underscore description. Let's run it. There you go. So we have the product name, the quantity in stock, MSRP and textual descriptions of the different products in the table. Okay. Now there are a few other operations that you can perform. Let's say you want to rename a view. Instead of product underscore description, you want to give some other name. So I'll just give a comment, rename description. So to rename a description, you can use the rename statement. I'll write rename table product underscore description, which is my old name. I want to change this name to, let's say, I'll give vehicle description, since all our products are related to some of the other vehicle. So I'll write vehicle description. Okay, let us run it. Alright, so here you can see I have renamed my view. So here if I just refresh it and I'll expand this, you can see we have the cust details view and we have the vehicle underscore description view. Okay, now either you can view all the views from this panel or you can use a command. Let's say I'll write display views is the comment. Now to show all the views, you can use show full tables, where table underscore type is equal to, within single quote I'll write view. So this is the command that will display all the views that are present inside a database. There is some error here. Let's debug the error. This should be okay. So instead of table types, it should be table type equal to view. Let's run it. You can see the two different views that we have. One is customer details, another is vehicle underscore description. Okay, now you can also go ahead and delete a view. For that you can use the drop command. So I'll write drop view followed by the view name. Let's say I want to delete customer underscore details or cust underscore details view. I'll write drop view cust underscore details. Let's run it. You can see here we don't have the cust underscore details view anymore. Alright, now moving to our final section in this demo. Here we will learn about Windows functions. Now, Windows functions were incorporated in MySQL in the 8.0 version. So Windows function in MySQL are useful applications in solving analytical problems. So using the employees table present inside my SQL underscore intro database, so we'll find the total combined salary of the employees for each department. So first let me switch my database to SQL underscore intro database. I'll run it. Okay, I'll display my table, that is employee. So here we have 20 employees in our table. Using this table, we are going to find the combined salary of the employees for each department. So we'll partition our table by department and print the total salary. And this we are going to do using some Windows functions in MySQL. So I'll write select. I want the employee name, the age of the employee, and the department of the employee, comma. Next I'll write the sum of salary over, I want to partition it by department. So I'll write partition by department, which is DEPT, and I'll give an alias as total salary, so that it will create a new column with the name total salary from my table, that is employees. The output will be a little different this time. Let's execute it and see the result. There you go. So here we have created another column in our result, that is total salary, and for each of the employees and the respective departments we have the highest salary. So in finance, the highest salary of one of the employees was $155,000. Similarly, if I come down, we have the highest salary from HR. If I scroll further, we have the highest salary from IT, marketing, product, sales, and the tech team. Alright, now we'll explore a function which is called row number. Now the row number function gives a sequential integer to every row within its partition. So let me show you how to use the row number function. I'll write select row underscore number function over my column would be salary, so I'll write order by salary. I'll give the alias as row num, give a comma, and I want to display the employee name and the salary of the employee from my table, that is employees, and I'll order by salary. So let's see how our row number function will create sequential integers. Okay, you can see here we have a row num column and we have successfully given row numbers to each of the records. You can see it starts from 1 and goes up till 20. Okay. Now this row number function can be used to find duplicate values in a table. To show that, first I'll create a table. I'll write create table. Let's say I'll give a random name, that is demo, and let's say we have in this table the student ID, which is of type integer, and we have the student name, which is of type varchar. The size is 20. I'll create the small table with a few records. Let's create this table first. Now we are going to insert a few records to our demo table, so I'll write insert into demo values. I'll give 101, the name is Shane, give a comma, I'll insert the second student name 102, the name is Bradley, I'll give a comma. This time for 103 we have two records. Let's say the name of the student is Herath. I'll give a comma, I'll copy this and we'll paste it again. So we have duplicated 103. Next we have 104. The name of the student, let's say, is Nathan. Then again, let's say for the fifth student, which is Kevin, we have two records. I'll copy this and I'll paste it here. Let me give a semicolon and we'll insert these records to our table demo. Alright. Now let me just run this table for you. I'll write select star from demo. If you see this, we have a few information that are duplicated in our table, that is for student ID 103 and student ID 105. Now I am going to use my row number function to find the duplicate records present in my table. I'll write select student underscore ID comma student underscore name. I'll give another comma and write row underscore number over, within brackets I'll write partition by st underscore id comma st underscore name. Okay, then I'll write order by st underscore id, close the bracket. I'll give an alias as row num from my table that is demo. Let's just run it. You can see here, okay, let me just delete n from here and do it again. Alright, if you see here, there is just one student in the name Shane. We have one student in the name Bradley. But here if you see, for Herath, the second record it says 2, which means there are 2 records for Herath. And if I scroll down, there is 1 record for Nathan. And there are 2 records for Kevin, which means Kevin is also repeated. Okay, now we are going to see another Windows function that is called rank function in MySQL. So the rank function assigns a rank to a particular column. Now there are gaps in the sequence of ranked values when 2 or more rows have the same rank. So first of all, let me create a table, and the name of the table would be a random name. We'll give it as, let's say, demo1, and it will have only one column, let's say variable a of type integer. We'll create this table first. Okay, now let's go ahead and insert a few records to our table, which is demo1. So I'll write value 101, 102, let's say 103 is repeated. I'm doing this purposely so that in the output you can clearly distinguish what the rank function does. Next we have 104, 105, we have 106, and let's say 106 is also repeated. Finally we have 107. Okay, let me insert these values to my table that is demo1. Okay, this is done. Now if I write select var underscore a and use my rank function, I'll write rank over, then I'll order by my variable that is var underscore a as an alias name, let's say test rank, from my table that is demo1. Let me execute this and show you how the rank function works. Now if I run this, there you go. So here if you mark, so for variable a101 the test rank is 1, for 102 the test rank is 2, but for this value which is 103 the test rank is repeated because there was a repetition for 103. So we have skipped the rank 4 here. For 104 the rank is 5 now, for 105 the rank is 6 now. For 106 again, since the record was repeated twice, we have skipped the 8th rank and our rank function has assigned the same value which is 7 for 106, and for the last value 107 the rank is 9. Alright. Now moving ahead, we'll see our final Windows function which is called first value. So first value is another important function in MySQL. So this function returns the value of the specified expression with respect to the first row in the window frame. Alright. So what I'm going to do is, I'm going to select the employee name, the age and salary, and I'll write first underscore value, which is my function, and pass in my employee name, and then I'll write over order by my column that is salary descending. I'll give an alias as highest underscore salary, from my table that is employees. So let me run this and see how the first underscore value function works. Alright, so in our table, Joseph was the employee who had the highest salary, which was $115,000. So the first value function populated the same employee name throughout the table. You can see it here. Now you can also use the first underscore value function over the partition. So let's say you want to display the employee name who has the highest salary in each department. So for that you can use the partition. I'll write select emp underscore name, comma, I want the department and the salary, comma, I'll use my function that is first underscore value followed by the name of the employee inside my first value parameter. I'll write over. Here I'm going to use partition. I'm going to partition it by department, since I want to know the employee name who has the highest salary in each department. And I'm going to order by salary descending, and I'll give my alias again as highest salary from my table that is employees. So let's run this and see the difference in the output. Okay, so as you can see here, we have the employee who had the highest salary from each department. So for finance, Jack had the highest salary. From HR it was Marcus. Similarly in IT it was William. If I scroll down, for marketing it was John. For product it was Alice who had the highest salary. Similarly in sales we had Joseph, and in tech we had Angela. So this is how you can use the first underscore value function using partition. Alright, so that brings us to the end of this demo session on our tutorial. So let me just scroll through and show you what we did from the beginning. First we learnt about subqueries in SQL. So we initially wrote a simple subquery, and then we used our classic models database which was downloaded from the internet. I'd also shown you the link from where you can download this database. Here we used two different tables and we performed a subquery operation. We learned how to create stored procedures. So we learned how you can use the in operator or the in parameter as well as the out parameter in stored procedure. After stored procedure, we learned another crucial concept in SQL which is called triggers. Now triggers are also a special kind of stored procedures. So we saw how to write a before insert trigger. You can see it here. Next, we learned how to delete a trigger. We also saw how to work with views in SQL. So views are basically virtual tables that you can create from existing tables. We also saw how you can use views using two different tables and an inner join. And we learned how to display views, how to rename view names, how to delete a view, and finally we explored a few Windows functions. In this tutorial, we will learn how to work with databases and tables using SQL with Python. To do this demo, we will be using our Jupyter Notebook and the MySQL Workbench. You can see it here. So we will write our SQL queries in the Jupyter Notebook with Python-like syntax. If you don't have MySQL or Jupyter Notebook installed, so please go ahead and install them first. While installing the MySQL Workbench, you will be asked to give the username and password. Let me show you. So I am on my MySQL Workbench. So once you connect, it will ask for the username and the password. So I have given my username as root, and password you can give while installing it. We will be using the same user ID or the username and the password to make our connection. So let's get started with our hands-on demonstration part. First and foremost, let me go ahead and import the necessary libraries. I'll give a comment as import libraries. Alright, so first I'll import mysql.connector. Next, from MySQL.connector, I am going to import my error method or the error module. Next, I want to import pandas as PD. So let's run this. Okay, there is some error here. This should be capital E and not small e. Alright, you can see I have imported my important libraries. Now I'm going to create a function that will help us create a server connection. So I'll write my user-defined function by using the def keyword. I'll write create underscore server underscore connection. This is going to be my function name, and it will take in 3 parameters. First is the host name, next is the username, and then we have the user password. Alright, I'll give a colon, and then in the next line I'm going to define a variable which is going to be connection, and I'll assign it to a value called none. Now we'll be using exception handling techniques to connect to our MySQL server. The try block lets you test a block of code for errors, and the except block will handle the errors. So I'll write try and give a colon, and then I'm going to reassign the connection variable to a method which is MySQL.connector.connect. Now this MySQL connector.connect method sets up a connection, so it establishes a session with the MySQL server. If no arguments are passed, it uses the already configured or default values. So here we are going to pass in 3 parameters. The first is the host name. I'll write host equal to host name, which is host underscore name. I'll give a comma, then I'll write user equal to user underscore name. Next will be my password, and I'll assign the value user underscore password. Alright, now I'm going to use a print statement and write MySQL database connection successful. After this, I'll give my except block. So I'll use the keyword except. Here I'll write error as err, give a colon, and then I'm going to use the print statement. Here I'm going to use some print formatting techniques using the F letter. I'll write error colon, and I'll use curly braces, give err, and then I'll close the double quotes. After this, I'm going to return my connection. Alright, let me give a comment here. We are going to assign our password, so we need to put our MySQL terminal password. So this password you assign it while installing MySQL Workbench. I'll write pw, and I'll give my password, which is simply @12345, and then I'm going to give my database name. So I'll give database name. Here I'm going to write db equal to, this is the database I want to create, which is going to be MySQL underscore Python. Let me just scroll this down. Okay, now I'll say connection equal to, I'll pass in my user defined function name, which is create server connection, and the parameters, which are going to be localhost, that is my host name, my username, which is root, and then I'll give pw, which is my password, that is exactly simply @12345. Let's just run it now. Okay, there is an error here. We need to remove this double quotation. Alright, made another mistake here. This should be root. Okay, you can see here MySQL database connection successful. Alright, next we are now going to create a database, that is MySQL underscore Python. So I'll give a comment, create MySQL underscore Python database. Again, to create this database, I'm going to create another user defined function using the def keyword. I'll write the function name as create database, pass in the parameters as connection, comma, query, give a semicolon, and in the next line I'll write cursor equal to, I'm going to make the connection, so I'll write connection dot cursor, and I'll give the parenthesis. So this MySQL's cursor of MySQL connector Python is used to execute statements to communicate with the MySQL database. The MySQL cursor class initiates objects that can execute operations such as the MySQL statements. Okay, next I'm going to again use my try and except block. So I'll write try, give a colon, and here I'm going to use cursor dot execute. Within that I'm going to pass in my query. Next I'll use a print statement, and the message I'm going to display is database created successfully. After this I'm going to write my except block. I'll write except error as err, give a colon, and then I'll use a print statement. I'll write print, I'll use the formatting again, error colon, then I'll write within single quotes, I'll give curly braces err, and then I'll close the double quotes. Next let's use the variable create underscore database underscore query, and here I'm going to write my SQL query to create the database. So I'll write create database, and followed by that I'll give my database name, which is going to be MySQL underscore Python. Okay, after this I'll call my function, which is create database, and I'll pass in the parameters. The first one is connection, and next the query is create underscore database underscore query. Let me just copy it and I'm going to paste it here. Alright, so what I am doing here is I am creating a new function, that is to create a new database with the name MySQL underscore Python, which you can see it here. Now this function takes in two parameters, connection and query. I'm using the connection.cursor function, which is often used to execute SQL statements using Python language. And then I have created my try and except blocks. So this try block statements will try to create my new database, which is MySQL underscore Python. In case it fails to create the new database, the except block will work. So here I am writing my SQL query to create a new database, which is create database followed by the database name, and I am assigning it to a variable which is create database query, and then I'm calling my function create database and passing in the two parameters, connection and the query. Alright, so let's just run it. Alright, you can see here it has created my database successfully. Now you can verify this by checking the MySQL workbench or the MySQL shell. You can see on the MySQL workbench here on the left panel under schemas, there is a database called MySQL underscore Python. Let me just expand it. Now we haven't created any table, so it's not showing it now. The next step, we are going to connect to this database. So let's go ahead and connect to our database that we have just created. I'll write the comment as connect to database. Now to connect to our database, I'm again going to create a user defined function using the def keyword. I'll write create underscore db, which is for database underscore connection, and the parameters it will take is the host name followed by the username, then we have the user password, and finally we have the database name. I'll give a colon. In the next line, I'm going to create my variable which is connection, and then I'll assign it to a value none. After this, I'm going to use my exception handling techniques. So I'll write my try block first. I'm going to reassign my connection variable using the MySQL connector method. So I'll write MySQL dot connector dot connect. So this method will take in the parameters. So first it will take the host name. I'll write host equal to host underscore name. I'll give a comma. Next it will take the username, so user equal to user underscore name, give another comma. Next it will take the user password. I'll use passwd equal to user underscore password. I'll give another comma, and this time it is going to be the database name. So I'll write database equal to db underscore name. Now let's use the print statement, and the message we are going to print is MySQL database connection successful. Alright, finally we'll write my except block. I'll write except error as err, give a colon, and then I'll use the print statement f within double quotes. I'll write error colon, within single quotes curly braces I'll write err, and will close the double quotes. Finally this function will return the connection value. Alright, let's run it, and there you go, it has run successfully. So we have connected to our database. Now it's time for us to execute SQL queries. I'll give another comment saying execute SQL queries. Alright. Now to execute our SQL queries, I'll use another user-defined function which is execute underscore query, and I'll pass in the parameters as connection and query. I'll give a colon. I'm going to write cursor equal to connection dot cursor. Now this is used to establish a connection and run SQL statements. Next, we'll use the try and except block. So I'll write try cursor dot execute. This will take in one parameter which is going to be my query, and then I'll write connection dot commit, which is another method. Now let's use the print statement. So I'll write print. Let's say the message would be query was successful. And then we'll write our except block, which is except. If the try block doesn't work, throw an error using the print statement. Within double quotes, inside the curly braces, I'll write err and close the double quotes. Alright, so let's run it. Okay, so we have successfully created our various functions that were needed to create a database, establish a connection, and to execute our queries. Alright, now it's time for us to create our first table inside the MySQL_Python database. So to do that, I'm going to write my create command in SQL. So first we are going to assign our SQL command to a Python variable using triple quotes to create a multi-line string. So let me show you how to do that. I'll write my variable name, which is going to be create orders table. It is always recommended to use relevant variable names to make it more readable. And now I'm going to use triple quotes. So the triple quote will ensure I can create my multi-line string. Inside the triple quote, I am going to write my create command, which is create table. Here I am going to create an orders table first, and inside the orders table I am going to create my column names. The first column would be the order ID. It is going to be of type integer, and I'll assign this order ID as my primary key column. We'll give a comma. Next, the second column would be customer underscore name. The customer name column would be of type varying character, so I'll write varchar and I'll give a size of 30, and this is also going to be not null. Moving ahead, my fourth column would be the product name column, so I'll write product underscore name. Product name will be of type varying character. The size is, let's say, 20, and it is also not null. Next, I'm going to create my fourth column, which is the date on which the item was ordered or the product was ordered. So I'll write date ordered. The data type will be date. Next, I'll create a quantity column to keep track of the number of quantities that were ordered. This is of type integer. My next column would be unit price, which will basically have information about the price of each unit of product. Unit price can be of type float. And finally, I'll have the phone number of the customer. I'll write phone number. Phone number can be kept as of type varying character. I've assigned a size of 20. Now let's give a semicolon and we'll close the triple quotes. Alright, so this is how the syntax would look like. Next, to run this, we are first going to call our createDB function. So let me give a comment as connect to the database. I'll write connection equal to create underscore db underscore connection. My parameters would be my host name, which is localhost, my username, which is root, comma, my password, and then my database name, which is MySQL underscore Python. So I'll write just db. Alright. Finally, let's execute this query using the execute underscore query function that we had created earlier. This takes in two parameters. The first one is connection, followed by the variable name, which is create orders underscore table. Let us run it. Okay, there is some error here. Let's see what's the error. Okay, so here we have put 4 double quotes. This should be triple quotes. Now let's run it. Okay, there is another here. Let's debug it. It says name cursor not defined. Let me just roll it to the above cell. If you see here in our execute underscore query function, instead of cursor, I have written cursor. So R is missing. Let's rerun this. And now let's run this again. There you go. You can see here MySQL database connection successful. Even our query was also successful. Now if you want to recheck if the table, that is orders, was created or not, you can check it on the MySQL workbench. So let me show you how to do it. So I am on my MySQL workbench, and under MySQL underscore Python database you have something called as tables. Let me just right click and I'll select refresh all. There you go. You can see this arrow. Just click on this arrow and here you can see we have a table called orders. So we have created a table called orders. Now you can check the columns as well. You have the order ID, the customer name, product name, ordered date, quantity, unit price, and phone number. Now it's time for us to insert a few records to this table, which is orders. Now to insert records, I'll give a comment as insert data. I'll start with the variable name. Let's say the variable name is data underscore orders. I'll give triple quotes. Next, I'll write my insert into command. So I'll write insert into my table name, that is orders, followed by values, and now I'll start entering my records for each of the rows. So first I'll give 101, which is the order ID. Then I'll give the customer's name, let's say Steve, and the product he had ordered is, let's say, laptop. Then I'll give my date in which the item was ordered. Let's say it is 2018. I'll choose 06 as the month and the date is, let's say, 12. I'll give another comma. This time we'll pass in the quantity, which is 2. Let's say the price of each laptop was $800, and we'll give a phone number. This is random. Let's say 6293730. Let's say 802. Alright. Similarly, I am going to insert 5 more records of different customers and their items that they have purchased to this table orders. So here on my notepad I have my rest of the 5 records. Let me just copy it and we'll paste it in the cell here. This will save us some time. Okay. Let me recheck if everything is fine. I'll give a comma here. Alright, so we have 6 customers in our table which have their customer IDs from 101 to 106. You have Steve, Jaws, Stacy, Nancy, Maria and Danny. You have the different items they have purchased: laptop, books, trousers, t-shirts, headphones and smart TV. This is the date on which they had ordered this item, the number of quantities they had ordered, and then we have the unit price and some random phone numbers. So let's create the connection now. I'll write connection equal to, I'll write create underscore db underscore connection. Then I'll going to give my same parameters. Let me just copy it from the top, which is localhost, the host name, root is my username, then we have password and the database name, and then I'll use the same query as above, which is execute query. I'll copy this, paste it here, and instead of create orders table variable, I'll put as data underscore orders. So this will store my insert into command. You can see the variable I have used here is data underscore orders. Now it's time, let's just run it. Alright, there was some mistake here. Let's debug it. Again, this should be triple quotes and not 4. Now let me rerun it again. There you go. You can see here MySQL database connection successful and my query was also successful. Now we'll create another user-defined function which will help us read query and display the results. So I'll write my function name as def read underscore query. This will take in 2 parameters, connection and query. Then I'll write cursor equal to connection.cursor. I'll put my result as none, and then I'll use my try and accept block. I'll write try cursor dot execute. This will take in 1 parameter, which is query, and then I'll give another variable which is result equal to cursor dot fetch all. Now this fetch all method will return all the results in the table. I'll write return result. Next we'll use the accept block. So I'll write accept error as err, give a colon, and I'll use my print statement. Scroll this down. I'll use my formatting f error, give a colon followed by a space, within single quotes inside curly braces I'll give err and close my double quotes. Let's run it. Alright, so now we are all set. Now we are going to use our select clause, having, whereby, then we'll see how to use order by clause, some inbuilt functions, we'll update some records, delete some records, and do a lot of other stuff. So let's start with our first query. So our first query is going to be using the select statement. Alright, so suppose I want to display all the records that we have inserted into our orders table. So the way to do is I'll assign my query to a variable, let's say q1. I'll give triple quotes. Within triple quotes I'll write select star from orders. I'll give a semicolon followed by the triple quotes. Now we'll establish the connection. So let me just go to the top and I'll copy this line. which is to connect to our database. I'll paste it here. Now we'll create a variable called results that will store the result of this query, and we are going to assign this variable to our function, that is read query, and this read query will have two parameters, the connection and the variable name, which is q1 for the query. Next, to display, I'm going to use a for loop. I'll write for results for result in results print, I'll say result. Now we are done. Let's just run this query. There you go. You can see here we have successfully printed all the rows in our table, which is orders. You can see we have 6 records in total. Now we are going to explore a few more queries. So let me just copy this and we are going to edit in the same query. I'll paste it here. Next, let's say you want to display individual columns from the table and not all the columns. So let me create the variable q2. Now instead of star, I'm going to display only the customer name and let's say the phone numbers of the customer. So I'll write phone underscore number. Alright, the rest all remains the same. Let me just recheck it, and here instead of q1 we'll put q2, and let's run this cell. Alright, you can see here now we have displayed only 2 columns. The first column is the customer name and then we have their respective phone numbers. Okay, now let me just paste that query again. Now we are going to see how you can use an inbuilt function, that is, in our table we have the order date, and from the order date we are only going to display the different years that are present in the order date. So to do that, I am going to use the year function. I'll edit this query. Instead of q1 I'll make it q3, and here I'm going to write select year, which is my function name, from my column which is date ordered, from orders, and here I'll change this to q3. q1, q2, q3 are basically query 1, query 2 and query 3. Let's run it. There you go. So we have successfully extracted the different years present in the order date column. Now if you want to display the distinct or the unique dates present in the column, you can use the distinct keyword in the select statement. So the way to do it is, I'll write select distinct, give a space, the rest of the query remains the same, and here instead of q3 I'll write q4. I'll make this as q4. Let's run it. You can see 2018 and 2019 are the unique year values that are present in the order date column. Okay, now moving ahead, let's write our 5th query, and this time we are going to explore how you can use the where clause. So I'll change this to q5 before I write my query. So let's say you want to display all the orders that were ordered before 31st of December 2018. So to filter this, we are going to use the where clause. So I'll write select star from orders. Next I'll write where my date underscore ordered is less than, within quotes I'll give my date value, which is 2018 December 31st. So all the items or the products that were ordered before 31st of December 2018 will be displayed. So let's run it. Alright, you can see here there are 3 orders in our table which have been ordered before 31st of December. Now moving ahead, we want to display all the orders that were made after 31st of December. So here what you can do is, I'll just copy the above query again. I'll copy this line So instead of less than 31st of December 2018, I'll make it as greater than. So every order that was placed after 31st of December will be displayed. If you run it, so you can see here there are 3 orders in our table which were ordered after 31st of December 2018. Now moving ahead, let's write our 7th query. Now let's see how the order by clause works in SQL. So you can filter your results based on a particular column or sort it based on a particular column. So this is going to be my query 7. I'll write it from scratch again. Let's say you want to display all the columns from the table. So I'll write select star from orders. Then I'm going to use order by unit price. I'll give a semicolon. Let's run this query and see the output. Now if you see the result here and you mark the unit price column, the result has been ordered in ascending order of unit price. You see here it starts with the lowest price and then goes on with the highest price towards the end. Now if you want to order it in descending order, you can use the keyword DESC. So this will ensure your top or the most expensive products appear at the top and the least expensive products appear at the bottom. Alright. Next. Now let's see how you can create a data frame from the given table. So as you know, using Jupyter Notebook and Pandas, you can create data frames and work on it very easily. So with this table also we can create our own data frame. So for that, let me create an empty list first. I'll write from db equal to, I'll assign this as an empty list. So we are going to return a list of lists and then create a Pandas data frame. Next, I'll write my for loop. I'll write for result in results. I'll assign result to list of results. So I'm converting the result into a list and then I'm going to append it to the empty variable or the empty list, which is from underscore db dot append. I'll append the result to my empty list. Next, we need to pass in the columns now that will be part of our data frame. So I'll write columns equal to this column. I'll pass it within a list. So I'll give my first column as order ID. Then we have the customer name. Next, I have my product name.
Good grammar and spelling are important, but if you want to write essays that inspire,
ordered, give a comma, and then we'll have the quantity column. Let me write it in the next line. Next, we have the unit price column, and finally we have the phone number column. So I'll write within double quotes phone number, and this we are going to assign it to a data frame. So I'll be using pd dot data frame, which is my function to convert a list into a data frame. My variable I'm going to pass is from underscore db, and I'll write my next argument is columns equal to my variable name, that is columns. Finally, let's display the data frame, which is df. Alright, so here I'm creating a empty list first, and then I'm creating a for loop, and I'm appending the results to my empty list. Here you can see I have created my column list. Using pd.dataFrame, I'm converting the list into a data frame.
After you take those two
screws
out, this bracket comes off.
This is append and not appends.
Motherboard screws, except for these two.
You can see we have our
they're still kind of
data frame ready. This is the index column. It starts from 0 onwards, and then we have the different
everything is soldered onto it, usually just to trick you so that you think you
now
have
let's
to take
see
something
how
out.
to use the update command.
Button fingerprint. Do I have to take them all out?
Now suppose
power button thinks that it's permanently pressing.
Change the unit price of one of the orders,
or it won't even turn on
you can use the update command. So the way to do it, I'll first
now we're gonna close this thing
create
back
my
up.
variable, let's say update.
It did get a little crease
and
in
I'll
it, but
give 3 quotes or triple quotes. Then I'll use my update command, which is update followed by the table name, that is orders. Next I'll write set, let's say unit underscore price. If you see this, let's say I want to set the unit price of trousers from $50 to, let's say, $45. I want to update this particular record. So I'm going to write set unit price column equal to $45, where the order ID equal to 103. So this query will update the third row in our table, which is order ID 103. So it will update from $50 to $45. I'll close the triple quotes, and now I'll use the connection queries again. Let me just paste it here. Alright, I'll delete these 3 lines of code, and instead of that I'll put execute underscore query, and this will take into parameters as always, which is going to be connection followed by the variable name, that is update. Let's run it. You see here it says MySQL database connection successful, query was successful. Now you can recheck that. To do it, let me just go to the top and we'll just copy our first query, which is Q1. I'll copy this and I'll paste it here. Let me just rename this now. This will be Q8, and I'll change this as well. I'll write select star from orders, where my order ID equal to 103. Let's see the unit price of 103 now. You can see here instead of 50, now we have updated it to $45. Alright, now the last command we are going to say is how you can delete a record from the table. I'll write delete command as my comment. Now to delete a query, I'll first give my variable name, which is delete underscore order, and I'll pass in within triple quotes. Next I'll write my delete query, which is delete from my table name, that is orders. Then I'll give my where clause, where let's say I want to delete my order ID 105. Let me just go to the top and explain you again. So if you say this, we want to delete the order ID 105, which was for customer name Maria and she had ordered headphones. We want to completely remove this particular record. So I have my delete query ready. Now let me just create my connection and display the results. So I'll go to the top and I'll copy this connection command, which also has the execute query command, and I'll paste it here. And I'm going to make a change here. Instead of update, we'll write delete underscore order. Everything looks good. Let's just run it. You can see our query was successful. And now if you want to print it, let me just show you. I'll just copy this. We'll paste it here. I'll make this as Q9. I want to verify if my order ID 105 was deleted or not. Instead of this statement, I'll write select star from orders, and here I'll change this to Q9. If I run this, you can see it here. You can mark order ID 105 was deleted and it no more appears in this table. Alright, So this brings us to the end of the demo session on SQL with Python. Let me just scroll you through what we did. So first we imported the important libraries, MySQL connector, then we imported the error function, then we imported pandas using PD. We learned how to create a server connection to MySQL database. We created a new database, that is MySQL_Python, and now we connected to that database. We created a function to execute our queries. We saw how you can write a create table command. Then we inserted a few records to our orders table. We created a read_query command to read the queries and display the results. Then we started exploring our different SQL commands one by one. We saw how to use select query. Then we selected a few individual columns from our table, followed by using a inbuilt function which was year. Then we saw how to use the distinct keyword. After that, we used our where clause to filter our table based on specific conditions. We saw how to order your results based on a particular column. Then we saw how you could convert the table into a data frame using pd.dataframe function. Finally, we learned how to use the update command and the delete command. PostgreSQL is a very popular and widely used database in the industries. In this tutorial, we will learn Postgres SQL or PostgreSQL in detail with an extensive demo session. So in today's video, we will learn what PostgreSQL is and look at the history of PostgreSQL. We will learn the features of PostgreSQL and jump into performing PostgreSQL commands on the SQL cell and pgadmin. So let's begin by understanding what is PostgreSQL. PostgreSQL is an open source object relational database management system. It stores data in rows with columns as different data attributes. According to the DB Engine's ranking, PostgreSQL is currently ranked 4th in popularity amongst hundreds of databases worldwide. It allows you to store, process and retrieve data safely. It was developed by a worldwide team of volunteers. Now, let's look at the history of PostgreSQL. So in 1977 onwards, the Ingress project was developed at the University of California, Berkeley. In 1986, the Postgres project was led by Professor Michael Stonebraker. In 1987, the first demo version was released. And in 1994, a SQL customer name. Next, I have my product name.
Good grammar and spelling are important, but if you want to write essays that inspire,
ordered. Give a comma, and then we'll have the quantity column. Let me write it in the next line. Next, we have the unit price column, and finally we have the phone number column. So I'll write within double quotes phone number, and this we are going to assign it to a data frame. So I'll be using pd.dataframe, which is my function to convert a list into a data frame. My variable I'm going to pass is from_db, and I'll write my next argument is columns equal. That will help you display all the databases that are already there. So if I hit SQL or PostgreSQL in detail with an extensive demo session. So in today's video, we will learn what PostgreSQL is and look at the history of PostgreSQL. We will learn the features of PostgreSQL and jump into performing PostgreSQL commands on the SQL cell and pgadmin. So let's begin by understanding what is PostgreSQL. PostgreSQL is an open source object relational database management system. It stores data in rows with columns as different data attributes. According to the DB Engine's ranking, PostgreSQL is currently ranked 4th in popularity amongst hundreds of databases worldwide. It allows you to store, process and retrieve data safely. It was developed by a worldwide team of volunteers. Now, let's look at the history of PostgreSQL. So in 1977 onwards, the Ingress project was developed at the University of California, Berkeley. In 1986, the Postgres project was led by Professor Michael Stonebraker. In 1987, the first demo version was released, and in 1994, a SQL interpreter was added to Postgres. The first PostgreSQL release was known as version 6.0 or 6.0 on January 29, 1997, and since then, PostgreSQL has continued to be developed by the PostgreSQL Global Development Group, a diverse group of companies and many thousands of individual contributors. Now, let's look at some of the important features of PostgreSQL. So PostgreSQL is the world's most advanced open source database and is free to download. It is compatible as it supports multiple operating systems such as Windows, Linux and Mac OS. It is highly secure, robust and reliable. PostgreSQL supports multiple programming interfaces such as C, C++, Java and Python. PostgreSQL is compatible with various data types. It can work with primitives like integers, numeric, string and boolean. It supports structured data types such as date and time, array and range. It can also work with documents such as JSON and XML. And finally, PostgreSQL supports multi-version concurrency control or MVCC. Now with this theory knowledge, let's look at the PostgreSQL commands that we will be covering in the demo. So we will start with the basic commands such as select, update and delete. We will learn how to filter data using where clause and having clause in SQL. We will also look at how to group data using the group by clause and order the result using the order by clause. You will learn how to deal with null values, get an idea about the like operator, logical operators such as AND and OR. We will also explore some of the popular inbuilt mathematical and string functions. Finally, we will see some of the advanced concepts in PostgreSQL, that is, to write case statements, subqueries and user-defined functions. So let's head over to the demo now. Okay, so let's now start with our demo. So first we'll connect to PostgreSQL using PSQL cell. So here under type here to search, I'll search for PSQL. You can see this is the SQL cell. I'll click on open. Let me maximize this. Okay, so for server I'll just click enter. Database I'll click enter. Port number is already taken, which is 5432. I'll hit enter. Username is already given, and now it is going to ask for password. So here I'll give my password so that I can connect to my PostgreSQL database. So it has given us a warning, but we have successfully connected to PostgreSQL. Alright, so now to check if everything is fine, you can just run a simple command to check the version of PostgreSQL that we have loaded. So the command is select version with two brackets and a semicolon. I'll hit enter. Okay, you can see the version PostgreSQL 13.2. Okay, now let me show you the command that will help you display all the databases that are already there. So if I hit /L and hit enter, it will give me the list of databases that are already there. So we have PostgreSQL, there's something called template 0, template 1, and we have a test database as well. Okay, now for our demo, I'll create a new database. So first I'll write create space database, and I'll give my database name as SQL_demo. I'll give a semicolon and hit enter. You see we have a message here that says create database. So we have successfully created our SQL demo database. Now if you want to connect to that database, you can use \c space SQL_demo. There you go. It says you are now connected to database SQL_demo. So here we can now create tables, we can perform insert operation, select operation, update, delete, alter and much more. Now I'll show you how to connect to PostgreSQL using pgadmin. So when you install the PostgreSQL database, you will get the SQL cell, and along with that you also have the pgadmin. So I'll just search for pg. You can see here it has prompted pgadmin. I'll click on open. This will open on a web browser. You can see it has opened on Chrome, and this is how the interface of pgadmin looks like. It is a very basic interface. So on the top you can see the files, we have object, there's tools, and we have the help section as well. And here you have dashboard, properties, SQL, statistics, dependencies, dependence, and here on the left panel you have servers. Let me just expand this so it will connect to one of the databases. Alright, so if I go back, you see when I had run \L to display the databases, it had shown me PostgreSQL and test. Now you can see here we have the PostgreSQL database and the test database. Alright, now we also created one more database which was SQL demo. So let me show you how to work on this PG admin and the query tool. Alright, so I'll right click on SQL demo and I'll select query tool. I'll just show you how to run a few commands on the query tool. So let's say you want to see the version of PostgreSQL that you are using, so you can use the same command that we did on PSQL cell, which is select version closed with brackets and a semicolon. I'll select this, and here you can see we have the execute button. So if I hit execute or press F5, it will run that query. You can see we have the output at the bottom and it says PostgreSQL 13.2 compiled by Visual C++. It has the 64-bit system. Okay, now let me tell you how to perform a few basic operations using PostgreSQL commands. So here let's say I'll write select 5 into 3. I'll give a semicolon, select this and hit F5. So this will run the query and it returns me the result, that is the product of 5 and 3, which is 15. Similarly, let's edit this. Let's say I'll write 5 plus 3 plus, let's say, 6. I'll select this and hit F5 to run it. It gives me the sum of 5 plus 3 plus 6, which is 14. Now the same task you can do it on this cell as well. Let me show you how to do it here. So let's say I'll write select. Let's say I want to multiply 7 into, let's say, 10. You know the result, it should be 70. If I hit enter, it gives me 70. Now this question mark column question wall will deal with this later. Alright, let me go back to my PG admin again. Let me do one more operation. Let's say this time I'll write select 5 multiplied by, and within brackets I'll write 3 plus 4. I'll give a semicolon. So what SQL will do is, first it will evaluate the expression that is there inside the bracket, that is 3 plus 4, which is 7, and then it will multiply 7 with 5. Now let me select this and I'll hit execute. So you can see 7 multiplied by 5 is 35. Alright, now we'll go back to our shell and here I'll show you how to create a table. So we are going to create a table called movies on the cell, that is PSQL cell. So here we will learn how you can create a table and then you can enter a few data into that table. Alright, let me just scroll down a bit. Okay, so my create command goes something like this. So I'll write create table followed by the table name, that is movies. Next, my movies table will have a few columns. Let's say I want the movie ID. After the column name, we need to give the data type. So movie ID, I'll keep it as integer. So integer is one of the data types that is provided by PostgreSQL. Next, my second column in the table would be the name of the movie. So I'll write movie underscore name. So all the variables or the column names should be as per SQL standards. So there shouldn't be any space between the column names. So I have used underscore to make it more readable. So my movie name will be of type varchar or variable character or varying character, and I'll give the size as 40 so that it can hold 40 characters maximum. Next, my third column will have the genre of the movie, so I'll write movie underscore genre. Again, genre is of type varchar. I'll give the size as, let's say, 30. And my final and the last column will have the IMDb ratings, so I'll write IMDb underscore ratings. Now the ratings will be of type real, since it can have floating or decimal point values. If I close the bracket, I'll give a semicolon and I'll hit enter. There you go. So we have successfully created a table called movies. Now let me go back to my PG admin. Alright, so here I have my database, that is SQL demo. I'll just right click on this and click on refresh. Now let me go to schemas. I'll just scroll down a bit. Here under schemas we have something called as tables. Let me expand this. Okay, so you can see we have a table called movies in the SQL demo database now, and here you can check the columns that we have just added. So our movies table has movie ID, movie name, genre and ratings. Alright, now there is another way to create a table. The previous time we created using the SQL cell. Now I'll tell you how to create a table using the PG admin. So here under tables, I'll right click and I have the option to create a table, so I'll select table. Okay, so it's asking me to give the name of the table. So this time we are going to create a table called students. So I'll write my table name as students. Alright, these will be default as it is. Now I'll go to the columns tab. So here you can create the number of columns that you want. So you can see on the right I have a plus sign. I'll just select this so that I can add a new row. So my first column would be, let's say, the student roll number. I'll write student underscore roll number. Again, the column name should be as per SQL standards. The data type I'm going to select is integer. Alright, now if you want, you can give these constraints such as not null, so that student roll number column will not have any null values. And I'll also check primary key, which means all the values will be unique for roll numbers. Alright, now if you want to add another column, you can just click on that plus sign, and let's say this time I want to give the student name as my second column. So I'll write student underscore name. Student name will be of type, let's say, character varying. If you want to give the length, you can specify the length as well, let's say 40. I'll click on the plus sign again to add my final column. The final column would be gender. So gender, I'll keep this time as type character. Okay, now you can click on save, so that will successfully create your students table. There you go. So here on the left panel you can see earlier we had only one table, that was movies, and now we have two tables. So one would be added, that was students. So if I expand this under columns, you can see we have the three columns here: student roll number, student name and gender. You can also check the constraints. It will tell you if you have any constraints. So you can see it says students roll number, there's one primary key. Alright, now let me run a select statement to show the columns that we have in the movies table. So I'll write select star from movies, give a semicolon, and let me execute this. Okay, so here on at the bottom you can see we have the movie ID, the movie name, movie genre and IMDb ratings. Now the next command we are going to learn is how to delete a table. So there is one way by using the SQL command, that is drop table followed by the table name. Let's say you want to delete students. You can write drop table students and that will delete the table from the database. This is one of the methods, so you just select and run it. Now the other way is to you just right click on the table name and here you have delete / drop. If I select this, you get a prompt, are you sure you want to drop table students? I'll select yes. So you can see we have successfully deleted our students table. Alright, now let's perform a few operations and learn a few more commands in PostgreSQL. So to do that, I'm going to insert a few records to my movies table. So for that, I'll use my insert command. So I have my insert query written on a notepad. I'll just copy this and I'll paste it on my query editor. Okay, so let me just scroll down. Alright, so here you can see I have used my insert command. So I have written insert into the name of the table, that is movies, and we have the movie ID, the movie name, movie genre and IMDb ratings, and these are the records or the rows. So we have the first record as movie ID 101. The name of the movie is a very popular movie which is Vertigo. Then we have the movie genre, that is mystery. It is also a romance movie. And then we have the IMDb ratings, the current IMDb rating, that is 8.3. Similarly, we have Shawshank Redemption, we have 12 Angry Men, there's The Matrix, 7, Interstellar and The Lion King. So there are total 8 records that we are going to insert into our movies table. So let me just select this and hit execute. Okay, you can see it has returned successfully 8 records. Now if I run select star from movies, you can see the records that are present in the table. So I'll write select star from movies. I'll select this and I'll execute it. There you go. At the bottom you can see 8 rows affected. If I scroll this down, you have the 8 records of information in the movies table. Alright, now if you want to describe the table, you can go to the SQL cell and here if you write \d and the name of the table, that is movies, this will describe the table. So here you have the column names, this has the data type, and here you can specify if there are any null values or any constraints like default constraint or primary key or foreign key and others. Let me go back to my pgadmin. Okay, now first and foremost, let me tell you how to update records in a table. So suppose you have an existing table and by mistake you have entered some wrong values and you want to update those records later. You can use the update query for that. So I'm going to update my movies table and I'll set the genre of movie ID 103, which is 12 Angry Men, from drama to drama and crime. So in our current table we only have genre as drama for 12 Angry Men. I am going to update this column, which is the movie genre, to drama and crime. Okay, so let me show you how to do it. I'll write update followed by the name of the table, that is movies. I'll go to the next line. I'll write set, then I'll give the column name, which is movie underscore genre, equal to, I'm going to set it as drama, comma, crime. Earlier it was only drama, and I'll give my condition using the where clause. We'll learn where clause in a bit. So I'll write where movie underscore ID is equal to 103. So here our movie ID is the unique identifier. So it will first look for movie ID 103. It will locate that movie and it'll change the genre to drama and crime. So now you can see the difference. Earlier we had 12 Angry Men as drama as the movie genre. Now if I run this update statement, okay, you can see we have successfully updated one record. Now let me run the select statement again. Okay, so here you can see if I scroll down, there you go. So movie ID 103, movie name 12 Angry Men, we have successfully updated the genre as drama, crime. Okay, now let me tell you how you can delete records from a table. So for that you can use the delete command. So you'll write delete from the table name, that is movies, where let's say I want to delete the movie ID 108, which is the Lion King. So I'll write where movie underscore ID is equal to 108. This is one of the ways to delete this particular movie, or you can give, let's say, where movie name is equal to the Lion King. Let me select this and I'll hit execute. Now if I run my select query again, you see this time it has returned 7 rows and you cannot find movie with movie ID 108, that was the Lion King. So we have deleted it. Alright, next we are going to learn about where clause in PostgreSQL. So to learn where clause, I'll be using the same movie table again. Let's say we want to filter only those records for which the IMDb ratings of the movies is greater than 8.7. So this is my updated table now. I want to display only those records or those movies whose IMDb ratings is greater than 8.7. So we'll display 12 Angry Men, which is 9. Then we are going to display The Dark Knight, which is again 9. And we are also going to display the Shawshank Redemption, which has 9.3. The rest of the movies have an IMDb rating less than 8.7. So we are not going to display those. Alright, so let me show you how to write a where clause. So I'll write select star from movies where I'll give my column name, that is IMDb underscore ratings is greater than, I'll use the greater than symbol, then I'll pass my value, that is 8.7. I'll give a semicolon and let's run it. I'll hit F5. There you go. So we have returned the Shawshank Redemption, The Dark Knight and 12 Angry Men because only these movies had IMDb ratings greater than 8.7. Okay. Now let's say you want to return only those movies which have IMDb ratings between 8.5 and 9. So for that I am going to use another operator called between along with the where clause. So let me show you how to use between with where clause. I'll write select star from movies where my IMDb underscore ratings is between, I'll write 8.5, I'll give an AND operator and 9.0. So all the movies that are between 8.5 and 9.0 ratings will be displayed. So let's select this and I'll run it. There you go. So we have returned The Dark Knight, The Matrix, The 7, Interstellar, and we have the 12 Angry Men. So a few of the records that we missed out were, I think, Vertigo, which has 8.3, and there's one more. Alright. Now moving ahead, let's say you want to display the movies whose movie genre is action. You can see in our table we have a few movies whose genre is action movie. So you can do that as well. I'll write select star from movies where the movie genre, I'm writing this time in one line. You can break it into 2 lines as well. I'll write movie underscore genre, which is my column name, equal to, I'll give within single quotes action. Now why single quote? Because action is a string, hence we need to put it in single quotes. If I run this, There you go. So we had one movie in our table whose movie genre was action, that is The Dark Knight. Okay. Now you can also select particular columns from the table by specifying the column names. Now here in all the examples that we saw just now, we are using star. Now star represents, it will select all the columns in the table. If you want to select specific columns in the table, you can use the column names. So you can specify the column names in the select statement. Let me show you. Let's say you want to display the movie name and the movie genre from the table. So you can write select movie underscore name, comma, I'll give the next column as movie underscore genre from my table name, that is movies, where let's say the IMDb underscore ratings is less than 9.0. So this time in our result it will only show two columns, that is movie name and movie genre. Let me run it. There you go. So these are the movie names and the movie genres you can see that have an IMDb ratings less than 9.0. Alright. Like how you saw the between operator, there is one more operator that you can use with the where clause, that is the in operator. So the in operator works like a or clause or an or operator. So let's say I want to select all the columns from my movies table where the IMDb ratings is in 8.7 or 9.0. If I run this, it will display only those records whose IMDb ratings is 8.7 or 9.0. Alright, so up to now we have looked at how you can work on basic operations in SQL like your mathematical operations. You saw how a select statement works. We created a few tables, then we inserted a few records to our tables. We saw how you can delete a table from your database, and we have performed a few operations like update, delete, and we saw how a where clause works. Now it's time to load a employee CSV file or a CSV dataset to PostgreSQL. So I'll tell you how you can do that. But first of all, before loading or inserting the records, we need to create an employee table. So let me first go ahead and create a new table called employees in our SQL underscore demo database. So I'll write create table. My name of the table would be employees. Next, I'm going to give my column names. So my first column would be employee ID. So the employee ID will be of type integer. It is not going to contain any null values. So I'll write not null, and I'll give my constraint as primary key. So the employee ID, as you know, is unique for all the employees in a company. So once I write primary key, it will ensure that there are no repetition in the employee IDs. Okay. Next, I'll have my employee name. So my employee name is going to be of type varchar, and I'll give my size as 40. Okay. Next, we'll have the email address of the employee. Again, email address would be of type varchar and the size is 40 again. I'll give another comma. This time we'll have the gender of the employee. Gender is again varchar of size, let's say 10. Okay. Now let's include a few more columns. We'll have the department column. So I'll write department varchar. Let's say the size is 40. Then let's say we'll have another column that is called address. So the address column will have the country names of the employees. address is also varchar, and finally we have the salary of the employee. Salary, I'm going to keep it as type real. So real will ensure it will have decimal or floating point values. Okay, so now let me select this create table statement and execute it. Alright, so we have successfully created our table. If you want, you can check by using select star from employees. Let me select this and I'll hit execute. Alright, you can see we have our employee ID as primary key. There's employee name, email, gender, there's department, address and salary. But we don't have any records for each of these columns. Now it's time for us to insert a few records to our employees table. Now to do that, I'm going to use a CSV file. So let me show you how the CSV file looks like. Okay, so now I am on my Microsoft Excel sheet, and on the top you can see this is my employee data.csv file. Here we have the employee ID, the employee name, email, gender, there's department, address and salary. Now this data was generated using a simulator, so this is not validated, and you can see it has a few missing values. So under email column we have a few employees who don't have an email ID. Then you can see under department also there are some missing values here as well. Alright, so we'll be importing this table or the records present in this CSV file onto PostgreSQL. Alright, so here in the left panel under tables, let me right click and first refresh this. There you go. So initially we had only movies table, and now we also have the employees table. Now what we need to do is I'll right click again, and here you see we have the option to import or export. Let me click on this, and I don't want to export, I need to import, so I'll switch on import. Alright, now it is asking me to give the file location. So let me show you how to get the file location. So this is my file location actually. So my Excel file, which was this, is present in my E drive under the data analytics folder. I have another folder called PostgreSQL, and within the PostgreSQL folder I have my CSV file, that is employee data.csv. So I'll just select this. You can either do it like this or you can browse and do. Okay, now my format is CSV. Next, I'm going to select my headers as yes, and then let me go to columns and check if everything is fine. Alright, so I have all my columns here. Let's click on OK. You can see I have a message here which says import _ export. Alright, so here you can see successfully completed. We can verify this by using select star from employees again. If I run this, alright, let me close this. There you go, it says 150 rows affected, which means we have inserted 150 rows of information to our employees table. You can see we have the employee ID, these are all unique. We have the employee name, the email, we have the address and the salary. Let me scroll down so that, okay, you can see we have 150 rows of information. That means we have 150 employees in our table. Okay, now we are going to use this employees table and explore some advanced SQL commands. Now there is an operator called distinct. So say if I write select address from employees, this is going to give me 150 address of all the employees. There's some problem here, I did a spelling mistake. There should be another D. If I run this again, our query will return 150 rows. You can see we have the different country names under address, that is Russia, we have France, there's United States, we have Germany, okay, and I think we have Israel as well. Yeah. Now suppose you want to display only the unique address or the country names, you can use the distinct keyword before the column name. So if I write select distinct address from employee, it will only display the unique country names present in the address column. If I run this, see, it has returned us 6 rows of information. So we have Israel, Russia, Australia, United States, France and Germany. Alright. Now, as I said, there are a few null values which don't have any information. So you can use the isNull operator in SQL to display all the null values that are there. Suppose I want to display all the employee names where the email ID has a null value. So I'll write select star from employees where email is null. So this is another way to use your where clause. If I select and run this, there you go. So you see here, for all these employee names, there was no email ID present in the table. So it has returned us 16 rows of information. So around 10% of employees do not have an email ID, and if you see, a few of them do not have an email ID and also they don't have a department. So if you want to know for those employees which do not have a department, you can just replace where department is null instead of where email is null. Now if I select this, okay, it has returned us 9 rows of information, which means around 5% of employees do not have a department. Moving ahead, now let me show you how the order by clause works in SQL. Now the order by is used to order your result in a particular format, let's say in ascending or descending order. So the way to use is, let's say I want to select all the employees from my table, so I'll write select star from employees order by. I want to order the employees based on their salary, so I'll write order by salary. Let me select and run it. Okay, there is some problem. I made a spelling mistake. This should be employees. Let me run it again. Okay, now if you mark the output, our result has been ordered in ascending order. So all the employees which have salary greater than $45,000 appear at the top, and the employees with the highest salaries appear at the bottom. So this has been ordered in ascending order, which means your SQL or PostgreSQL orders it in ascending order by default. Now let's say you want to display the salaries in descending order so that all the top ranking employees in terms of salary appear at the top. So you can use the DESC keyword, which means descending. If I run this, you can see the difference now. So all the employees with the highest salary appear at the top, while those with the lowest salaries appear at the bottom. So this is how you can use an order by clause. Okay, so now I want to make a change in my existing table. So here if you see, under the address column we only have the country names, so it would be better if we change the name of the address column to country. So I want to rename a column. You can do this using the alter command in PostgreSQL. So let me show you how to rename this column, that is address. So I'll write alter table followed by the table name, which is employees. Then I'm going to use rename column address. I'll write to, I want to change it to country. If I give a semicolon and hit execute, it will change my column name to country. Now you can verify this. If I run the select statement again, there you go. Earlier it was address column and now we have successfully changed it to country column. Okay, let me come down. Now it's time for us to explore a few more commands. So this time I'm going to tell you how an AND and an OR operator works in SQL. So you can use the AND and OR operator along with the where clause. So let's say I want to select the employees who are from France and their salary is less than $80,000. So let me show you how to do it. I'll write select star from employees where I'm going to give two conditions. So I'll use the AND clause or the AND operator here. I'll write where country is equal to France. Now mark here I'm not using address because we just updated our table and changed the column name from address to country. So I'll write country equal to France, and my next condition would be my salary needs to be less than $80,000. I'll give a semicolon. Let me run this. Alright, so it has returned 19 rows of information. You can see all my country names are France and the salary is less than $80,000. So this is how you can use or give multiple conditions in a where clause using the AND operator. Now let's say you want to use the OR operator, and let's say you want to know the employees who are from country Germany, or the department should be sales. So I'll write select star from employees where country is equal to Germany, and instead of AND I'm going to use OR. Their department should be sales. Okay, now let's see the output. I'll hit F5 this time to run it. Alright, so we have 23 rows of information now. Let me scroll to the right. You can see either the country is Germany or the department is sales. You see one of them in the table. So here for the first record the country was Germany, the second record the department was sales, again for the fourth record the country is Germany. So this is how the OR condition works. So if one of the conditions are true, it will return the result. It need not be that both the conditions should satisfy. Now in PostgreSQL there is another feature that is called limit. So PostgreSQL limit is an optional clause on the select statement. Now this is used as a constraint which will restrict the number of rows returned by the query. Suppose you want to display the top 5 rows in a table, you can use the limit operator. Suppose you want to skip the first 5 rows of information and then you want to display the next 5, you can do that using limit and offset. So let's explore how limit and offset works. I'll write select star from employees. Let's say I'll use my order by clause. I'll write order by salary, let's say in descending, and limit it to 5. This is going to display the top 5 employees which have the highest salary. If I run this, there you go. You see it has given us 5 rows of information, and these are the top 5 employees that have the highest salary. Okay, so this is one method of, or one way of using the limit clause. Now in case you want to skip a number of rows before returning the result, you can use offset clause placed before the limit clause. So I'll write select star from employees, let's say order by salary, descending. This time I'm going to use limit 5 and offset 3. So what this query will do is it will skip the first 3 rows and then it will print the next 5 rows. If I run this, there you go. So this is how the result looks like. Okay. Now there is another clause which is called fetch. Let me show you how that works. I'll copy my previous SQL query, I'll paste it here, and here after descending I'm going to write fetch first 3 row only. So my fetch is going to give me the first 3 rows from the top. There you go, it has given us the first 3 rows, and you can see the top 3 employees that have the highest salary, since we ordered it in descending order of salary. Alright, you can also use the offset along with the fetch clause. I'll copy this again and let me paste it here. Now after descending I am going to write offset, let's say 3 rows, and fetch first 5 rows only. So what this SQL query is going to do is it will skip the first 3 rows of information and then it is going to display the next 5 rows. It is going to work exactly the same as we saw for this query. Let me run it. There you go. So these are the first 5 rows of information after excluding the top 3 rows. Alright, we have another operator that is called as like in PostgreSQL. So like is used to do pattern matching. So suppose you have a table that has the employee names, you forgot the full name of an employee but you remember the few initials, so you can use the like operator to get an idea as to which employee name it is. Now let's explore some examples to learn how the like operator works in PostgreSQL. So suppose you want to know the employees whose name starts with A, so for that you can use the like operator. Let me show you how to do it. So I want to display the employee name, and let's say I want to know their email IDs from the table name, that is employee, where since I want to know the employees whose name starts with A, so I'll write employee name like. Now to use the pattern is within single quotes I'll write A and then followed by percentage. Now this means the employee name should have an A in the beginning, and percentage suggests it can have any other letter following A, but in the beginning or the starting should be A. If I run this, so there is an error here, the name of the table is employees and not employee. Let's run this again. There you go, you can see there are 16 employees in our table whose name starts with A. You can see this column employee name, all of them have a letter A in the beginning. Okay, now let me just copy this command or the query. I'll paste it here. Let's say this time you want to know the employees whose name starts with S. So instead of A I'll write S. So this means the starting letter should be S and followed by it can have any other letter. If I run this, so there are 10 employees in the table whose name starts with S. Okay, let's copy the query again, and this time I want to know the employees whose name ends with D. Now the way to do it is instead of a percentage I'll write this time percentage D, which means at the beginning it can have any letter, but the last letter in the string or in the name should be ending with D. Now let me copy and run this. So there are 13 employees in the table whose name ends with a D. You can see it here. Alright, now let's say you want to find the employees whose name contains ISH or have ISH in their names. So the way to do is something like this. So I'll copy this. Now here instead of a percentage I'll replace this with percentage ISH percentage. Now this means that in the beginning it can have any letter and towards the end also it can have any letter, but this ISH should appear within the name. Let me run and show it to you. Okay, so there is one employee whose name contains ISH. You can see here there is an ISH in the last name of the employee. Alright, now suppose you want to find the employee name which has U as the second letter. It can have any letter in the beginning, but the second letter of the employee name should have U. Now the way to do is, I'll copy this, and instead of %, I'll write underscore U followed by %. Now this underscore, you can think of a blank that can take any one letter. So the beginning can start with A, B, C, D, or any of the 26 alphabets we have. Then it should contain U as the second letter followed by any other letter or letters. Let me run this. Okay, so there are 10 employees in the table whose name has a U as the second letter. You can see these. Okay, now moving ahead, let me show you how you can use basic SQL functions or inbuilt functions. So we'll explore a few mathematical functions now. So let's say you want to find the total sum of salary for all the employees. So for that you can use the sum function that is available in SQL. So I'll write sum, and inside the sum function I'll give my column name, that is salary, from my table name, that is employees. Let's see the result. This will return one unique value. There you go. Now this is the total salary. Since the value is very large, it has given in terms of E. Now one thing to note here is, if you see the output, the column says sum real. So this output column is not really readable. So SQL has a method which can fix this, that is called an alias. So since we are doing an operation of summing the salary column, we can give an alias to this operation by using the as keyword. So if I write sum of salary as, let's say, total salary, then this becomes my output column. You can see the difference if I run this. Okay, you can see now in the output we have the total salary. Now this is much more readable than the previous one. So this is a feature in Excel where you can use or give alias names to your columns or your results. Now similarly, let's say you want to find the average of salary for all the employees. Now SQL has a function called AVG which calculates the mean or the average salary. If I write AVG, and I can edit my alias name as well. Let's see, I'll write mean salary. Let's run it. You can see the average salary for all the employees. It's around $81,000. Okay, now there are two more important functions that SQL provides us, which is max and minimum. So if I write select maximum or max, which is the function name of salary, as, let's say, instead of total I'll write maximum. So this will return me the maximum salary of the employee. Let's run it and see what is the maximum salary that is present in the salary column. Alright, so we have $1,19,616 as highest salary of one of the employees. Similarly, you can use the min function as well. I'll just write minimum, and this will return me the minimum salary of one of the employees in the table. I'll replace the alias name as minimum. Okay, now run it. This will give me the minimum salary that is present in our table. So it is $45,685. Okay, now let's say you want to find the count of department in the employees table. You can use the count function. So if I write select count, let's say I want to know the distinct department names, I can write inside the count function distinct department, as total departments from employees. Let's run this. This will return me the total number of departments that are there. So it gives me there are 12 departments. Okay, now let me show you one more thing here. If I write select department from employees, let's run this. Okay, so it has returned me 150 rows of information, but what I'm going to do is I'll place my distinct keyword here just before the column name so that I can verify how many departments are there in total. There you go. So there are 13 departments and one of them is null. So moving ahead, we'll replace this null with a department name by updating our table. Okay. So now let's update our department column. So what we are going to do is, wherever the department has a null value, we are going to assign a new department called analytics. So earlier we have also learned how to use the update command. So I'm going to show it again. So we'll write update followed by the table name, that is employees. I'm going to set my column, that is department, equal to, within single quotes, my name of the department would be analytics, where department is, I'll say null. So wherever the department has a null value, we'll replace those information with department, that is analytics. Let's run this. You can see query returned successfully. Now let's say I'll run this command again, and this time you can see the difference. There you go. So we have 13 rows of information and there is no null department now. We have added a new department, that is analytics. Okay, now we are going to explore two more crucial commands or clauses in SQL, that is group by and having. So let's learn how group by clause works in PostgreSQL. So the group by statement groups rows that have the same values into summary rows. For example, you can find the average salary of employees in each country or city or department. So the group by clause is used in collaboration with the select statement to arrange identical data into groups. So suppose you want to find the average salary of the employees based on countries, you can use the group by clause. So let me show you how to do it. I'll write select. I want the countries and the average salary for each country. So I'll use the average function, that is avg, and inside the function I'll pass my column, that is salary. I'll give an alias name as, let's say, average underscore salary from my table name, that is employees. Next I'm going to use my group by clause. So I'll write group by, since I want to find the average salary for each country, so I'll write group by country name. Let's give a semicolon and let me run it. I'll use F5. There you go. So here on the left you can see the country names. We have Israel, Russia, Australia, United States, France and Germany, and on the right, the second column, you can see the average salary for each of these countries. Now you can also order the result in whichever way you want. Suppose you want to arrange the results based on the average salary, so you can use the order by clause after the group by clause. So I'll write order by. Here you can use the alias name, that is average salary. This is actually average underscore salary, and let's say I want to arrange it in descending order, so I'll write DESC. Now let's run this. You can mark the difference in the average salary column. There you go. So as per our result, in United States, the average salary is the highest, and if I scroll down, the average salary is the lowest in Germany. Now let's see one more example using group by. Suppose this time you want to find the maximum salary of male and female employees. You can do that too. So let me show you how to do it. So I'll write select. This time we want to find the maximum salary based on gender. So I'll select my gender column, comma, and this time I'll use my max function. Since I want to find the maximum salary for male and female employees, I'll give an alias name as maximum underscore salary from my table, that is employees, group by, I'll write gender. Okay, so let's run this. There you go. You can see, so one of the female employees had a highest salary of $1,19,616, while of that of a male was $1,17,654. Alright, now suppose you want to find the count of employees based on each country. You can use the count function along with the group by clause. So I'll write the select statement, select, since I want to count the employees based on each country, so I'll first select my country column and then I'm going to use the count function. I'll write count emp underscore id from my table name, that is employees. I'm going to group it by country. So this query will give me the total number of employees from each country. You can see here Israel there are 4 employees, in Australia there are 4 employees, in Russia we have 80 employees, in France there were 31, in United States we have 27, so on and so forth. Now let me scroll down. Okay, now it's time to explore one more clause, a very important clause that is used in PostgreSQL, that is having. So the having clause works like the where clause. The difference is that where clause cannot be used with aggregate functions. The having clause is used with the group by clause to return those rows that meet a condition. So suppose you want to find the countries in which the average salary is greater than $80,000. So you can use the group by clause and the having clause to get the result. So I'll write my select statement as select country, comma, I want the average salary, so I'll write avg of salary. I can give an alias name as average salary from employees. Now I'm going to group it by each country, so group by country column. Since I want to find the countries in which the average salary is greater than 80,000, so I'll use having clause after the group by clause. I'll write having average of salary is greater than 80,000. Now this condition cannot be specified in the where clause, so we need a having clause. You cannot use aggregate functions along with where clause. Let me just run it now. There you go. So we have Russia and United States where the average salary is greater than $80,000. Alright. Now let's say you want to find the count of employees in each country where there are less than 30 employees. So for this I am going to use the count function. First let me select the country column. Then I'm going to use the count function, and in the count function I'm going to pass my employee ID so that we can count the number of employees from my table, that is employees. Now if you want you can use an alias name for this as well, but I am just skipping it for the time being. I'll write group by country. Next I'll write having count of employee ID less than 30. So this will return me the countries in which there are less than 30 employees. Let's run it. You can see here Israel, Australia, United States and Germany are the countries in which there are less than 30 employees. Okay, now if you want you can use the order by clause as well. So suppose I'll write here order by count of employee ID. So what this will do is it will arrange my result in ascending order of employee ID count. There you can see we have successfully arranged our result in ascending order of employee IDs. Okay, next we are going to explore one more feature of PostgreSQL, that is of using a case statement. Now in PostgreSQL the case expression is same as if-else statement in any other programming language. It allows you to add if-else logic to the query to form a powerful query. Now let me just scroll down and I'll show you how to use a case statement. This is very similar to your if-else statement that you use on Excel, in C++, in Python or any other programming language. So what I'm going to do is I'm going to write a SQL query that will create a new column, and the name of the column would be, let's say, salary range. So I'm going to divide my salary. Suppose if the salary is greater than $45,000 and if it's less than $55,000, in the new column, that is salary range, we are going to assign a value low salary. Now if the salary is greater than $55,000 and if it is less than $80,000, we are going to assign a value that is medium salary. If the salary is greater than $80,000, we'll assign a value high salary. So all this we are going to do using our case expression in PostgreSQL. So I'll start with my select statement, but before that let me show you how to write a comment in PostgreSQL. So you can write a comment by giving a double dash. Comments are very helpful because they make your codes or the scripts readable. I'll write case expression in PostgreSQL. Similarly, if you want, you can go to the top and let's say here you can write with double dash having clause. Okay, let's come down. So I'll write my select statement as select. I want the department, the country and the salary column. I'll give a comma and I'll start with my case statement. I'll write case when my salary is greater than 45,000 and my salary is less than 55,000, then the result would be, within single quotes, I'll write low salary. So this is exactly like an if-else condition. Next, I'll write another case when salary is greater than 55,000 and salary is less than, let's say, 80,000, then the result would be medium salary. And finally, I'll give my last condition, that is when salary is greater than 80,000, then the result will be high salary. Let me write this in a single line, then high salary. Now one thing to remember, in PostgreSQL the quotes are insensitive, so you can write your select statement in capital, in lowercase or in sentence case. Similarly, I can write case as small c or you can write as capital C. Alright, now moving ahead, after this I am going to write end. I'll give an alias name as salary range. Now this is going to be my new column in the output. Let me just come down. After this, we need to give our table name from employees. I'll order it by salary descending. Okay, so what I'm going to do here is I'll first select department, country and salary column from my employees table, and then I'm creating a new column that is salary range, and I'm specifying the range. So I have 3 conditions here for low salary, for medium salary and high salary. So let's run this and see the output. There you go. Here you can see we have added a new column known as salary range, and we have ordered our salary in descending order, so all the highest salaries appear at the top. If I just scroll down, you can see we have medium salaries here, and if I scroll down further, you can see these low salaries. So case statements are really useful when you want to create a new column based on some conditions in the existing table. Alright, now moving ahead, we are now going to see how to write subqueries in PostgreSQL. So subqueries, we write query inside another query, which is also known as nested query.
The level that I am,
so suppose
it's like
we want to find the employee name, NBA, department, country and salary of those employees whose salary is greater than the average salary. So in such cases, you can use subqueries. But let me show you how to write a query inside another query. First, I'll write the select statement. I am going to select the employee name,
Messi, with Lewandowski, with Higuain,
I want the department,
with the top of the best players in the world. So,
comma,
I mean, this is
also
not
want to display the
fighting,
country name,
but it's hard, it's
salary,
healthy. You know, comparisons is healthy,
from
and we fight, you know, to be the best.
Employees table.
This is why it's my main point. It's my motivation. It's to be better than them.
Salary
than them year after year.
Greater than the
to
average
be in my
salary.
shoes is not easy.
So after this, where salary greater than, I'm going to use brackets and write my
subquery
that is select.
All this happened
average
because the reason is I'm unbelievable inside the pitch. This is why the people have
employees
so much interesting on me.
Are you the best footballer in the world?
Let me break it down
right
for you.
I think so, yes.
So
in
first,
my mind, I'm always the best.
We are going to select the average salary from the employees.
What they say,
so this
in my mind,
particular SQL statement will find the average salary from the
I'm
table.
Always the best.
We'll compare this average salary with salaries of all the employees.
So thinking we are the best.
Whichever employee has the salary greater than the average salary will display their name, the department, country and their original salary. So if you want, you can run this statement as well. Let me select this statement
almost every day. This is why
and run it for you.
Top level many years.
You can see we have written the average salary of all the employees, which is nearly $81,466. So we want the salaries of the employees to be greater than this average value. So let me run this and see how many employees have a salary greater than the average salary. There you go. So we have around 75 employees whose average salary or whose salary is greater than the average salary.
And I think it's going well on me.
Alright.
This is why I'm
now moving ahead, this time I'm going to tell you how to use some inbuilt functions. We'll learn some inbuilt mathematical functions and string functions that are available in PostgreSQL. So I'll just give a comment. There's another way to write a comment. Instead of a double dash, you can use the /.
I'm always competitive player.
An asterisk, and inside the asterisk you can write, let's say,
with my sister,
SQL
my mom, with my nephews, I'm always try to competitive hard and try to win.
And you need to close this, like so I'll give another asterisk
I'm never change.
A /
because I like this.
So this is also a comment in PostgreSQL.
I'm a happy person.
Alright.
So
first of all, we'll explore a few math functions. So there is a function called APS,
England,
which is used to find the absolute of a value. So if I write select ABS of, let's say, -100,
speak with the ball.
it is going to return me positive 100 or just 100, because as you know, the absolute of any value will remove the negative sign involved in that value. There you go.
This is
so
that
original input was -100, the absolute of -100 is +100.
I don't thinking about that, but my subconscious,
let's see
thinking
another function that is called greatest. So the greatest function in PostgreSQL will return the greatest number in a range of numbers. So suppose I write select greatest.
The most important thing, I knew it, and everyone
inside the greatest function, I'll pass in a few numbers. Let's say 2.
We have everything.
I'm just randomly passing a few numbers.
I have millions, billions.
4.
But the most important thing, it's the family. Keep your family healthy, good, and
let's
take care
70.
of your family, because
give a
this is the most important
Let me
thing
run
in the
this.
world.
You will
Apart
see
of that, of course, you have
the greatest function
your life,
will return the
your
greatest
life, you have your
integer
girlfriend,
value or greatest number
your
that is
cars,
present
your
in the
houses,
range of numbers that
your
we have
fame.
provided. So in this
But
case,
in the beginning,
90
your
was
family,
the
it's
largest
always
number or the
you.
greatest
For the
number,
good
so we
moments
got
and
the
for the
result
bad
as
moments.
90. Again, you can use an alias for each of these statements.
I'm always say it was
Now, like greatest, we also have
in my
a
life.
function called
It
least,
was when
which is
I
going to
left my
return
family
the
with
least
11
number present
years
in
old
the range
to
of
live in a
numbers.
different world,
If I
which
run
is
this,
Lisbon.
so the result is 2 because
In the same
2 is
country,
the
but it looked like
least
it's
number that is present
different part of
in
the
this
world.
selection.
I was cry almost every day to miss my
Now,
family, but I'm not
there's a function called
regret
mod, which is going to return the
because
remainder
it
of a
was
division.
probably the more
select
intense moments in my
mod,
life that I lived
and
through.
this takes 2 parameters.
So
let's say
without sacrifice, we cannot
divided by 10.
win nothing. So I did
As you
an
can
unbelievable
guess, the remainder
sacrifice.
is 4.
My family too, and I think
And
it was.
so is our result.
I did a good
you
option.
can see it has returned the remainder. 54 divided by 10, the remainder is 4. Alright. Let's scroll down. Now let's see how to use the power function. So I'll write select power.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos.
Which is
to nerd up and get certified,
8.
click here.
Let me just run this. There you go. So the result is 8. You can also check, let's say, power of 5, 3. It should be 125. Alright. Next, you can use the sqrt function that is available in PostgreSQL to find the square root of a number. I'll write sqrt, and let's say I want to find the square root of 100. You can guess the result. The output should be 10. If I run this, you can see the output here 10. Let's say I want to find the square root of, let's say, 144. You can again guess the result. It should be 12. Let's verify it. Okay, there is some error. Let me verify it again. There you go. It is 12. Now, there are a few trigonometric functions as well. You can use the sine function, the cos function, and the tan function. Let's say I want to know the sine of 0. If you have studied high school mathematics, you would know the sine of 0 is 0. You can see the result, it is 0. Let's say you want to know sine 90. If I run it, you can see the output here, 0.89. Alright. Now there are other functions like ceiling and floor that you can use. So let me show you what the ceiling and floor function does. I'll write ceiling. Let's say I'll pass my floating value as 6.45 and let me run it. You can see the ceiling function returns the next highest integer, that is 7 in this case, since the next highest integer after 6.45 is 7. Let's see what the floor function does, and let me run it. As you can see, the floor function returns the next lowest integer, that is 6 in this case, or the nearest lowest integer to any provided decimal value. Okay. Now that we saw how to use mathematical functions, there are a few string functions available in PostgreSQL. So let's explore them as well. I'll write string functions. Okay. We'll scroll down. Cool. There's a function called character length that gives you the length of a text string. Suppose I write select, give the function as character length, and inside this function I'm going to pass in a text. Let's say India is a democracy. This is my text. Let me run this. Okay, you can see the result here, which is 20, since there are 20 characters in my string that I have provided. Alright, now there's another function called concat in PostgreSQL. So concat is basically used to merge or combine multiple strings. So I'll write select concat, within brackets I'll give the text string. Now let's say I want to combine Postgres SQL. I'll give a space, comma, I want to merge Postgres SQL is, I'll give another comma and write my final word, that is interesting. Now what we have done is, inside the concat function we have passed in separate strings, and now using the concat function we want to merge the three strings. Let's see what the result is. I'll run it. Alright, let me just expand this. You can see here we have concatenated the three strings successfully, so the output is PostgreSQL is interesting. Okay, now there are functions like left, right and mid in PostgreSQL. So what the left function does is, it will extract the number of characters that you specify from the left of a string. Let's say I'll write select left and I'll pass in my text string as India is a democracy. I'll copy this and I'll paste it here. Let's say I want to extract the first 5 characters from my string, so I'll give 5. So what it will do is, it will count 5 characters from left, so 1, 2, 3, 4 and 5. If I run this, it should ideally print India for me. There you go, it has printed India for us. Alright, similarly you can use the right function to extract few characters from the right of a string. Let's say you want to extract, let's say I'll give 12 characters from right, so from here onwards it will count 12 characters. I'll change left to right now. Let me select this and run it. So you can see here, this is the output. From the right it has counted 12 characters and returned a democracy. Okay, now there is a function called repeat. So the repeat function is going to repeat a particular string the number of times you specify. Let's say I want to select and use my repeat function, and inside the repeat function I'm going to pass in, let's say India, and I want India to be displayed 5 times. I'll give a semicolon and run it. In the output you can see India has been printed 5 times. Okay, let's scroll down. There is another function, a string function in PostgreSQL called as reverse. So what reverse function is going to do is, it is going to print any string passed as an input in reverse order. So if I write select reverse, and inside the reverse function I'll pass in my string, that is India is a democracy. I'm going to use the same string. I'll copy this and I'll paste it here. I'll close the quotes and the brackets. Let's print this. You can see it here, India is a democracy has been printed in reverse order. There you go. Alright, now this time we explored a few inbuilt functions that are already present in PostgreSQL. Now PostgreSQL also has the feature where you can write your own user-defined functions. So now we will learn how to write a function of our own in PostgreSQL. So let's create a function to count the total number of email IDs that are present in our employees table. So for this we'll write a function, a user-defined function. So let me give my comment as user-defined function. Okay, so let me start by first writing create So this is the syntax to write a function in PostgreSQL. So I'll write create or replace function. Then I'll give my function name as count emails, and as you know, functions have brackets. Then I'll write returns, the return type, as integer, then an alias with dollar symbol. I'll write total emails, since I'm going to display the total number of email IDs that are present in my table. I'll close the dollar symbol. Then I'm going to declare a variable. The variable name is going to be total underscore emails. This is of type integer. I'll write begin, and inside begin I'll write my select statement. So I'll write select. I want to count the email IDs that are present, so I'll pass my column name, that is email, into total emails from my table name, that is employees. I'll give a semicolon, and then we'll write return total emails. As you know, user-defined functions often return a value, so hence we have mentioned the return statement as well. And now I'm going to end my function. Then the next syntax would be, let me just scroll down. Okay, so here I'll give my dollar symbol again, followed by total underscore emails. Next I'll write my language as PostgreSQL. So the way to mention is PL PG SQL. Let's give a semicolon and end it. So this is my user-defined function that I have written. So I created a function with the function name count underscore emails, and this would return integer as an alias, which is total underscore emails. We declared that variable as an integer. Then we started with our begin statement that has my select statement, where I am selecting the count of email IDs that are present in the employees table, and I am putting the value into total underscore email. So I have used the into keyword, and this returns the result as total underscore emails, and I have ended. Let's run this. Okay, there is some problem. There is an typo, so this should be integer. Okay, let me run it once again. There you go. So you've successfully created a user-defined function. Now the final step is to call that function. Now to call this function, I'm going to use my select statement and the function name, that is count underscore emails. I'll give a semicolon. Let's execute this. There you go. So here you can see there are 134 email IDs present in our employees table. Now one thing to mark is there are total 150 employees in the table, but out of them 134 employees have email IDs. The rest of them don't have, so they would ideally have null values. Alright, so that brings us to the end of this demo session on PostgreSQL tutorial. Let me go to the top. We have explored a lot. So we started with checking the version of PostgreSQL. Then we saw how to perform basic mathematical operation, that is to add, subtract, multiply. Then we saw how to create a table that was movies. We inserted a few records to our movies table. Then we used our select clause. We updated a few values. Then we deleted one row of information. Then we learned how to use the where clause. We learned how to use the between operator. we also learned how to use the in operator. Let me scroll down. We created a table called employees, and then we learned how the distinct keyword works. We also learned how to use isNull with where clause. We learned about the order by clause. We saw how to alter or rename a column. Then we explored a few more examples on where clause, where we learned about and OR operator. Then we learned how to use limit and offset, as well as the fetch operator or the fetch keyword in PostgreSQL. Moving further, we learned about the like operator in SQL, which was used to perform pattern recognition or pattern matching, you can say. Here we saw how to use basic inbuilt PostgreSQL functions like sum, average, minimum, count, maximum. Next, we saw how to update a value in a column using PostgreSQL update command. We learned how to use group by. Then we learned how to use having clause. Then we learned how to use case expressions in PostgreSQL. So we saw how case expression is similar to our if-else in any other programming language. We explored a few mathematical and string functions. And finally, we wrote our own user-defined function. So that brings us to the end of this tutorial on PostgreSQL. Now if you want to get this SQL file that we have used in the demo, you can give your email IDs in the comment section and our team will share this SQL file with you over email. SQL is a very important technology that is used in the IT industry. Professionals working as application developers, web developers, data analysts, data scientists, software testers, and cybersecurity experts need to know SQL. In this video, we will cover 30 important SQL questions that are most frequently asked in the interviews. Now these questions consist of a set of theoretical and practical questions. So we will use different commands, functions, joins, and other functionalities in Excel to solve the problems. So let's get started with the first question. So the first question is to state the difference between where and having clause in SQL. Now where and having are very widely used in SQL to solve specific problems. Now let's look at the difference one by one. So where clause is used to filter the records from the table based on the specified condition and can be used without the group by clause. On the other hand, having clause is used to filter the records from groups based on specified conditions. Now where clauses cannot have aggregate functions, so you cannot use sum, count, average, min, and maximum functions in the where clause. While in the having clause, you can operate on aggregate functions, and those aggregate functions are used to filter values from a group. Now where clause is implemented on rows or at row level. So for each row of data, you have the where condition applied. Now having clauses are implemented on columns. So for each column of data, you have the having condition applied. Now another important difference between where and having is that the where clause is executed before the execution of the group by clause and after the execution of the from clause. On the other hand, the having clause is executed after groups are created. Now we will learn more about where and having and understand the usage better when we tackle practical problems in this video. Now moving to our next question, which is how is drop different from truncate? So drop and truncate are two different commands. So drop command is used to drop the whole table, removing the table definition and its contents, while truncate deletes all the rows from the table. Now we can drop the whole table structure in one go, so the view of the table does not exist. By using the truncate command, the existence of all the rows in the table is lost, but the view in the table exists. Now integrity constraints will be removed in drop command, while the integrity constraints will not be removed when you use the truncate command. Now moving to our third question. Now this is a practical question. So we will be using a table which is present in my MySQL database. So the table name is called employees, and I want to find the lowest salary of the employees in each department. you can see here, this is how my employees table looks, and the output query would be something like this. So here, since I want to find the lowest salary of the employees, so I'm using a min function to find the lowest salary in the table, and then I'm grouping all the employees and the results by department. So let's do this on MySQL workbench. Okay, so here I am on my MySQL workbench. First, let me go ahead and create a new SQL script. So I'll click on this, and that will create a new script. Okay, so here we'll write our commands. Alright, so our question was to find the lowest salary for each department. Okay, so I've given my comment to make my commands and whatever I'm doing more readable. So first, before I proceed, I need to select my database. So I'm going to use my SQL_intro database. So I'll write use SQL_intro. Now this database has a lot of tables that we'll be using in this interview questions video. I'll run it. Okay, we are in our SQL intro database. Now there is a table called employees. Let me show you the table first. If I write select star from employees, okay, so here you can see this is the table I'm talking about. Now these are the rows that are present in the table. We have 20 rows, and here you can see the different columns. We have the employee ID, employee name, age, gender. We have the department, city, and salary. Now this is the same table that we have also used in our other videos that are already live on YouTube. Okay, so let's solve our question to find the lowest salary for each department. Now for that, I'll write select. I'll select my department column, which is DEPT, comma, and then to calculate the lowest salary or to find the lowest salary, I'm going to use the min function. So that will return the minimum salary present in the salary column. So I'll write min salary as, I'm giving an alias name as, let's say, lowest underscore salary from my table name, that is employees. Then I'll write group by department. Now I'm grouping it by department because we want to find the lowest salary of the employees in each department. Now let's run and see the result. There you go. I'll just move it to the top so that you can see the results clearly. Okay, so here we have total 7 departments, you can see at the bottom, and in these 7 departments you can see in sales 70,000, let's say, dollars was the lowest salary. In marketing we had $55,000 as the lowest salary. Similarly, if I scroll down, we have other departments like tech, IT, finance, and HR. So these are the lowest salary in each department. Alright, now moving to our next question. So our fourth question is, which query will help you fetch unique values from a column in a table? So this is a multiple choice question, which is another type of question that is often asked in the SQL interviews. Now we have multiple queries here, and you need to choose the right query that will solve our problem. So since I want to get the unique values from a column in a table, so the right option would be to use the distinct keyword in the query. So if I write select distinct followed by the column name, let's say you want to find the distinct cities or the distinct departments in the employees table, so the query would be select distinct city or let's say department from the table name, that is employees. Hence this is the right option if you want to find any unique values from a column. Now moving to the fifth question. Now the fifth question says, it is actually a similar question here, we want to write the SQL query to fetch unique departments from the employees table. So as we saw, this is our employees table, and if you want to find the unique departments from the employees table, you can just write select distinct, then followed by the column name, which is departments here, so DEPT from employees. Let's do this on our MySQL workbench. Okay, so let me just scroll down and I'll give a comment here. That is, we want to find the unique departments. So the query would be select, then I'll use the distinct keyword. If I hit tab, it will autocomplete. Then I have my column, that is department, from my table name, that is employees. If I run this, the query will give us the unique departments that are present in the table. So here we have total 7 unique departments in the table. You can see here we have sales, marketing, product, tech, IT, finance and HR. But if you see our original table, which is the employees table, so there are total 20 records, and if you see the department column, there are multiple departments to which each of these employees belong to. Okay, now moving ahead. Now the sixth question is to write an SQL query to fetch the unique values of departments and print their length. Now this question consists of two parts. First, we need to fetch the unique values of departments that we saw in our fifth question, and then we want to print the length of each of the departments. So for that, I'm using the distinct keyword to find the unique departments, and then I'm using the inbuilt length function that is present in MySQL to find the length of the department, and then I'm using an alias that is length underscore department from employees. So let's say this on our workbench. Okay, so let me give a comment. I'll say unique departments and length. Okay, so the query would be, I'll write select distinct department, and then let me just scroll down. I'll give a comma and use my inbuilt length function. See, I'm hitting tab to autocomplete, and inside the length function I'll give my column name, that is department. I'll give an alias as department underscore length from my table, that is employees. This is pretty simple. So first I am finding the unique departments, and then using the length function I'm finding the length of each department. Let's run and see. Okay, you can see the result here. So sales, the length is 5. Marketing, the length of marketing is 9. So basically you're counting the number of characters that are present in each of the departments. So in sales there are total 5 characters, in marketing there are total 9 characters, in product there are total 7 characters, in IT we have just 2 letters, I and T, so hence the length is 2. Similarly finance is 7 and HR is 2 because we have just 2 letters, H and R. Okay, so this is another variation of using distinct along with any inbuilt function. Alright. Now moving to the seventh question. The question is, what is the use of dateDiff function in SQL? Now dateDiff returns the number of days between two date or date time or timestamp values. So dateDiff is another crucial inbuilt function that is present in MySQL. So here is how you can use the dateDiff function. So it will return the number of days between two dates or date time or timestamp values. So here I have two date values, that is 10th of April 2021 and I have 30th of March 2021. So this query will give us the total number of days that lie between these two dates. And similarly, here is another example of using the dateDiff function. So I want to calculate the total number of days that are present between today's date, so I am using the now function, and between 20th of April 2021. So let's do this demo on the workbench. Alright, first I'll give a comment saying dateDiff function. Okay, now the way to use is I'll write select, and then you can see here once I type date, MySQL workbench is automatically suggesting some of the inbuilt functions. I'm going to use dateDiff, and within dateDiff I'm going to pass in two values. So I'm passing in two date values, let's say 2021 April, so I'll write 04, and let's say 10th of April. I'll give another comma, and I'll pass in my second date value, that is going to be 30th of March 2021. Alright, now another thing to note here is the date value should be present inside quotations. Now if you want, you can give an alias as well. I'll write as total days. Let's run it. There you go. It has given us the output as 10. So there are total 10 days between 31st of March to 10th of April. Now let's see another example. I'll write select dateDiff, and we'll pass in my now function. So the now function returns the current date, that is today's date, and I'll give another date value, let's say 2021 April 20th. Now we'll see the results. If you want, you can give an alias name so that the output is more readable here. I'll run it. Okay, so between today's date and my previous date, that was 20th of April, there are total 49 days. So today's date is actually 8th of June. So between 20th of April and 8th of June, there are total 49 days. Alright, now moving ahead. Now in the 8th question, we want to write an SQL query to display the departments that have more than 2 employees. So this is our employees table that we have been using, and here is how the command looks like. So here we are using both group by and having. Now I am grouping by department because I want to display the departments that have more than 2 employees. Now for the second filter, I am using the count function of the employee IDs and checking if the employees in each department are more than 2 or not. Let's do this. Let me move down a bit, and I'll give a comment departments with more than 2 employees. Okay, now let's write our query. So I want to select the department, and then I'm using the count function to count the employee IDs in each department, or the employees present in each department. From my table, that is employees, I'm going to group by department, and then I'll use having my count of employee ID. This should be greater than 2. So our query will return only those departments which have more than 2 employees. Let's run and see. There you go. So we have total 4 departments, that is sales, product, tech and IT, where we have more than 2 employees. You can see here sales has 4 employees, product has 3, tech has 4 and IT has 3. The rest other departments like finance, HR and others have less than 2 employees. Now if you want, you can give an alias as well. Let's say as total employees. Okay, let me run it again, and here you can see I have the column name as total employees. Okay, so moving ahead, the 9th question, we want to display the details of the employees for all the departments except marketing. Now here I have my employees table. Now if I were to display all the details of the employees apart from marketing department, I can give a condition like where department not equal to marketing. So this is the way how you write not equal to. So you use the less than and greater than symbol. Another way to do is use the exclamation mark and give equal to. So this means select all the employees where department is not equal to marketing. Now let's do this. I'll move down a bit and will give a comment as details of employees apart from marketing. So the query would be select star from employees. I'm using star because I want to display all the details. That means I want to display all the columns. Then I'm going to use my where condition where department not equal to marketing. I'll put marketing under quotes. Let's run it and see the results. There you go. So we have total 18 rows of information, and if you see the department column, we have all the departments apart from marketing. Now if you remember, our employees table had total 20 rows of information, out of which 2 are missing, which means there were 2 employees who were from marketing department and those departments were not displaying. Now another way to do is to use exclamation mark and equal to. So this also means select all the employees where department is not equal to marketing. Let's run this. You see here it gives us the same result and has returned us 18 rows of information, leaving apart the employees from the marketing department. Alright, now moving ahead. So our 10th question is to write an SQL query to print the details of the employees who have joined before April 2010 and after May 2005. So here is my employees table and this is my SQL query. So here we are using just a where condition to filter our results, and my condition is the employee should have joined after May 2005. So I have written after 31st of May 2005 and before April 2010, which is before 31st of March 2010. Let's do this. I'll give a comment here. We'll write employees joined before April 2010 and after May 2005. Now let's write our SQL query. So I'll write select star from employees where my date of join. If you see here, I have a column called date of join which has the details about the day on which the employee had joined the company. So I'm going to write where date of join is greater than 31st of May 2005. So I'll write 2005. This is one of the formats to use date values. So this is the year value, this is the month value, and this is the day value. And my date of join should be less than 31st of March 2010. So I'll write 2010 March 31st. I hope you were able to understand this. Date of join greater than 31st of May 2005 means after May 2005, and date of join less than 31st of March 2010, this means employees joined before 2010 April. Let's run it. Okay, so we have total 3 employees in our table. You can see the date of join, and all of them have joined after May 2005 and before April 2010. Department column, we have all the departments apart from marketing. Now if you remember, our employees table had total 20 rows of information, out of which 2 are missing, which means there were 2 employees who were from marketing department, and those departments were not displaying. Now another way to do is to use exclamation mark and equal to. So this also means select all the employees where department is not equal to marketing. Let's run this. You see here it gives us the same result and has returned us 18 rows of information, leaving apart the employees from the marketing department. Alright, now moving ahead. So our 10th question is to write an SQL query to print the details of the employees who have joined before April 2010 and after May 2005. So here is my employees table and this is my SQL query. So here we are using just a where condition to filter our results, and my condition is the employee should have joined after May 2005. So I have written after 31st of May 2005 and before April 2010, which is before 31st of March 2010. Let's do this. I'll give a comment here. We'll write employees joined before April 2010 and after May 2005. Now let's write our SQL query. So I'll write select star from employees where my date of join, if you see here I have a column called date of join which has the details about the day on which the employee had joined the company. So I'm going to write where date of join is greater than 31st of May 2005. So I'll write 2005. This is one of the formats to use date values. So this is the year value, this is the month value, and this is the day value. And my date of join should be less than 31st of March 2010. So I'll write 2010 March 31st. I hope you were able to understand this. Date of join greater than 31st of May 2005 means after May 2005, and date of join less than 31st of March 2010, this means employees joined before 2010 April. Let's run it. Okay, so we have total 3 employees in our table. You can see the date of join, and all of them have joined after May 2005 and before April 2010. Okay. Now moving ahead to the 11th question. So here we want to find the employee with the third highest salary from the table. So I have my employees table here, and my command would look something like this. So here we are going to explore how to write subqueries in SQL. So I'm using a subquery here where I'm trying to find the employees who have the top 3 salaries, or the top 3 employees who have the highest salaries, and from that I'm going to filter out my third highest salary employee. So let's do it on our workbench. Okay, so I'll come down and let me give a comment as third highest salary. Okay, so let me first write down my SQL query and then I'll explain. So I'll write select star from. After that I'll start a bracket and write my inner query. So I'll write select star from employees order by salary descending. Then I'll use my limit keyword and I'll write limit 3 as I'll give an alias name, let's say T, and then I'm again going to use my order by salary limit 1. Okay, now let me explain you the flow. So first let me run the inner query. I'll select my inner query and I'll run it. So the inner query returns my top 3 employees who have the highest salary, and this is ordered in descending order since I used salary descending. Now let me just use this. Okay, now you can see it clearly. So these are my top 3 employees who have the highest salary. So Joseph has the maximum salary, followed by Angela, and then we have Jack. Now from this I want to return only the record for Jack, because Jack is the employee who earns the third highest salary. So for that I'm going to use the result returned by my subquery or the inner query, and on top of this I'm going to order the salary and say limit equal to 1. So I'm again ordering this salary in ascending order. So what will happen? Jack will appear at the top, Angela will be at the second place, and Joseph will come to the third place. And from there I'm using limit 1 so that I can only get the record for Jack. Now if I run the entire query, you see the result. I have my employee name as Jack who earns the third highest salary. Okay. Now moving ahead to the 12th question. The question is to print all the alternate records in a table. So here is my employees table, and from this table I'm going to print all the alternate records. For example, I'm going to print my employee ID 101, then I'm going to skip 102 and print 103, followed by 105, 107, 109. So all the employee IDs that have an odd value. And you can look at this example in another way of displaying the employees which have an employee ID of even numbers. So 102, 104, 106 and so on. Now the way to do is, either you can use a simple select clause and say employee ID percentage or modulus 2 equal to 0, which means I want to filter only those employees which have an even employee ID. Else what you can do is you can use a CTE, as you can see here. So CTE, or the common table expression, is a temporary named result set that you can reference within a select, insert, update or delete statement. Now it is used to simplify complex joins in subqueries and to provide a means to query hierarchical data. Now let's write this query on our workbench and see how it works. But before that, let me explain you. I am using a few new functions such as row number. This will create a row number for each of the rows or the records present in my table. And then From this CTE, I am going to use my filter clause or the where clause, where rn, which is row number, %2 equal to 1. So this will return only the odd records from the table. Let's see how to do it. Okay, so I'll give a comment, print alternate records. Okay, now I'll start with my simple query, which is select star from employees, where let's say I want to find only the even employee IDs or the employees who have an even employee ID. So I can use employee ID %2 equal to 0. So it has to be a perfect division and the result should be 0. Only then I can get only the even employees. If I run this, okay, there was an error here. It should be employees. I'll run it again. You can see here I have printed the alternate records in a table. So we have skipped 101 because it is not divisible by 2. I've started with 102, followed by 104, 106, 108, and then finally we have 120 or 120. Now if you want to print only the odd records in the table, you can use employee ID %2 equal to 1. So you can see here I have 101, 103, 105, 107 up to 119. Now the best way to do this is to use a common table expression or CTE. So I'll start with my command, that is with CTE, as I'll start with my bracket, I'll write select star comma, then I'm going to use my row number function. So I'll write row number, then I'll write over, then I'll use order by employee ID. So this row number for each of the rows is going to be created over my employee ID column, and that is sorted in ascending order. I'll give an alias as rn, which stands for row number, from my table, that is employees. I'll scroll down and then I'm going to close my bracket. I'll write select, let me remove the space here. Okay, I'll write select star from CTE, where my row number %2 equal to 1. Now let's see this from the top. So I have my common table expression where I am going to create a row number column named as rn, and this row number column is based on my employee ID column, which is sorted in ascending order, and from that I'm going to filter only those row number values that are not divisible by 2, or I'm going to print only the odd records from the table. So let's run it and see the results. There you go. So here if you mark, I have my row number column created and I'm filtering only the odd records in the table. So it starts with 1, 3, 5, 7 and goes up to 19. And similarly here you can see the employee IDs, the name, the age, gender and other information. Now if you were to print the even records in the table, the alternate even records, you can use rn %2 equal to 0. Let's see the difference. I'll run this. There you go. So I have my even row number starting from 2, which goes up to 20. Okay, so this is how you can print alternate records in a table. Now moving to the next question. Now in the 13th question, we want to write an SQL query to fetch all the duplicate rows in a table. Now this is another crucial interview question that is often asked in most of the interviews. Now I have a table which is named as duplicate table, and here you can see I have some employee ID, name and age, and a few records are duplicated. For example, 101 Sam 40, the first record is duplicated, and you can see here it has the same values. Now if you mark 103 Mary and 28 is not duplicated because here the age is different, so this is a different person than compared to the third name that we have. So this is how you can find the duplicate rows in a table. So I'm going to select my employee ID, name and age, and then count all the employee IDs, the names and age, and compare them with whether they are greater than 1 or not. So if they are greater than 1, then I'll say that particular record is duplicated or is present more than one time in the table. Let's do this implementation on our workbench. Okay, so I'll come down and let me give my comment as duplicate records. Okay, so let me first show you the records that are present in my table. So I'll write select star from DUP underscore employees. I'll run it. Okay, you can see here I have my table that we saw in the slides. So employee ID 101 with name Sam and age 40 is duplicated. So we want to find this duplicate record. The way to do is I'll write select E underscore ID, which is employee ID, comma name, comma age, comma I'm going to count all of them. So I'll write count star as duplicate count. This is my alias name from my table that is DUP underscore employees. I'll say group by employee ID, name and age, and then I'm going to use my having clause saying having count of employee ID is greater than 1 and count of name should also be greater than 1 and my count of age should also be greater than 1. Let's run it and see the results. Okay, there is some error here. The name of the table should be employees. Okay, let's run again. We have our correct result, that is employee ID 101 with name Sam and age 40 is duplicated, so the value is 2. Great. Now moving ahead. Now the 14th question is a bit tricky, wherein we want to display the employees with exactly 2 A's in their name. So you see here I have my employee names and there are certain employees who have just 2 A's in their names. So I want to find those employees only. Now the way to do is, it is a bit tricky to understand. I'm going to break it down and make you understand on my MySQL workbench. So here you can just have a glance. I write select star from employees where I am finding the length of my employee name and then subtracting my length wherein I have replaced my employee name that has A with a blank, and if this subtraction is equal to 2, then that particular employee has 2 A's in their names. So let me show this first. Let me first give my comment as employees with 2 A's. Okay. So first I'm going to write a select statement. Okay, before that I'll show you the records present in my table. Okay, if you see here, Shane is one of the employees that has just one A in its name. Then we have Mary 1A, Dwayne has 1A, but if you see Sarah has 2A in the name, so we want to extract Sarah. Then Jack has 1A. Again, if you see Angela has 2A. It doesn't matter if it is uppercase A or lowercase a, we just need to find if the employees have 2 A's in their name. And similarly, if I scroll down, let me check if we have any other employee with 2 A's in their name. Marcus has 1, David has 1, Sophia has 1. We also have Amelia that has 2 A's in its name or in her name. And we also have Maya. Okay, now let me go ahead and write a SQL query, and then I'll explain you what I'm trying to do. I'll write select. I'm using the length function, and in the length function I'm going to replace, then I'll use another function called upper on top of employee name. I'll write A and then replace it with a blank. So I'm using quotations to represent blank from employees. Okay, let's run this and see the results. You see here it has given us the length of the employee strings after replacing all the A's with a blank. So here I'm essentially converting my employee names to uppercase, and I'm changing wherever there is an A, I'm replacing that A with a blank, and then I'm finding the length. So this trick I'm going to use in my final query. So I'll write select star from employees, where what I'm going to do is I'll bring this to the next line. I'll write length of employee name minus, then I'm going to use my above condition. I'll copy this, I'll paste it here, and this value should be 2. So what I'm doing is I am first finding out the length of my employee name. From that I'm subtracting the length after replacing the A's present in the employee name with a blank, and this value should be equal to 2. The reason being we are only trying to find the employees who have 2 A's in their name. Let's run and see the results. Okay, if you see here we have Sarah, Angela, Amelia and Maya who have 2 A's in their name. So we have Sarah that has 2A, Angela has 2A, Amelia has 2 A's, and then Maya also has 2A. Okay, now moving ahead. Now the 15th question is, given a string, how will you extract 4 characters starting from the second position? So I have my string here which says Michael Ballack. Now Michael Ballack, you must be aware, is a popular footballer. He is from Germany and also was the captain of Germany. So from the string Michael Ballack, I am going to extract 4 characters starting from the second position. You can use 2 inbuilt MySQL functions to do this. The first is called substr, wherein we pass in the string, then we give the position from where we want to extract the characters. So here I am going to extract from the second position, so hence 2, and then the number of characters that you want to extract, which is 4. The other way is to use the substring function, which is again similar to the substr function. In the substring function also I am first passing in my input string and then giving my starting position, which is 2, and then I want to extract 4 characters from it. Let's do it. I'll give a comment, extract strings, So here I'm going to write select. First I'm going to use substr, which is my inbuilt function. I'm going to pass in my input string which says Michael Ballack, and then I'll give my starting position which is 2 and then the number of characters, that is 4. Let's run it and see the results. You can see here it has given us ICHA. So if you see, M is at the first position. From the second position onwards I needed 4 characters, so M, C, H and A. These are the 4 characters starting from the second position. Similarly, let me just copy this, and instead of substr I'm going to use the substring function. I'll write just ing, that becomes substring. Let's select and run it, and this also returns the same result. Suppose you wanted to extract from the 4th position, you wanted to extract, let's say, 3 characters. Let's see the results. It gives us H, A and E. If you see here, M is the first position, I is at the second position, C is at the third position, H starts from the 4th position. So H, A and E are the next 3 characters starting from the 4th position. So hence this is the result. Alright, now moving ahead. Now my 16th question is on how does self-join work. So self-join joins a table to itself. So the table must contain a column X that acts as the primary key and a different column, let's say Y, that stores values that can be matched up with the values in column X. Now this might not be really easy to understand. You'll get to know once we do this demo. So I have a table which is called employee manager. So this is my table. Now let me tell you how to interpret this table. We have 5 different employees starting from employee ID 1 to employee ID 5. Gary, Gibbs, Smith, Latham and Jimmy are the different employees we have. You have their salaries, and now you have the employees reporting to which manager. Now if you see here, Gary's manager ID is 3. So if you see our table, at 3 we have Smith. So Gary is reporting to 3, or in other words, Smith has a employee under him who is Gary. Similarly, Gibbs is reporting to manager ID 1 or employee ID 1, which is Gary. So Gibbs manager is Gary. Similarly, if you see for Smith, Smith is reporting to the person with manager ID 4 or employee ID 4. We have Latham. So Latham has one employee under him who is Smith. Now Latham in our table has no managers. Then we have Jimmy who's reporting to the employee ID 3 who is Smith. Okay. Now I want to use this table and return the name of the manager for each employee. To do that, I am going to use my self join. So here I am using a self join to join both the tables. Here both the tables mean I am using the same table twice. So I have written select e.employee ID, e.employee name, then we have e.manager ID. Then I am using another alias for managers. So m.employee name as manager underscore name from employee underscore manager as e. This join means self join employee underscore manager as m on e.manager ID equal to e.employee ID. So this is my common column, that is employee ID and manager ID. Let's do it. Alright, I'll give a comment here saying self join, and I'll start with my self join. I'll write select. Let me first display my table. I'll write select star from, and my table name is emp underscore manager. I'll run it. You can see the table here. This is the same table that we saw in the slides. Now I'll write my join query. I'll write select e dot employee ID, comma e dot employee name, comma e dot manager ID, comma, then I'm using another alias as M for finding the manager name. So M dot employee name as manager name. There shouldn't be any space in the alias name. Then I'll write from emp underscore manager as E join emp underscore manager as M on E dot manager underscore ID equal to M dot emp underscore ID. Let me run this and we'll see the results. There you go. So Gary reports to the manager ID 3. So from the table 3 is for Smith. So Gary's manager is Smith, Gibbs' manager is Gary, Smith's manager is Latham, and Jimmy's manager is Smith. Okay, so this is how you can use self join. Now moving ahead with our next question. So the 17th question is on which of the following is called a virtual table in SQL. So again we have a multiple choice question. So the answer is view. You can see here. So view is a virtual table that has rows and columns as they are in a real table in the database. Now we can create a view by selecting fields from one or more tables present in the database. Next, moving to the 18th question. So here we want to write an SQL query to fetch the list of employees with the same salary. Again, I am going to use a self join here, wherein I'll join the same employees table, and this is how my query would look like. So I am selecting distinct employee ID, so e.employee ID, e.employee name, e.salary from employees. Then I'm joining employees as E on employees E1, where e.salary equal to e1.salary, because I want to fetch the list of employees with the same salary, and I'm ensuring that the employee IDs from both the tables are different. Let's do it. I'll give a comment here and write employees with same salary, and I'll start with my query. I'll write select distinct e dot employee ID, comma, I'll write e dot employee name, comma, e dot salary from employees as E, then employees as E1, where e dot salary equal to e1 dot salary and e dot employee ID is not equal to e1 dot employee ID. I'll give a semicolon and let's print the results. You see here we have Amelia, Bela, Shane and Sarah who have the same salary. So Amelia and Shane have the same salary of $55,000. Bela and Sarah have the same salary of $72,000. Okay. Now moving to the 19th question. So the question is to write an SQL query to print one row twice in results from a table. So I have a table here called employees and I want to print one row twice in the results. So to solve such kind of problems, you need to use the union all operator in SQL. So union all combines the result sets of two or more select statements. It does not remove duplicate rows. Between the various select statements, all the rows are returned. So let's say I want to print the employee name and department for those employees who are from the HR department. Now to do this, we can use the union all operator. You can see it here. So I'm selecting my employee name, the department from my table employees as E. Then I'm giving my where clause where E.department equal to HR. and then I'm using the union all operator. Then I'm again selecting my employee name, department from employees with another alias as E1, where E1.department equal to HR. So let's do this. Okay, so I'll give my comment as print row twice. Okay, now I'll start with my query. I'll write select my employee name, comma, the department from my table that is employees as E. Then I'll use where E dot department equal to HR. Then I'm going to use the union all operator. So the union all will combine the result set of two or more select statements. Then I'm going to write select emp underscore name, comma, my department from employees as E1, where E1 dot department equal to HR. I'll give a semicolon. Now let's run it. There you go. You can see here Marcus and Sophia are from the HR department, and we have printed them twice in our results. Coming to the next question. The question is, using the num table, write a query to add 10 when number is 0, 20 when number is 1, else print the number itself. So you can see here I have my table called num, and it has just one column, which is num ID or number ID. We have some numbers here, and from these numbers I want to add 10 if the number is 0, 20 if the number is 1, else I would print the number itself. So to answer this question, we'll use the case statement in SQL. So the case statement is SQL's way of handling if-then logic. The case statement is followed by at least one pair of when and then statements. So here you can see I have my case statement. I'm writing when case, my column name n underscore id equal to 0, then add plus 10. If it is 1, then add plus 20, else we'll just return the number ID. Now let's do this. Okay, I'll give a comment saying using case statements. Okay, first of all, let me display the values present in my NUM table. You can see here this is my table, and there are total 12 rows of numbers. Now let's start with our query. I'll write select n underscore id, comma, then I'm going to write my case statement. So I'll use the keyword as case when n underscore id equal to 0. I'll use then n underscore id plus 10. I'll write when n underscore id equal to 1, then n underscore id plus 20, else I'll just print an id. Now I'll end my case statement. I'll write end as an alias name, let's say num underscore add, from my table that is num. Let's run and see the results. Okay, you can see here my first number was 0. So since it was 0, we have added num id or n id plus 10. So the result is 10. Now wherever the num id is 1, for example here we have added 20, so the result or the output becomes 21. Similarly here the value was 0, so we have added 10, the output is 10. And you see here again, here we had another 1, so we added 1 to 20, so the result becomes 21. And for the rest of the numbers, for example 3, we had 2, the values are the same. Okay, now moving ahead. So we have a table called num1, and using this table we want to write a query to find the sum of all positive values and the negative values. So let's see the table first. So this is my table, which is num1. You can see here we have a list of integers, and there are positive as well as negative integers. So for positive values and the negative values, we want to find the sum separately. So again, for this we are using the case statement. You can see here I have used two case statements. I'm writing select, and then I'm using the case to find if the number is greater than 0, which means it's a positive number. So I'm finding out the sum, and then I'm checking case when the integer is less than 0, so it's a negative number, and I'm finding the sum for the negative numbers as well. Let's do this. Okay, so I'll give my comment as add positive and negative numbers. Okay, so let's start with our select query. I'll write select. I'll use the sum function, and inside the sum function I'll use my case statement. So I'll write case when num underscore integer. Okay, before that let me just print the values present in my table. So I'll write select star from my table name, that is num1. Okay, so you can see here these are the values or the list of integers that we have. There are some positive as well as negative integers. Okay, let's continue with our query. So here I'm going to write case when num underscore integer or int, which is my column name, if it is greater than 0, then I'll return num underscore int. Else I'll say 0 and end my case statement. I'll give an alias as sum of, let's say, positive numbers. I'll give a comma. Then I'll use another sum function, and inside the sum function we'll use the case statement to find the sum of negative numbers or integers. So I'll write num underscore int. If it is less than 0, then num underscore int, else 0, and I'll end. Okay, and I'll give another alias name as, let's say, sum underscore neg, which stands for negative. POS is for positive integers, and then I'll write from my table, that is num1. Let's run it. Okay, there you go. We have our results. So we have two columns, sum of positive integers and sum of negative integers. You can see the results 19 and minus 14 respectively. Okay, now moving ahead. Now in question number 22, we want to list the difference between primary key and foreign key. So as you can see here, primary key is something that can uniquely identify a record in a table. So if you consider a school database, a primary key would ideally be the roll number or the registration number of the student, because that is unique to all the students in a school. Now foreign key is the field in the table that is primary key to another table. So suppose you have another table called courses to which the students have enrolled to. Now if you have a roll number or a registration number column in the course table, that becomes the foreign key. Now the other difference is primary key don't accept or cannot accept null values, while foreign key can accept null values. Now you can have only one primary key in a table, but you can have more than one foreign key in a table. Now coming to the 23rd question, what is the difference between primary key and union? So you can have only one primary key in a table as we discussed in the previous question, but you can have more than one unique key in a table. A primary key column cannot have null values, but union can accept null values. Now if you assign a column as a primary key, you create a clustered index, and similarly if you assign a column with union, you create non-clustered index. Okay. Now coming to the 24th question, what is a check constraint in SQL? So check constraints are used while creating tables. Check constraint helps to limit or restrict the values that can be inserted into a column. For example, we have a table here, let's say dummy 1, and you want to ensure that every time you insert the age of people or persons in the table, you want to make sure that age should be always greater than 0. Reason being, a person cannot have, or an animal cannot have, or a tree cannot have a negative age. Similarly, you can set a constant for the salary column in a table to ensure that it is always greater than 0, because you cannot earn a negative salary, or it cannot be less than 0. Now we are going to create a dummy table on my MySQL workbench and see how check constraints can be applied. Okay, so let's give our comment as check constraints. Alright, so I'm going to create a table called dummy, let's say underscore SQL. Now this table will have a few columns. First we have, let's say, EID, which stands for employee ID. The data type is integer, and I'm going to assign employee ID as my primary key. So I'll write primary key here. Okay, I'll give a comma. Next we'll have a city column. City column is of type var char or varying character. I'll give the size as 30, and here I'm going to apply my check constraint to this city column. I'm going to check the city should take only values as Mumbai. Let's say I'll have my final column, that is age. Age is of type integer, and here I'm going to check my age should always be greater than 0. So I'll write check age greater than 0. Okay, so our dummy SQL table has one primary key constraint, and we have applied two check constraints on city and age column. Let's run this. Okay, so we have created our table successfully. You can see it here. Now let's insert a few records and we can see the difference. I'll write insert into dummy underscore SQL. I'll write values. I'll have my employee ID as 101. I am giving my city as Mumbai, which is what we want. And let's say I'll give my age as 10. Now this should perfectly work because my city is Mumbai and my age is greater than 0. So I should be able to insert this record successfully. You can see here I have inserted this record to the table. I'll write select star from dummy SQL so that you can check. Let's run it. There is some mistake. I should write from. Okay, let's run it. You can see it here. We have one record or one row returned. Now let's say we'll insert another record, and this time I'm going to give my employee ID as 102 because it has to be unique. And this time, instead of Mumbai, I'm going to give my city as, let's say, Delhi. So I'm not following my check constraint where I am supposed to give only Mumbai. I'm purposely giving Delhi here to see the difference. If I run this, let's say we'll have age is 40, which is greater than 0. Let's run it. You see here we get an error saying check constraint dummy underscore SQL underscore check is violated. Similarly, let's say I'll change this to Mumbai again, and instead of 40, let's say I'll give us minus 30. So your age can never be in negative numbers. If I run this, I get the same error. My check constraint has been violated because age should be greater than 0. Okay, so this is how you can use check constraints in SQL. Now coming to the 25th question. So given two tables A and B, we want to write a query to fetch values in table B that are not present in table A. Now to answer this question, you can use the left join. So what left join does is, it returns all the rows from the left table and only matching rows from the right table. And I've used my condition as a.id, which is in the right table, should be null. Let's write this query on the workbench. Okay, so I'll give my comment using left join. First of all, let me display my tables. I'll write select star from A. If I run this, I have the IDs. There are total 5 IDs in table A. Similarly, I'll copy this and we'll see the values that are present in table B. So again, I have 5 values. There are a few non-matching values as well. So I want to return those non-matching values that are not present in table A. So for that, I'll write select ID from table B. I'll use left join A using my ID column. This is another way to give the condition, or you can use the on operator. Then I'll give where a.id is null. Let's run and see the results. There you go. So 150, 200 and 75 are not present in table A but are present in table B. Okay. Now moving ahead. So now we'll look at the last set of 5 questions. So these questions are based on the popular Northwind sample database provided by Microsoft. Now there are several tables in this database. So we have an order table, customers, employee, products, a region table and others. We'll use our Microsoft SQL Server to solve the 5 questions. So my next question, which is based on Microsoft SQL Server, the question is, using the Northwind database, find the customers who don't have any orders. Okay, so I am on my Microsoft SQL Server Management Studio. So this is how the interface looks like, and here you can see I have a list of databases. Now to solve the last 5 questions, I'm going to use the Northwind database. If I expand this, I'll click on the plus sign. You can see there are a lot of tables that are already present in the database. You can see here we have customers, employees, employee territories, order details, orders, products, region, shippers, suppliers, territories and more. Okay, let me just collapse this. Alright, so to write my queries, I'm going to create a new query file, and here you see I am currently on my master database. I am going to change this to Northwind database so that we can utilize all the tables that are present. So my 26th question was to find the customers who don't have any orders. So for that I'm going to use two tables, customers and orders. So let me first give a comment saying customers with no orders, and now let's go ahead and display the columns that we have and see the records present in the tables customers and orders. So first I'm checking all the columns and the rows present in the customers table. I'll execute using this button, or you can hit F5 as well. Okay, you can see here there are total 91 customers. These are all unique customers. You have total 91 unique customer IDs. You see here the company name of the customer, you have the contact name, the contact title, address, city to which the customers belong to, then the region, postal code, country, phone, fax number. Okay, now let me just copy this query, and now we'll check for the orders table. I'll write select star from orders, and let's execute it or run it. Okay, so there are total 830 rows of information. So there were total 830 orders or order IDs. We have the customer ID. Now this customer ID is actually the foreign key for the orders table, but for the customers table, customer ID is the primary key, and in the orders table, order ID is the primary key. We also have the employee ID. Again, this employee ID is the foreign key for this orders table. We have the order date, we have the required date, ship date, ship via, which means by which medium the order was shipped. We have the freight charges, ship name and ship address as well. Then you have the city from which the item was shipped, the region, postal code and the country. Okay, now let me use the distinct keyword. I'll write select distinct. I want to find the distinct customer IDs from my customers table. Let's run and see how many unique customer IDs we have. So there are total 91 customer IDs or customers. Now let's check for the orders table. Let's run it and see the difference now. If you see here, there are total 89 customer IDs in the orders table, which means there are 2 customers missing from the orders table, and that implies those 2 customers don't have any orders. So to get the result, I will use 2 different queries to derive at the same output. So I'm going to select my customer ID from my table, that is customers. I'm going to use where my customer ID, and then I'm going to use the not in operator. I'm going to use a subquery select customer ID from my orders table. Close the bracket and I'll give a semicolon. Now what this query essentially does is, it is first going to find all the customer IDs that are present in my orders table, and in the outer query we are only going to return the customers that are present in both the tables, and we are going to exclude those customers which are not present in the orders table. So let's run and see the results. We should get 2 customer IDs. There you go. So these are the 2 customer IDs which are present in the customers table and are not present in the orders table, meaning that they don't have any orders in their name. Now there is another way to do it, that is to use the not exists operator, wherein you can write another subquery to get the same result. We'll leave that to you. You can try this out using the not exists operator as well. Coming to the 27th question. Using the orders table in the Northwind database, we want to find all the month-end orders. So such problems you will face while dealing with sales data. So very often sales executives would try hard to meet their month-end targets. We want to display all the orders made on the last day of the month. So let's solve this question on our Microsoft SQL server. Okay, so let me first give my comment for the 27th question. So the question is to find all the month-end orders. So I'll just write month-end orders. Okay. Now to get the month-end orders, we are going to use a built-in EO month function which stands for end of month. So let's start with the query. I'll write select. We are going to select the employee ID, comma. I also want the order ID and we want the order date from my table, that is orders. I'll then give my where clause. I'll write where my order date equal to, and I'll use my inbuilt function, that is end of month. I have hit tab to autocomplete, and inside this function I'll pass in my order date column. Then I'm going to use the order by clause. I'm going to order it by employee ID and the order ID. I'll just move down and hit tab. Okay, let's run the query. There you go. We have got 26 rows of information. You see on the left side we have the employee IDs, the order IDs, and then we have the order date column. Now if you mark the values present in the order date column, these are all the end of month date values. You see this is 28th of Feb, then we have 31st of July, we have 30th of June, so on and so forth. So these are the list of all the orders that were placed on the last day of the month. Now coming to the 28th question, we want to find the top 5 countries with the highest freight charges in the year 1997. So freight charge is the amount paid to a carrier company for the transportation of goods from origin to another location. The freight charge is calculated based on the mode of transportation and the distance between the pickup place or the pickup location and the destination. So let's try this out on the Microsoft Server Management Studio. Okay, so let me go ahead and give my comment. So since we want to find the top 5 countries with the highest freight charges, I'll just give my comment as highest freight charges. Okay, now to solve this question, I'll just change this to GHT. Okay, we are going to use our orders table. So the way to do is I'll write select. I'm going to use the top 5. So top is another keyword or an operator. So I'm going to find out the ship country and then I'll calculate the average freight prices. So I'm going to use the average inbuilt function on top of my column, that is freight. I'll give an alias as, let's say, average freight. There should be no space. I'll give a underscore. I'll write from my table that is orders. I'll use my where clause where, and then I'm going to find the year from my order date column, and this year should be 1997. I'm going to group it by my ship country, and I'll use order by my alias name, that was average freight, and in descending order I'm going to sort it. Let's see the top 5 shipping countries who have the highest freight charges. These are the results. You have Austria, Switzerland, Sweden, Canada and Ireland, and here you can see the average freight prices sorted in descending order. Okay, now moving ahead to the 29th question. So here we want to display the total number of products in each category. So we have two different tables, products and categories. So both these tables we are going to use to find a solution to this problem, that is to display the total number of products in each category. So first let me give my comment to display the total number of products in each category. I'll just write print total products. Okay, so to solve this problem we are going to use our two tables. So let me first display the rows and columns from both the tables. The first table is products. Okay, it is products. Let's run this and see the columns that we have in this table. Okay, so you have the product ID, which is the primary key. You have the product name. So there are total 77 different products. Okay, and then you have the supplier ID, you have the category ID. So these two columns are the foreign key columns. You have the quantity per unit, unit price, units in stock, units in order, and if you want to reorder some product to fill in the stocks, so you have information for that as well, and if the product has been discontinued or not. I'll copy this and let's see what rows and columns we have in my categories table. Okay, let me execute this. Okay, so we have total 8 categories of products. You can see beverages, we have dairy products, meat or poultry, you have produce, seafood. These are the description. Okay, now to find the total number of products in each category, I'll write my query as select. I'll write category name, comma, count star. I'll give this an alias name as total products, give an underscore and write products from my first table, that is products, give an alias as P. I'm going to use an inner join with my categories table, and I'll give my alias as C on my common key column, that is P dot category ID is equal to C dot category ID. Then I'm going to group my results based on the category names. So I'll write category name and we'll use the order by clause. I'll write order by count star as descending. So let's see the total number of products that we have in each category. So this shouldn't be as descending, should be just count star descending. Okay, I'll select and run it. There you go. So here on the left hand side you have the different category names, and on the right you have the total number of products that belong to each of the categories. Alright, now moving on to the final question. So the last question is to use the Northwind database, and using this database we want to find the list of late orders for all the employees. So this is a real world problem that often occurs. So the shipment of your orders might get delayed due to logistic issues, or if the products are not available on time. There can be various other reasons as well. So here we want to find those orders for the employees where the required date is less than the shipment date. So we are going to use two different tables, that is orders and employees. Okay, now let me give my comment for the final query that we are going to write in this interview questions tutorial. So using the orders table, I want to find the list of orders for all the employees. So I'll just give list of late orders, not just orders, for employees. I write EMPS, which stands for employees. So here I'm going to use two tables, orders and employees. Orders table we have already seen. Let's see the rows and columns that are present in the employees table. I'll write select star from employees and let me run it. Okay, so there are total 9 employees we have. So we have the employee ID, this is the primary key column which goes from 1 to 9. We have the last name of the employee, the first name of the employee, we have the title, then we have the title of courtesy, whether doctor, Mr., Mrs. We have the birthday of the employee, the hire date or the date of join. You have the address, city, region, postal code and other information. Alright, so let's see how you can join the orders table and the employees table to get the list of late orders. And we must remember that late orders are those where the required date is less than equal to the shipped date. So I'll start with select e dot, I'll write employee ID, comma, I want the first name, comma, I'm going to count star as late orders from my table orders as O. Then I'll use my inner join. I'll write employees as E. It doesn't matter actually if you use small e or capital E. Then I'm going to use my on condition on e dot on e dot employee ID equal to O dot employee ID. So this is my common key column that is present in both the tables. Then I'll use my where clause where. Now you should be careful and you should give the right clause. So my required date should be less than or equal to my shipped date. So this is my condition, and then I'm going to group by e dot employee ID, comma, e dot first name, and then I'll use my order by clause, order by my alias name that was late orders, and I'll arrange it in descending order. So let's run this and see our result. Okay, so you have the employee IDs on the left, then you have the first name of the employee IDs, and then you have the late orders for each of these employees. So if you see here, employee ID 4 has the highest number of late orders, followed by employee ID 3 and 8 as well as 9 who have 5 late orders. Then we have the employee ID 2 which has 4 late orders, even employee ID 7 has 4 late orders. Employee ID 5, that is Steven, has only 1 late orders. So we are done with our demo section and we have covered all our 30 questions, out of which 25 questions were based and used on MySQL server. And to address the last 5 questions, we used our Northwind database that had a lot of tables. You can see it here, and using those tables we solved some interesting questions.
In this video, we'll understand what exactly MongoDB is and what are its key features. Now I'm sure you must have heard about databases, but MongoDB is a popularly used not only SQL database. Now, without further delay, let's begin and understand what exactly MongoDB is. So here's what's in store for you. First, we'll understand what MongoDB is. Then we'll understand why exactly MongoDB is used. Then we'll understand the characteristics of MongoDB. After that, we'll understand the working of MongoDB and how it functions. We'll also look at some of the commonly used applications of MongoDB. And finally, we'll look at the top companies that readily deploy MongoDB. So what exactly is MongoDB? It is a document-oriented NoSQL database. It was initially released in August 27, 2009. MongoDB replaces the concept of rows of conventional relational data models with something called documents. It offers developers the flexibility to work with evolving data models. Since it's document-based, MongoDB allows embedded documents, arrays, and represents complex hierarchical relationships using a single record. It is also schema-free, which means that the keys defined in the document are not fixed. As a result, massive data migrations can be ruled out. But you must be wondering, when there's something like SQL, why is NoSQL or MongoDB used? There are a few reasons why MongoDB is widely used. First up is flexibility. MongoDB's notion of documents that can contain sub-documents nested in complex hierarchies is really expressive and flexible. Flexible query model. A user can selectively index some part of a document or a query based on attribute values, regular expressions, or ranges. Next up is native aggregation. Native aggregation allows its users to extract and transform data from MongoDB and either load them in a new format or export it from MongoDB to other data sources. It makes it extremely compatible. Lastly, as mentioned earlier, the schema-free model. Now, applications get the power and responsibility to interpret different properties in different ways. Now that you know what MongoDB is and why exactly it's used, let's have a look at the characteristics of MongoDB. Firstly, it's a general-purpose database. Now, MongoDB can serve heterogeneous loads and multiple purposes within an application. Again, it has a flexible schema design. Document-oriented approaches with non-defined attributes that can be modified on the fly is a key contrast between MongoDB and any other relational database. Next up is scalability and load balancing. It's built to scale both vertically but most importantly horizontally. Using sharding, an architect can share load between different instances and achieve both read and write scalability. When it comes to load balancing, this happens automatically and transparently to the user by the shard balancer. Again, we have aggregation framework. Now, MongoDB offers an extract, transform, and load framework that eliminates the need for complex data pipelines. Native replication. Now, data will get replicated across a replica set without complicated setup. Security features. Both authentication and authorization are taken into account in MongoDB. Next up is JSON. Now, JSON is widely used across the web for front-end and API communication, and as such, it's easier when the database is also compatible with the same protocol. Lastly, we have MapReduce. Now again, MapReduce is an excellent tool to build data pipelines, and MongoDB uses MapReduce readily. Now let's quickly have a look at the working of MongoDB. Data is stored in documents with the help of key-value pairs. Now the data is stored in the BSON format. At the back end, MongoDB converts JSON data into a binary format known as BSON. MongoDB also makes provision for nested data. Now all of these documents are stored in a collection. These collections hold multiple documents, and since MongoDB is schema-less, the documents in one collection need not be similar. Now again, these collections are stored in the entire MongoDB database. As mentioned earlier, MongoDB makes provision for nested data. This makes fetching of data extremely efficient when compared to other databases. Now you must be wondering where exactly MongoDB can be applied or used. So let me help you with that. Several areas of technologies use MongoDB as their DBMS currently. Some of them are Internet of Things, mobile applications, real-time analysis, personalization, catalog management, and content management. Now all said and done, let's look at some of the companies that use MongoDB currently. Companies like Toyota, SAP, AstraZeneca, Adobe, Verizon, Cisco, Barclays and Google among others readily deploy MongoDB as their database management system. In this video, I'm going to help you install and set up MongoDB on your Windows system. You will have to navigate to the official MongoDB website. And here you can see software. So go ahead and click on Community Server under Software. And you can see that the current version is 4.4.4 and the platform is Windows, and make sure that the package is MSI. Alright, now go ahead and press download. So this could take a while. Alright, so once it's downloaded, go ahead and install it. Now since it's already installed on my system, the installation process will be different, but you just need to follow the steps there and finally install it. So once you're done with the installation, you can go to your C drive, and here you can click on Program Files, and you can see that MongoDB is installed. And inside of it, you have the server folder, and then you have the 4.4 folder, and then you have the bin folder. Right? So here you have the application, that is your Mongo and the MongoD applications. Both are executable files. Now the MongoD file or the application is the daemon process. Now this is the background process that makes sure you retrieve the data from the database, access the data. So it does all the background tasks. So after the installation, now you need to create a path to this file. By doing this, you don't have to always go to the bin folder and then execute the file. You can directly execute the file on your command prompt, right? So for that, let's just go to our environment variables. But before that, let's just copy this path, right? And here under the user variable section, click on path and say edit, and go ahead and just paste it, right? I've already pasted mine, so just go ahead and paste it and click on OK and say OK, right? So now you've created the path successfully. Now let's head to our command prompt and run the Mongo file. So here you can just directly type Mongo since the path has already been created. So just go ahead and say Mongo, and here you can see that your Mongo server has been generated, and with this you know that your MongoDB has been successfully installed and your server is up and running, right? So just for confirmation, let's see if there are any databases and how much space they've occupied. So you can right now just type show DBS, and when you click on it, it says admin, config and localhost, and all of it is 0. So with that, you have successfully installed MongoDB on your system and it's up and running. Alright.
In this particular tutorial, we will be learning what MongoDB is all about and their advantages and some practical demonstrations. So let's get started now. So here in MongoDB, we would like to discuss about what is a MongoDB. So as we know, the MongoDB is known to be a traditional document-based database, okay, which stores the data in a document. Okay, NoSQL means it doesn't say like no to SQL. Instead, it says not only SQL. That means it is not only SQL, but it is supporting the other approaches too. Okay, so the document based, when we talk about it, actually represents the typical hierarchical relationship using the single records. That means how the records are related with each other. So that's how exactly it represents. And it is a pure schema free environment, so that you really do not need to have a schema before you go and develop this program. So it is a pure schemaless environment. Due to that, it is giving you far more better flexibility when you talk about completely unorganized environment. So what is NoSQL? So here's the idea about a NoSQL. So it is completely into the non-relational database. Like traditionally, if you see any non-relational database, you talk about typical NoSQL, it's purely into the document base. Here, NoSQL does not use any tables like in rows and columns. A traditional RDB based approach, if you see, there they are using a complete table structure, like they talk about columns, they talk about rows and all about. So here in NoSQL, it stores the relationship data in the documents. So the different type of NoSQL databases are available, like you talk about called document based, you talk about key value based, you talk about white column based and graph based. Different options are available for the NoSQL, but the one which we are using at MongoDB, it is a purely document based database. Now here we would like to go ahead with some demonstrations, like talking about like how MongoDB installation works and the other aspects. Okay everyone, so now we're going to start working on the first option called MongoDB installation. Okay, see, MongoDB installation is very simple. If you open on a website and go for this website name called MongoDB download. If we talk about MongoDB download, you're going to see the official website called MongoDB community download is available. When you click here, so you can see it is taking the current version to 4.4.6. macOS, it by default detected my platform. However, you can select, depends on which platform you have it. And after that you will be clicking on this download. Okay, so it will get ready for. If you are from Windows, I would say in this Windows you can select appropriate option, like two options are available. You can talk about MSI or talk about zip. My recommendation is you can stick to the zip portion, because it won't start any MongoDB services behind the scene. That is really helpful, because you really do not want the MongoDB to be there running unnecessary, even if it is not required. My suggestion is to stick to the zip file. So here, once the MongoDB is there, so you will be seeing there are two files available inside the MongoDB folder inside the bin. So once you download the zip, you will find two different type of files are available. Let me mention those. So inside the bin folder, you will see two files. One is called MongoD. Okay, the other file which is available called Mongo. MongoD is to basically start the MongoD server, and the Mongo is actually the client which will connect with the MongoD. Clear? So if you are in Windows environment, so once you are inside this bin folder of your zip file, you will get the MongoD. So you have to double click on this. It will start a new command prompt. So you do not need to do anything further. Just minimize this command prompt and go inside the bin folder again and click on the another binary file called Mongo. So it will get start as a client. Okay, since I am using the MacBook, here the concept is little different about how MongoDB can be used. Okay, so this is just a basic way of how the Mongo is being used into your code. Okay everyone, so now as we are in the MacBook, so here to start MongoDB we have a very special way to start with. So here I'll start with my terminal, and here I would like to paste one very simple command to start my MongoDB database, that is called MongoD. And after that you have to say --db path. It is the place where your database will be starting. And one more important thing I forgot to mention, like MongoD would not start automatically inside your Windows machine unless inside your C drive you have to create a new folder name called data, and under this you have to create a new folder name called db, because automatically when the MongoD starts, it looks inside the C drive data inside a db folder. There your all records will get stored. So do not forget, whenever you're trying to use the MongoD, so you must have this particular folder structure in place in your local machine. Otherwise, this is not gonna start. Every time you start your MongoDB without this location, it automatically terminates. So to avoid those, make sure that you have this DataDB folder ready with you. However, you can also change the location of this particular folder structure, for which we will discuss it little later on. But as of now, we can see I'm giving my location that is called -db path/datadb. I hit enter. You can see now my MongoDB is starting now, and since it's stuck, so I have to start the new terminal now. So here I'll open another tab and type Mongo, and the moment I type Mongo, now you can see it is now connected with my MongoDB, and now it is ready. That's the first thing you need to remember. Okay, now to check which other databases are available to you, so you can just type show DBS. So it will show you the number of databases which are already there inside your existing newly installed MongoDB. But you can go back and create new database too. Here you can see some databases are already present. However, you go back and create the new databases into your system. And to create this database, we have a very simple option available here, name called use SimpliDB. If I say use SimpliDB, it automatically creates this database and take you inside. Let's see. Now you can see you say use SimpliDB, it automatically creates, though it is not there, but automatically takes you in while creating those. Okay, so that means you are in current database name called SimpliDB. So if you're not sure which database you are in, so you can just type DBS or DB, and it will show you that your current database is SimpliDB. That's it. So your database is set, and we are all good to go ahead with our next level development. Hello everybody and welcome back. In a previous videos you have seen like how to create a database and how to identify whether my database is there or not. So if you remember, previously we have created our database using use keyword. So if I just see my databases which we have created last time, so how we can check this out? We can say show space DBS. Okay, so you can see we have got database list, but we do not have any database which we have created last time is registered here. That's quite surprising, because when we have created our database, it should be listed here, but it is not. Let's do one more time. I'm saying use SLDB, and I'm saying switch to SLDB. Now when I say once again show DBS, so I still don't see my database is listed here. There is a reason. The reason is, according to the MongoDB rule, unless we have minimum one record or collection stored inside my MongoDB, it really can't show in the list. Now I want to tell you about a few important things. Now here when we talk about called MongoDB, in this MongoDB, compared to the relational database, here the table which is actually in RDBMS it is called, here it is called collection. Okay, DB is still called DB here. Okay, that means the database will be still called database, but row, what you use this word in a traditional RDBMS, here it is known as called document. If you remember, I told you like it is a document based database. So here every single record what you try to insert, it is not called a typical row, it is instead called a document. So every table is called collection and every single row it is called document. That's what exactly the difference is. Okay, now here once it is ready, we will go ahead and talk about our next feature now. Well, we have to basically go and create a new collection. Okay, so what you can say, db dot create collection, and here I can pass my collection name. I can say demo collection. So once it is done, I can see collection is created. In typical language, I can say the table is created, and now when I try to see same show DBS, I can see my database is now listed. Okay, that's how exactly it works. So the very simplest way of how we use in my code. Well, in our previous examples, we have seen like how we can create a collection, and we can give the name, and I can see the details are listed when I say show DBS. But there's again another alternative option available where you can just do that without even saying db.createCollection. Well, if I want to create a collection, I really don't need this particular functionality called create collection. I can directly use this statement name called db.sl student.insert, and here we would like to add the property like a name, and here we can say admin. Now what is that meaning is, when you say db.slstudent.insert and I hit enter, you can see this n inserted one, and surprisingly when you try to say press enter, you will see this SL student is not a collection which we have created earlier. So what this line does, this line not only create the collection for you but also add a record inside with this property called name, because that is a MongoDB, and MongoDB is always following the JSON based structure, and due to that it goes with the key and value pairs. So DB is a predefined keyword, SL student is a collection name, insert is a command through which you are trying to insert a record. Now to check how many collections are there. Okay, so we have one property called show collections. When I say show collections, I can list down those number of collections, or else I can say tables in a typical RDBMS language which are there added in my system. So SL student, in which I can see the record is inserted. So if I want to confirm, I can simply say db.sl student.find. Find is a function through which I can list down those number of records which are added. I say find, and you can see that the records are received. At the same time, when I say db dot the name called demo collection, okay, db.democollection.find, I'll find no record. Reason because this collection was created but there was no record which was inserted in. But you will see when I write this command called slstudent.insert, it not only create a new collection for me but also insert the record into my table, also called a collection. That's where exactly it is giving you the advantage when you want the collections to be created along with the data. This is the way how you can really do this. Clear? But whenever you talk about db.createCollection, many people always think about what is the significance of having this db.createCollection. Look, db.createCollection is having its own significance. We never recommend this technique, okay, to create a collection, because when you create a collection you always bring some restrictions, some terminology which missed out whenever you talk about this line. So having this db.createCollection, you can also offer some additional capping which is not possible when you use db.collectionName.insert. So you might be thinking what those cappings you're talking about. Let me try to brief you. When I say db.createCollection, and here we are providing the first name called suppose student. Okay, when I say student, so after this is student, additional parameters what we can pass is this. When I say capped colon true, what we say? Capped colon true. So you are enabling the capping. After that, the next parameter I'm going to pass, that is known as called size. In this size, we are providing the size. Suppose I'm saying 5 to 4, and also we are saying 2880. That is the size of 5 MB, and here we are giving call max colon 5. What exactly that meaning is? See, the meaning is very simple. Whenever we try to bring this create collection option, so capping true means you are enabling the capping. So what does that meaning is? It is trying to say in this particular collection name called student, maximum number of documents can be either 5 or less than 5. Clear? And the collective size of documents cannot be increased to more than 5 MB. That means you're trying to say either by adding the total number of 5 records, the collective size of 5 documents will reach to 5 MB, okay, or else the maximum number of 5 documents can be stored. So whichever fills earlier. You may have a total number of 4 documents which are pretty heavy and they reach to the size 5 MB, and beyond that the next document won't be added, or else you can have the 5 documents which has not yet even reached. So any option will help you to achieve this. So that's where exactly you can offer the capping, but this is only possible when the user is trying to say db.create collection. This option is not possible when you're trying to use this. So that's the benefit of having this db.create collection, and this is what we always recommend. Well, now we would like to talk about our next feature here inside the same MongoDB. So we now know how to create a collection, how to create a database, and how to switch from one database to the another database. Now we will tell you like how to insert a document. So far we have already seen how to insert a document inside the MongoDB. Now we would like to also show you how we can insert the documents using multiple techniques. So remember one thing, MongoDB comes with two different types of documents. One is called relational document and second is called embedded document. Mostly while working with MongoDB, we always recommend you to use embedded documents because that helps you to scale up your application without any hurdle. Okay, the embedded documents means what? That means the I would say the parent record as well as the child records both stores in the same location. Fine. So how exactly that is? Let's take a look about this example. Here we would like to insert some records by saying db.student. I do not have a student collection, but I'm just telling you db.student.insert. Here we would like to add some records. What I'm trying to say, the registration number. I'm just saying 1, 2, 3, 4. You can give anything. Now the next one we will talk about called name. This name we can say student1, followed by the next one. I'm talking about which course the student has registered, so we can say course. Inside this course we would like to say the course name. So let's say course name. We are giving the course name called MCA. Okay, followed by another property called duration. Okay, I'm giving this duration is called 3 years, like that. After that, this curly braces is closing. That means, see, the idea is like you see the course is an embedded document because from course you have got few more properties like in course name and duration. I'm closing this and starting the another property, and that is called address. Okay, sorry, let me remove from here, and from address. And address, we can say one more curly braces, and inside this address we can say city. I'm giving the name called what? Bangalore. The another one we are using that is called state. Let me remove this state colon KE. Okay, and the third property we are using that is known as called country. Here we are saying IN, that is called India. So it is closing here, okay, and it is closing here. So the inner document and outer document both are closed. Hit enter, and now you can see the records are inserted. One thing you might notice, the course and the address, these two are embedded documents and they do not have any primary key of its own. Instead, the course and address both are directly dependent on the student object or the student database. So I will say student have the registration number, fine, and the primary key. So the primary key will be associated with the most outer document, and the inner documents are directly associated with them. And now when I try to say db dot student dot find, you can see now the records are fetched. I can understand many of you are thinking every time while adding the record we do not add any object ID, and here you might have observed, and there also you have observed. Then what exactly that ID is? Now let me brief you. This ID is nothing but a unique primary key your MongoDB has offered you. That means MongoDB says whichever data you are inserting it, so by default with every single document MongoDB will associate this by default property called underscore ID, which you can't even ignore. However, you can override. I haven't provided any underscore ID as a property because this is a predefined property associated with every single MongoDB document. If you want to override it, you can override from this value to any value, because if you do not pass any value, this value will be automatically provided. That is a typical hexadecimal value. However, if you want to override it, you can override the value of underscore ID, but you can't change the key name. Let's try with some another record. So the same record, if I try to add, let's go, I'm using call student2, and here I'm saying 1 2 3 4 5. Here if I want to override it, I can just say underscore ID colon, now I can give the value called what, 101. This you need to remember. So I'm overriding this value with 101, now adding it, now the records are added. Now let me call find. Now you see this time the records when I fetched, so in this record the first record contains a default underscore ID, in the second record it is the one which I have provided. And remember one thing, in MongoDB you really can't offer any property other than underscore ID as a primary key. Here there is no concept of having the like in composite key which you used to do in traditional IDBMS. Here you have only underscore ID, and this is the only property which you can override it, else by default the new value will be given to you. So this is the first way of how the insert document has been done. We'll be telling you the another ways where the other documents are also added. Okay, so in the previous examples you have seen like how we can add the records, but I also tell you there is another alternative options are available if you want to insert the records in a bulk. That option is also possible in MongoDB. How we can do? Let's try to understand. Here we would like to use one very simple concept called var my emp equal to, now starting with a typical object like this, and after that I'm adding this, and within this I'm adding the first property called emp id colon 1. After this, okay, now you can see it is not understanding, because there is a challenge when we talk about call the logical part, because you go with multiple lines, it is not supporting. However, you have to follow the same lines now. emp id 1, and we just give the second property called emp name. So emp id, just remove this. I just say emp id and I say emp name colon admin. Okay, adding it here. So first record here, again I'm adding another one that is called emp id colon 2. Okay, and now colon manager. Okay, again colon 3 and colon QA. Added. Okay, and this curly braces is closing. After this, your square bracket is also closing, and once it is done, you come down and say db dot new emp dot insert. Okay, and here you pass the name of the object called myEmp, and you can see now it is telling you n inserted 3. That is known as called bulk insert, where you're inserting multiple records in a single shot. See how easy it is for you. Okay, now you simply use db dot, the collection name is what? Your new emp dot find, and you can see now all 3 records are inserted with its default object ID. Okay, so that is a really nice idea to have the ID to be provided. Okay, remember this statement. So you understood finally how we can add the records in a bulk. Going forward, we will also talk about which is related to your update as well as delete in your upcoming demos. Okay, but here that is the first thing which you realize it, how we can perform those kind of operations in very simple and straightforward manner. Okay everyone, so now we have got 3 records with us, and in case if I'm planning to perform update on any of my records, how will I do this now? So we have a predefined functions available name called update function. Let's see how this update function can really work. So we use this statement name called db dot, what is my collection name, which is known as called a new emp. Okay, dot update. Okay, so what I will do, I will say db dot new emp dot update here. Okay, now when we talk about called update, we have a statement available. Okay, what is that? That is called emp id. We have called emp name. So we say wherever the emp id is this, I want to change what? The name. How can I do this now? Very simple. To perform this, what I would like to do now, I want to basically add few more records to give you some more better idea. You can see now here we have a call admin id name. So I just do one thing, I just change the IDs 1 2 3, I just say 4, I say 5, I say 6. Okay, and I call this. Again the 3 records are inserted. Now let me try to call find. Now we have total number of 6 records are available where admin is repeated, manager is repeated, QA is repeated. Now let me try to update the record. Okay, now I want to say db dot new emp dot update. Here I would like to perform the property like in what name, I say emp name colon, I say admin. Okay, so I just close that and I use another curly braces with dollar set. Set means you want to set the new value. Here we are giving emp name. Okay, what I want to do, I say wherever the name is admin, change to what? Admin new. That name I want to change it. Close this, and run. Now you can see it is saying n matched to 1 and the record fields are updated like this. Let me check. Well, here I will see the value called admin new is updated, but I have one more admin called admin. It is not changed, and that is something which you need to notice. What you need to notice is like when you try to perform update. So what MongoDB does, it starts from the top, find the first record, change the value or modify the value and come out from the loop. It doesn't carry forward its search process for the next level of results. And that is something which is, I really want to do that. So in case if you are planning to change those values multiple times, so what you need to do, let's take a look. Here in the similar example, here we have a call name admin, second property we have a call manager. Let's try to say managers are repeated twice, so we just want to change to new underscore manager, and I want to update multiple values. So what I will do here, I will put comma and say multi colon true. Okay, saying multi-colon true, that you want to say, hey, I want to update multiple search or multiple repetitions. Hit enter. This time you can say it is saying and match to and modify to. That means 2 records found and 2 records are modified. Let's check. There we go. We have got new manager is updated in both the location. That's something which is really awesome, because this is how you try to perform the multiple changes. Well, in our previous examples you see like how we can perform the update part, but we have one more beautiful feature available inside the MongoDB, and that is called how exactly we can perform upsert. Clear? Let's talk about upsert. Upsert is a combination of update and insert. Let me try to show you one magic here. Here, when we talk about called update part, you see now, here we are trying to say this point. Yeah, you see about multi-true we have used. Now here, this multi-true is we're trying to update, but let's talk about something called manager2. Enter. Now you can see it is saying no records found. Clear now, no records found. But there's one concept available in called upsert. Upsert means if I try to perform upsert, it means if the records are not available, it will insert the record. I want to show you one simple example now. Here we are using multi-true. Okay, so as I can see, we are using something called name and we are performing this update part. So in this update part, we are using this $set new manager. So here, rather than using multi-true, we are saying upsert true. When I say upsert true, so what happened now? They say n matched 0 and up inserted 2 and modified with id this. That means when I try to call this find function, you will be seeing now we have got the another record has been added. Are we clear now? As a new record. So upsert does what? Upsert says like if the records are found, I will update it. If it is not, I will insert it. That means if I try to call the same thing, manager 2, fine, it is added as a new manager. Now if I just try to say not manager 2, I will call QA, and here we are saying emp equal to new underscore QA. And now you can see it is saying n matched 1, n upserted 0, n modified 1. So it is clearly telling you like, hey, I did not find any inserted part, but yes, I matched one record, I found one record, and the one record is updated now. That is very, very beneficial feature when you really want to perform upsert. So that is the advantage of upsert. That is also called update plus insert. Very important feature that depends on the requirement. If you want to add, you can certainly add this. So the way we have tried to add this upserted part, we can also try to perform the delete part also. Okay, so MongoDB also helps you to perform the delete part. And how you'll be trying to add it now? Let's try to understand. Here in my code, if I want to perform any delete part, I have this statement name called db dot, the option we are using it, that is also called collection name emp, new emp, sorry, dot, we have an option name called remove. In this remove, we would like to offer the property. Okay, and what we're talking about now here, let's try to add the ID here or the name which you would like to import. So I want to say like emp name admin new. So we just say p name. Okay, and then name is called what? Admin new. Okay, emp name admin new. When I say remove, you can see it is removing the first record. So you can see now the records are removed. Fine, because there is only one admin new is available. Okay, now in a similar way, if I try to remove the property called new underscore manager, new underscore manager, hit enter. Now you can see the 3 records are removed. So it's not like update which removes update only one record. It can also eliminate more than one records at the same time. That's the benefit of remove. So now you can see we have already implemented some records. As I seen earlier, like we have performed the delete part now. Now when I try to say db dot new emp dot find, 3 records are available with me, 3, 4 and 6. Now when it comes to insert part we have seen, update part we have seen, delete part we have seen. Now it's time to basically fetch the records. So find function we've already seen, but in find function we also have some conditions, so-called queries. So in case if you want to limit the number of records into your application, you can also do that. Let's see, db dot new emp dot find. Clear now? So in find you can also pick up the specific records too, like when I'm saying dot find, and here we can just say name colon admin. Sorry, here to put curly braces. It says there is no record with a name called admin. because it is an EMP name, not a name. So let me change back to. Now you can see it finds one record. So like that, you can also apply a condition, okay, into your code. Now, in a similar line, if you really don't want to offer any condition, okay, but you want to limit the number of records to be shown, so you have this function available name called limit 2. 2 means only 2 records. Now you can see, though I have 3 records, but it is only showing me 2 records because I have limit those number of records into my code. Also, we can perform sorting in case if you want to perform the sorting in ascending and descending order, that also you can also do. So here, rather than saying limit, we just put this option name called sort, and in this sort, on which property you want to sort it, that also you can mention. So we can just say emp name okay, and using ascending order or descending order, so you can just say -1. That is called descending order. Hit. Now you can see it is showing in a descending order. Now if I just say -1, if I just say 1, now it is showing you in an ascending order. So you can pick up the specific property behalf on which you can tell it should be either on descending order or ascending order. So that option really works very fine. Okay. So that's like how you can perform the queries. But remember one thing, you can also search the records based on their embedded columns too. Because if you see in our previous records, we have some records added. Okay, that is, let me try to say show collections. I will call SL student and student. Okay, db dot find. Okay, you can see we have records which are embedded records. Now if you want to search the records based on their embedded properties, like I'm talking about address, there's one property name called city. Fine, so if you would like to pick up those records, these are also possible. So how you can do this? Very simple. So you say db dot student dot find. Okay, so inside this find, you can provide the specific properties. Like my outermost property name is called what? Address. So we are using this option called address dot city. So we say city. Are we clear? Colon. I'm giving the city name called what? Bangalore. Clear? Let me close this. And that's it. Okay. So we have to start passing another curly braces here. Hit enter, and you can see now I find 2 records because both the records belong to what? Bangalore. So I'm getting this city Bangalore with me. That's really awesome. Like you can also pass the city accordingly. Apart of that, we also have the other details also, okay, in which you can have the conditions based on less than, greater than, or whatever values you would like to make it is available and possible. Okay, so that's how the conditions are satisfied. So suppose if you would like to pick the users, are we clear, where the range which you would like to consider, so those are also possible. Like you can see we have this property name called what? EMP ID 3 and 6. I just want to pick up only those records whose ID is greater than what? 2. So what I can say, db dot new emp, okay, dot find, and inside this find we can say the property, Okay, so what's property we're using? emp id. We are saying emp id here, colon, here we'll be using $GT. GC stands for what? Greater than, colon. We're giving the value called what? 1. Fine. Close this. Run. You can see you have received 3 records, 3, 4 and 6. In case if I just look forward for higher than 5, you will see only 1 record. So greater than, that's called GT. Okay. Same option, if I just say LT, you can see we have found 2 records. So less than, greater than. Okay. So that's how exactly you offer it. Okay. And also you can provide the condition so-called limit. As I can say find emp id the way we provided. So here I will not use less than. Okay. Instead I'll be providing another property. Let me show you what. So here in emp id, whatever we have taken, so let me try to take the property called find, and here we are providing emp id, and then we're using another curly braces, and we're using $in. Is very important property, $in, colon. Here you provide the details. I'm saying inside, so the property is 346. We are saying 3, 6. Close this, and you can see we got 2 records which matched with 3 and 6. That's the benefit of having this. Okay everyone, so in our previous example we have already seen many activities. This time we are trying to offer you something very interesting feature, and that is known as called working with indexing. See, MongoDB is one of the most popular tool, and one of the reason why it is very popular because it is having the facility of having indexing. Now what exactly the index does? So friends, main job of having this index is to basically give you the concept of like how one particular document, which is huge document, in case if you would like to perform any sort of indexing inside this, how you will be applying this. So to apply indexing into my code, let's try to understand why index is really required. Without indexing and with indexing, how you'll be making a difference into the code. So to make it happen, we would like to insert some records to confirm. Okay. So what I will do is in step number 1, previous records, if I see, I have got 46341, depends on what earlier records we had it. So we had a call new emp. So db.new-emp.find. So we have total number of 3 records are available. So it's okay, we can have this 3 records with me. Now let me try to apply indexing. Without indexing, if I want to find a result, what outcome I'm gonna receive. So to know about how much time it's gonna be taking, if I have got large number of records with me, I'll be using this statement name called db dot, the name is called new emp dot explain, and here I'll be using one predefined functionality called execution stats. Execution stats. Okay. Now here, after the execution stats, we'll be using dot find. We'll be using the first property here. Okay. And what user would like to find it, that you need to basically offer it. So we are giving the name called emp name colon, giving the name called QA. Okay, let's close. Okay, now when I pressed hit enter, execution stats is a predefined functionalities which will tell me when the query was executed, what exactly the query plan was. hit enter, and now you can see a lot of details are available with me. Like you can see parse query, winning plan and everything. One thing you need to remember, by default, here when I try to run, it says n return 1, advanced 1, need time, total, everything it is showing me. But one important thing which you will see here is total number of documents scanned. So it is telling me total number of document examined is 3. Clear now? N return 1, that means one result is returned and the total number of documents examined is 3 in order to find this record. Just imagine a use case here. When I say total number of documents examined 3, in case if I have got millions of records with me, that means to search the record, it will examine all the millions number of records to search the result, which certainly gonna be taking huge amount of time. And that's where exactly when you try to search the record, fine, when you have no indexing is available. Okay, so you need to understand one important thing is, by default, index is applied on your underscore ID. db.newemp db.newemp. When I say db.newemp.getIndex is a predefined function, it tells me like, hey, by default index is applied on underscore ID. That's a fact, because by default index is applied on underscore ID, not on the other properties. So I need to identify which of the properties are required to be get indexes. MongoDB advantage is it is supporting multi-column indexes, and that's what exactly we would like to see. So let's see in our next demo. Now we will try to apply indexing on our own property. Okay, so to apply the index, what we need to do, we have to say db dot, certainly we will be talking about called collection name, call new emp dot create index. Here you have to pass two things. Number one, on which property you would like to apply. Okay, and it has to be ascending or descending. So I'm trying to apply on emp name, and I want the index to be applied on ascending order. Okay, so here :1, hit enter. You can see now it is telling me like number of indexes before 1 and number of indexes after 2. That means earlier index was available only on one particular property, now it is applied on 2 properties. If you want, you can check. Now you can see there's another property is added called emp_1. Now if I try to execute a similar query which I executed earlier, QA, now you'll be seeing there's a different statistics altogether. Here if I see in my code, see it will tell you total document examined 1. See now earlier the number of document examined were 3, but since this index is applied, now it is telling me the total number of document examined is 1. So performance is certainly improved. So to search your document, it won't be searching the complete collections. Okay, rather it will search what? Only that particular column in which it is actually applied for. So that's the benefit, in fact I would say, when you will be using these kind of indexes into your code. Okay, so hope we all are clear and understood about this concept. So let's go ahead and get this implemented into our system. Well, this is the first way of how the index can be applied. So you can also apply index on multiple properties. Clear? So that we will show you one by one how it is. Okay everybody, so we have already seen in our previous example how we have applied indexes in our existing MongoDB application. So it is also a possibilities where we want to also apply the index on other number of properties too. As you can see in our existing database, okay, an existing collection. My collection name is new EMP, which contains two different properties. One is called EMP ID and second called EMP name. Just now we have applied index on our EMP name, but in case if I want to apply index on EMP ID, I'll be using the same technique. Okay, let's try to apply index on the same. So first of all, get indexes. I'm having this index applied on two different property. Now we would like to say db dot create index, and here in this db dot create index we can just, I will say db dot collection name. So our collection name is called new EMP dot create index. First parameter is certainly the name of which property we are applying. So here we are saying EMP ID, and in this EMP ID we will just offer it has to be ascending or descending. Let me decide descending order. So we are saying -1. Okay, now let's press enter and check the status. Okay, now you can see earlier indexes which we have created, that was 2, and now it turns to 3. So it is very clear that index is improving. Now let's check this out. db dot new emp dot get indexes. Now we have a total number of 3 indexes are available. So you can apply index on n number of columns if you want. Okay, at the same time, the way we have created the index, in case if I want to drop an index, so we can also drop. So what we can do, db dot new emp dot drop index, and in this drop index we have to provide which particular index we would like to drop. Remember this point. In case if you're planning to drop any sort of index, so you need to provide which index. So you should have that particular index name. Okay, so here we are providing my index name. So it should not be I would say the traditional name called EMP ID. No, it has to be EMP ID underscore -1 or EMP name underscore 1. So this should be the name. I'm saying EMP name. In case if you try this, you see it is saying index not found with the EMP name, because internally it maintains with this name. Let's try this out. We say EMP name underscore 1. Let's try, and now you can see new index was 3. Okay, 1. Okay, now you can see we have a call EMP ID and underscore ID. So now we have only 2 indexes left. There's no EMP name anymore. This is how exactly you can drop the indexes. So it is very simple and straightforward way of how in MongoDB you can perform your activities. Hello everybody and welcome back. In the previous examples of MongoDB, you might have considered we have used lot many operations. In our last video we have seen how to utilize indexing into our code. Now in our next journey of our MongoDB, we will see how aggregation works. See, in MongoDB aggregation plays a vital role, and aggregation comes with so many handy functions with MongoDB which will help you to perform and to apply some very simple code snippets into your ongoing I would say the requirement, which can make your query so much seamless. Now we will see how this aggregation really works, and to work on an aggregation we have taken some default database name called aggregateDB, and here we have a call student as a by default collection in which we have some set of records are already added. Now if I just want to apply aggregation, now I would like to tell you about what exactly the aggregation is. See, ideally when you talk about called aggregation, okay, so aggregation is nothing but a call aggregate. Like RDBMS, if you see, we have a call aggregation there. So in a Unix command, like you talk about shell pipeline, means the possibility to execute an operation on some input and use that output as an input for the next command. That means the output of one particular execution becomes an input for others. So MongoDB also supports same kind of concept in aggregation framework. There's so many type of functionalities are available, which we will see one by one into our next code. Okay, now here we want to confirm about a few important things. Now here let me try to bring some of the important, well-known, I would say, the functionalities of our aggregation framework. First, we use a term name called $project. The project is basically designed for select a specific fields. $project is designed to select what specific fields from a collection. We used to talk about called what? $match. The match is responsible to filter out the operations. Are we clear now? It is designed to filtering out the operations. You talk about $group. Talk about $group. So it does the actual aggregation. Fine. We talk about call $sort. Okay, it basically sort the document. Okay, like that there's so many operations that are available, which we will see one by one in our aggregation behavior. Now my first example, the one which I want to execute, I have a called student record with me, which contains a student name, okay, the section and the marks and the subject, on which subject the person or the student is appeared. Now here my first requirement is we want to filter data based on a section A, because students belong to the different sections. As you can see now, they belong to the different sections, section A, B, C, D. So I just want to filter the data based on a section A. Okay, so for filter out, I would like to use $match. Let's see how it works. So I just would like to filter out only those students who belong to the section A. So how we would like to use it now? I will say db dot student dot aggregate, and inside this we would like to use this square brackets and then curly braces, and then use $match. With this I would like to use another curly braces, and I say section A. Okay, and I close this, close this, close the square bracket, close this. Okay, so db.student.aggregate, aggregate should be always associate. Match is now the aggregate functionality, section A. Hit enter, and you can see now it lists down all those students who belong to the section A. Okay, very simple and straightforward example. Now we would like to use the second example. So we want to find out all the records where the section is A and we are using AND operator. Marks is greater than 80. There are so many students who have a different marks like 70, 90 and whatever. So we want to use both the conditions together. So how are you going to be using this now? Remember, not only the section A but also marks who are greater than 80. So similar thing, we have a call match. Okay, after this match we are starting this curly braces. Okay, so after this match we would like to bring AND. We say $and again colon. Again we are starting this square bracket now. Okay, we talk about what? Section A, number 1, and after this the first curly braces we would like to use marks. So we say marks colon, and once again they would like to start curly braces, and here we use $GT, that is called what? A greater than colon 80. Okay, all are closed. So you see, like here we have got this square bracket and round brackets. So what else is left? So we have called 80. We are using another curly braces needs to be closed here, and then square bracket, okay, and followed by again curly braces, again curly braces, again square bracket, again round brackets. Okay, let's see where it has gone wrong. So we are using this db.student.aggregate. We are use this, yeah, square bracket, then curly braces, then we use $match. Okay, after the $match, we are using another curly braces, and we have a call AND operator. After this AND, we have a call this square bracket, then curly braces, section A. After section A is getting closed, we are using another curly braces, marks, colon, $GT. Okay, and we are using what? Colon 80. After that, we are closing this and using two more curly braces, square bracket in this. Okay, so this where exactly you can utilize that. So db.student.aggregate, and like this it will be able to get it now. Okay, so in a previous example that was the only missing point was after this this $match, we didn't apply this curly braces. That was the only missing point which was there, and now we have applied. Another code is giving me this outcome, and I have only one user who's scoring greater than 80. Well, that was the first thing which we have it now. Along with this, I would like to go ahead and talk about few more things. Now, I just would like to bring selective fields, not all the fields. Like as you can see, we have a call student name, section, marks, everything I'm getting it. So I really don't want to bring all the properties from this document. I would like to selectively take specific property. So let's talk about how we can use this. So we'll be using project. You remember about project is responsible to select the specific record. So I just use this statement name called db dot student, okay, dot aggregate. We're using it now. After that, now square bracket, then curly braces. Now we are trying to say $project. What we would like to use? $project, and colon, we are trying to use student name, okay, colon, okay. Remember one thing, 1 means I want those, 0 means I don't want. So whichever property will be enabling it by giving the 1 as a digit, that means it is expected to be displayed. So I'm saying 1, comma, I'm saying section, colon, 1, okay, and I'm also looking forward for marks, colon, 1. That's it. So now you can see now I am once again picking up only those like student, section, and marks. Now if I go back and remove some properties, like I only want student and section, you can see I have only student and sections are used. Here if I just use this statement name call underscore id colon 0, now you can see only the names and sections are visible, ID is not, because I really don't want ID. By default ID is shown, but if I say it's 0, that means the ID will not be visible here. So like that you can select the columns or the properties accordingly. That was the one way. Now the other thing I would like to use, what if you want to find out the student name, section, and marks from student? Once again, we want to find out the student name, section, and marks from the student collection where the section is A. Okay, so here it will be the combinations of match as well as the project. How we can use this? Let's take a look. towards my implementation. If you see the previous one, what we have used here, you remember about, we have used this statement called aggregate match. Okay, so now we would like to go back and utilize, after this $match, this is a curly braces, I'm giving section colon A. Okay, section colon A, and after this I'll close this. Okay, and close this again. Again I'm opening it up by using this option called project, $project. We're picking up the project right now, and here with this colon symbol we can use again and say student name, colon, we are using 1, comma, section colon 1 and 1, marks colon 1, and now closing this. Now you can see I got those. So the requirement was, we want to find out the student name, section and marks from student collection where the section is A. So you are not only using the match, okay, but also using what? The selective details. Like this you can implement it. Okay, that's where exactly the projection really works. So projection gives you lot many opportunities which you can utilize it for your own, and also it comes with lot many predefined functions like in sum, AVG and all. So let's talk about those functionalities too. So this is the first thing which we have seen, aggregations are taken place. Now in case if you would like to perform the group, like if I want to find out the total marks, group by, okay, section, like each and every section I would like to confirm the total marks in every section, then how will I basically do that? So let's try to get this example also. So here let me try to go back, and we will not be using match here because I would like to use the group part. So after this curly braces we want to use $group. Okay, that is called group by. In RDBM is how you use it. Here we use this curly braces. Again here we are passing this underscore ID. Okay, you have to provide underscore ID in a group because you cannot skip it. That part you need to be always remember. You really can't skip $ID whenever you're trying to talk about called group. This is a compulsory field, you need to have it. After that I'm using this section. In this section we are saying $section because we would like to make it on a section basis. After this closing, and here we are using what? Total marks, colon, here curly braces, again $sum, okay, colon, on which behalf I want to use in marks, so I can say $marks. Naming convention is very important because it is a JavaScript, so it is a case sensitive. Okay, then, and we can see now section wide I'm able to get all the marks. Isn't it amazing? That's where exactly the aggregations are playing very important role while retrieving such kind of records. So hope you are clear about how we utilize this together. So in a previous example we got it like how we are basically taking this marks in my application. Fine. So we are clear about how we are picking that up. But what in case if I would like to take marks for the specific section? So it is also possible. So we'll be using the same group but the only thing is what will be bringing the match between, because here we are trying to get all the section marks, but if you would like to bring it only for the specific section, we know it very well what we need to do. So here, before I talk about called $group, we can use one more curly braces here. Okay, so we can use this option called $match. Okay, and here we are using this option called section A. Sorry, here in $match we are giving this call section colon, here we are giving A. So closing this, followed by the other areas like in group which you want to start now. So you can start with this curly braces, hit enter, and you can see now only the specific section you're able to receive the records, and that's very simple now. Okay, so that's where exactly you would like to perform. And there's another option, like in case if you would like to perform an average. Suppose if you want to fetch the count of students in each section and total marks and average marks as well as. So total marks as well as the average marks we want to get it. So how are I able to take it now? So it is very simple, as you have seen earlier also into our code, how we have taken call group underscore ID section. We're talking about section total marks with the sum. We are also using this. After that, we can also use the average. Okay, so this is, we have taken called group underscore ID sum. So here onwards we will start. So when we say sum marks, after that we can just put curly braces and we can just use count. Okay, and after this we'll be using this colon, curly braces, and use $sum. Okay, colon 1. Okay, and after that I'll put comma here, and we use average, and inside this average I will use, in curly braces we can say $avg. Okay, colon of what? $marks. Very simple. So curly braces is closed. Okay, so total how many? 3 curly braces will be closed, 1 square bracket and round brackets. And now you can see you got the average markings in each and every section. So just imagine how easy it is for you to deal with the aggregations. So aggregation seems to be a very simple approach provided by MongoDB that really create a difference of how the aggregation changes the way how you react to. Okay everybody, so after going through the idea of like how we can utilize the concept of aggregation, it's time to talk about like how when it works with MongoDB. MongoDB is properly known for, I will say, for replication, that is called high availability, and that feature comes by default with MongoDB. You really don't need to install any software for this because it is a built-in feature for the MongoDB. So when you download that, it comes along with this, so no additional configuration setup is really required when it comes to the MongoDB part. Okay, so let's get started and talk about how MongoDB can offer the replication. See, the idea behind the replication is what? The idea behind the replication is like you are replicating it. Okay, so when you talk about replication, you are replicating your data to where? To the multiple childs. So here in MongoDB, we have one concept available. Okay, that is known as called master. Okay, and slaves. Okay, Master is one and there will be multiple slaves. Okay, so these slaves where your records are actually stored, and this is a master which will be responsible to replicate the data to all its childs when the request comes. Due to that, in case if one particular node fails, so automatically the data will be taken from the other nodes. That's the beauty of having this master and node slave process. So to make this possible, we have a very simple option available. In MongoDB, we have a one concept like called MongoDB Atlas. So there we can go and get our cluster ready. So here we start with the concept name called MongoDB Atlas. Let's search for MongoDB Atlas, and here I see MongoDB Atlas Database as a Service. See, this is a free tool. It's a cloud environment where you really don't need to install MongoDB in your local machine. It is a cloud-based MongoDB support which is free to use with a limited amount of space, but yes, for the testing purpose it is the best suitable. So I can start with the start free, or else I can say the login here. Okay, from there onwards I can go ahead. Now it is getting ready. Now this is the place from where you can start working on your cluster. See, as I've told you, like initially when you will be working on this MongoDB, it will ask you to create a cluster initially. Okay, since I already have a cluster with me, okay, so I really don't need to create it, and as a free tier it will not allow me to have more than one cluster setup ready. So if I say create a new cluster, okay, and I say by default AWS, okay, and let me close down this notification. AWS, you can select any other cloud provider, and 8 GB RAM, cloud backup, cluster name. You can see now it is taking me 0.54 per hour. Reason being because I already have a cluster with me. Hence, more than one cluster is not allowed in a free tier cluster. So I have to cancel this. But you can go and create a cluster the way it was offered there. So if you want to create, you can just go ahead and do nothing. Just select by default AWS, select your location. Okay, give the name of the cluster. You want to give anything, you can give it here. Otherwise, let it be the by default name cluster and say create cluster. It will take a while, minimum 2 to 3 minutes, depends on the availability. It creates a cluster for you, and your cluster, once it is ready, it looks like that. Okay, so here in this application you have to go back and understand what is there in a cluster. So when I click on cluster 0, you can see now here we have got 3 nodes available. One is called primary node, which is called master, as I suggested earlier, and now we have called slaves. Automatically when the clusters are created inside this MongoDB, by default it will be 3 node cluster, where the 1 will be the primary and 2 will be secondary. Based on your package, whichever you have taken it, you can increase the number of nodes later on, but as a free, I will be receiving total number of 3 nodes available here. So records, whichever will be stored, it will get stored automatically in both the nodes, secondary nodes. And from the primary, I can insert the record, and secondaries, I can read the records. Remember, you can't insert the records into the secondaries. You can only insert the record only in your primary record. Secondaries are not allowed to insert. So this is your replica set. Okay, these are the nodes which are available to you. So when you click on this primary here, you will see it is telling you no data available. Nothing is there because I haven't stored any records as such. So I just go back to my cluster. So initially I would like to go back and create few things now. Okay, I would like to go back and set up few initial things at a time of creating the cluster, because when a cluster is created, clear now, so in that point of time, no setting is configured. You have to do few settings now. First setting is you have to put it, remember the steps. first step will be your network access. So in network access, you have to go and you have to say add IP address, and in this add IP address you have to select this option from which location you would like to accept. Only those IP addresses will be whitelisted. Otherwise, what you can do, you can see here in my options I have given 0.0.0. that means all IP addresses are acceptable, so all IP addresses are used. Okay, so this you have to enable it, otherwise you won't be able to get this network access from any third-party locations. Next, you have to talk about call database access, which is required for you to create a new user. There are already some new users are created, but it is recommended that you to go and create a new users here. Okay, so you can go back and add a new user. So by default it is username and password is given, so you can go back and create a new user. When I say add user, you can give the username as well as the password as per your own convenience. So new user, I'm going to create it, that is known as called SL, okay, user, and here we're giving call admin 123. So SL user admin 123. Remember, this will be the username and password. I'm saying add user. New user is automatically added. SL user admin 123. So once you have provided this network access, database access, next you have to create a new data. So what you need to do, when you go back to your statement, okay, network access, database access, it will ask you like you want to create a new database. So I just go back to my project 0. There will be an option called collections. You have to go back and create a new collection here. Now it is retrieving the list of databases. Now you can see there are already some collections are there. AmarDB is one of the database which is there. DemoDB is there. Lot many databases are there. So you can go back and create some new database and connect through. So if I just create database, I already have a Simplilearn DB with me. User app is already one collections I've created. So creating a database and collection is very easy. If I give you the quick demo, I say create database, give the collection name called SL demo, okay, and give the username called EMP SL demo and employee. I say create. Now you can see SL demo and create. It is there with me. So there is no record right now, and once it is there ready, so remember SL demo and employee. I'll go back to my code again, project 0, and from here I can say connect because I want to connect it. So to connect it from, because your MongoDB is already there, so you want to connect it through. So to connect it through, we have a very simple option available. You can just click on this connect option. Multiple options are there. Through Mongo Shell, connect your third-party application with the MongoDB Compass. So since I already have a Mongo Shell with me, so Mac OS, I have this Mac OS with me, so you can just use this line. Okay, so if you have a window, you can select your window. Since I have this Mac OS, I'm selecting this line, but I need to replace with this you can see this username, okay, and you have to give the username here. I'll select this. I open my terminal, okay, and this is, I'm just closing this and opening up another terminal here. Since I want to connect with the Mongo Shell now, so what I need to do here in this, I'll just paste that, the command which I have it now. Username is, you remember I told you, you call some users which you have already created. Let's check. Here, SL user, I say SL user, I hit enter. It will ask me the password, so I've given the password admin, and now you can see it is connecting with me to this particular, see, Now see, it is connecting me to this particular replica set. You can see in a logs it is telling you very clearly, okay, saying that it is a username 4.2, and you can see it is connecting with your shard cluster, the cluster which is created, and this is where exactly I have it with me. So I'm connecting with this environment. So primary is there. So if I just want to go back and say show collections, so I can go back and create a new collection here. Okay, so it's up to you now. By default collection which is their employee, so I can say db dot employee dot insert, and now here we can just add name. Okay,
coffee.
Now you can see some exception is raised, so you understand. Now you can see the records are added into my primary cluster. So if I just go back and go back to my project 0 where we have got collections, here you will be getting the SL demo employee, loading the documents. So it takes time to get this, but this is where exactly you see the records will be stored. Okay, so that's where exactly it works fine for all of you. So we have this record. Okay, so when I say show collection, so we have a call employee, and I say db dot employee dot find. So I can see we have got new collection name call. This is added right now. Okay, so like this you have got the first connection established and the records has been inserted. In this particular tutorial, we will help you to connect your MongoDB with the front end that is called Python. As we know it very well about the popularity of Python in last recent years, it is growing like anything. So we thought, why not to offer you this connectivity where you can have the MongoDB not in a local environment but in a cloud environment. So here we will tell you how to create the MongoDB complete environment of cluster in your cloud, and we can have this connectivity with our Python which is running local to my system. So I show you about few important things one by one. So why Python, MongoDB? We understand MongoDB is one of the most important database, which is so-called document-based database available in market, and it is fantastic, phenomenal in terms of speed and the reliability. It is purely called NoSQL database, okay, and helps you to go schemaless. Now Python is one of the most commonly user-friendly programming language for creating a complete web-based framework. So it offers you huge amount of libraries with flexibility of connecting wide variety of applications. So we would like to give you the idea of like how Python and MongoDB works together. Okay, so you can use both the products together to develop different varieties of applications which can suit to different type of ideas. Now here we have one of the very popular tool available named called PyMongo. So PyMongo is actually the Python library which is a kind of a driver through which you will be able to connect with your MongoDB and perform basic operations whichever you expect. Okay, so let's go ahead and start working on those demos. Okay, so we will start with creating a MongoDB environment with cluster in one of the very popular tool that is known as called MongoDB Atlas. So we'll be opening our website and go here and talk about called MongoDB Atlas. I search for MongoDB Atlas, that is basically the MongoDB where called database as a service. I'll be selecting the first option and go to the start free because it's going to offer you by default some 500 MB of free space. I say sign up with Google. Going ahead and selecting this. Okay, I say accept and say submit. Okay, so it is starting up now. It'll ask you about a few things. I would rather say to select skip and continue. Well, it'll ask you about which environment you would like to take. So I like to take this shared cluster. I say create cluster. Now here it will take a while to get yourself ready for. We can see it is offering the sandbox of having 512 MB of free space. And this MongoDB no backup, that is the by default cluster name. You can give the name of the cluster if you want, but let it be by default cluster 0. I'm saying create cluster. So my cluster is being ready. So it will take a while to get your cluster set up. So just wait till the time your cluster is getting ready. So I tell you about this cluster is going to give you by default 2 child and 1 parent, so called a 1 master and 2 child nodes where your cluster will get ready. So you really don't need to set up any kind of cluster in your local environment, and that is the best environment I would suggest for most of your development, where your time reduced. There will be no software requirement because sometimes version to version it changes, and you can get all the benefits of clusters. So we're just waiting till the time the cluster is getting ready. So once the cluster is ready, you will be seeing some options where will help you to create the clusters in your upcoming demos. So friends, your cluster is now ready. You can see now in this cluster you have got this environment. So in this environment you will see there are some options they have given you one by one. Build up your cluster, create a first database user, add an IP address, multiple options they're telling you now. So how to set up? So the first build of the cluster, which we have anyways done. Next is called create your first database user. So select this. So it will highlight this area. Now you can say like database access, and I'm going to create a first new database user and new database user, giving the username called admin. Let's keep very simple username and password admin123. So admin123. Yeah, same, and say add user. Now you can see the user is created. Now let's go back to the next option. It's telling me the network access. Now go here and say sorry. Now say add IP address, and I'll say allow access from anywhere so that I can take it from anywhere. I say confirm. Now it is telling me about the progress. I select this. Now tell me about which type of collections you want. Okay, so I select this, and inside this I'll be selecting this called collections. Okay, and it's getting ready. So it is giving me some options. Well, two options it will give you: load sample dataset, add my own data. I'll say add my own data. Give the database name SL demo. Give the collection name EMP or employee. Remember, database name SL demo, or I can better give the name called SLDB. SLDB and employee. I say create. That is getting ready. Okay, so my database and table is ready. That's it. So I think we are all set with this environment. Okay, well, once it is ready, your collection is also ready. I'll go back and click on my project 0, and here, yeah, So once it is there, then I'll be clicking on this option called connect. Now it will give me the multiple options how to connect. So it will say connect with the Mongo shell, or it will say connect with your application, connect using Mongo Compass. I'll select the Python version 3.11 or later. So certainly I'll be using those version only. Okay, and in this I'm having this, so I will be using this to connect with my backend. So that's how exactly you have the setup of MongoDB cluster. Everyone, so we are all ready now with our setup. Cluster we have already created earlier. You remember about we have taken Python 3.11 or later. So here if I just go back and check, I have got 3.8.5, which is Python 3 version, which is available. So you can select based on whichever we have it. Say 3.11 or later, we can say 3.6 or later. So there'll be no much difference if I just see, even if I just talk about 3.4, there's some change, but here 3.6 or later, it is same. So I have a 3.8.5. Okay, so I can use the same option. So here in my VS Code editor, I am using for my development. So here's a simple demo.py I have used. Welcome to check if it is working fine. So yes, it is working fine. I'll start working with my first program with MongoDB. So I just go back and say demo py, or I can say py demo.py. Okay, and here if I want to go back and start working on the development, remember one thing we need, first dependency called pymongo. Okay, what I need, pymongo, and for this we have already installed this dependency here sometime back. This is how you need to install. Okay, so we have this statement name called what, pip install pymongo. That is the first dependency which you need to download in order to work with this. Okay, so that's what we have taken, this install pymongo. So if you just see, you can go back and start developing this statement. Okay, so let's go back and start working on this. Step number one, you need to always say import number one, the one dependency which you've installed is called pymongo. So I can just say pymongo. That is a dependency we have recently imported from. Okay, let me go back and search from next point. So import pymongo from, here we are saying pymongo. Okay, pymongo, and we're also saying import Mongo client. That's the first thing you need to remember. Okay, after that we would like to go back and use the cluster. So we say cluster equal to Mongo client, and here I'll be passing the complete values, the one which we have taken. So this complete line, I just take it, go back, and here I'm pasting it. Now here I have to basically replace this password with admin123. Okay, and we are all set. Okay, now once it is ready, we can go ahead and define db equal to cluster and provide which database you're talking about. Okay, so you remember about we had a database which was available to us that is known as called SLDB. So I can just use the same SLDB there, and accordingly I can use which collection I'm connecting it to. So accordingly I can go back and insert a record. Okay everybody, so I can see I have got this file with me. going forward, I have to tell, so this is what exactly the connection URL you have received. Now I have to define which database you're working on. Let me say TP equal to cluster, and we have to provide in double quotes the database name called SLTP. If you remember, we have used this. After that, we have to mention which collection it was. So collection equal to DB, and here we just give the name called employee. That was our collection name. So once it is ready, then I have to basically perform some insert operation. So I just say post, okay, it's just a name equal to, and here we just provide the properties like I would say name. So you know it is a JSON based database, so I can just use the name. I say Amar, and once again I can just say email and say amar@email.com. That's it. So this is just the data which I have. Now I want to insert, so I can certainly say collection dot, because I want to insert only one record. You can see I have one functions coming up, collections dot insert one, and pass post as a parameter. Now we are all done. Let's try to run this. So I'll be running this with Python 3 py mongodemo.py, hit enter. Now it's done. Let's confirm. Here into my code, I will just go back and check here inside my applications. I can just go back to my collections, and in employee, yeah, there we go. We have got some records coming up here. Okay, so these records are nothing but the one which we have recently inserted in our application. Okay, so fantastic. So first example is working perfectly fine. How we can have the records coming from the Python and insert it there. Like that, I can have as many number of records I can add it. So how we can basically add, if I want to add more than one records, let's see this now. Here in case if I want to add more than one records, so I can just use called post one. I copy this URL and paste it below, and I say post 2. I say Amar, I say Amar G email amar12@mail.com, and rather than saying insert one, I can use insert many, and inside this I'll be using this square brackets and pass post 1 comma post 2. That's it. Okay, so let's change the little name because it is already there. Let's insert. Yep, records are inserted. Let me verify once again by refreshing it. Well, now we have a total number of 3 records are available. Yeah, there we go. So records are added. Perfect. So like this, you can have as many number of records you can basically add it. In a similar one, the way we have basically used this, I can also perform the search part too. Okay, so in case if you want to perform the search part, we have a very simple statement available with us. What? I'll go here the way we have added this. So in this, I'll just, these records which are added inside my application, I would not execute this. Rather, I would like to go back and say no, they are basically commented now, and in fact I would like to use this also. Okay, I'll go here and find results equal to same collection dot find If I want to find a name, we can just use curly braces, name, colon, Amarche. Okay, so let me say print and parse results. Okay, let's run this. Okay, so it will print what? The results for me. Okay, so it is just printing what? The cursor object for me, saying that, hey, this is what the record is available to me. We can also change, in case if we do not think the correct result is coming up, we can also go back and we can use some alternative option that is called for. Okay, so what we can do, let's take a look here. We can use for. With this for, I can say result, okay, in results, and print this result. That could be one option through which you can get the details with you. Okay, so what you can do, you can run this code again. Oh, I forgot to put this semicolon here, or we need to check. Well, that was my requirement was, so I'm having this. Let's try to run this. Well, I got my result, and this is what the detail which I have available to me. So very simple how you can basically find a record and how you can basically retrieve the records. At the same time, if you want to have the specific field rather than all the fields, so here in my code, in this result, okay, you can just put a square bracket and tell which field you really want it now. Suppose if you just want ID, or else if you want name, you can basically pick that up. Okay, so if I just want that ID, only ID is printed. That's it. Okay everyone, so you have seen, like in my previous code, how we were basically trying to fetch all the records. We were using this find. Now in a similar line, you can also have the option available, because see, when we used to talk about called find, it gets me lot many records, find, and because of that we were using this loop. But in case if you want to fetch the individual records, I'll be clear. So in such cases, you really do not want to use find. You can just use find one. So what you can do is, rather than using find, I can also use one more option called find one, and for which I can come back, just remove this all. Yeah, so here in this case, rather than using this find, I can use find underscore. You can see this option called find one. Here we talk about which are the properties you want to skip and which are the properties you want. So I can just use this option called underscore ID, okay, colon 0. Okay, I just remove this underscore ID 0, and here just print what results. That's it. Let's run. So that will try to fetch some of the records for you, because if you do not have that ID which you've overridden, it will certainly not found. That depends on what you would like to take. So if I just say is having some issues, but no problem, but you know it very well how it basically takes. Now in a similar line, we would like to also perform one more activity to talk about delete. So for which what I will do is this, I just want to uncomment it, okay, and I would like to insert some records here. So here I want to add the ID by my own with name. So we already have this name. Email, I have it. I would like to use underscore ID. Okay, so we have this property called underscore ID. colon 101. Okay, comma, like this. Copy the same, using it here, and this time I'm using 102. Name and everything, it'll be taken. Let me say user 1. Here we try to say user 2. Okay, so collections.many result find 1. I'm just deleting it all, and let's try to execute it first. Okay, so it's executed. Going back. Okay, so I have some records with ID 101 and 102. Now here I just delete this and perform some actions here. Here we say results equal to collection dot delete. See, the options are available: delete one and delete many. It totally depends on what you really want. Okay, so if I just talk about called delete one, it will be only deleting one record. Delete many means wherever the matching records are available, you delete it. Fine. So I'm just using this option called delete many. Okay, wherever the property names are matched, cause quite possible names sometimes match or whatever it is. So it's delete many. So the option is up to you now, how you want. So the selected name, you have to offer it, whether you want to match it with the name or whether you want to match it with the email or whatever it is. So that will be offering it. But there's also an option available where you would like to delete everything. Are we clear? So if you're planning to delete it everything, what you can do, you can just leave it as a blank and try to run this. So collection dot delete underscore many. Let's check. Great. All records are deleted. So as I told you earlier also. So delete many means what? It will delete all the records whichever are present in your code now. Clear? In a similar one, if I want to perform insert, so you remember about we have an option called what? Insert many, and here we would like to pass post 1, post 2. Let's execute. So it will add the records inside this. Okay, and next time what I want to perform, after adding this record, I would like to perform the update part. Okay, so what I really want in my update, let's take a look. Update means certain properties I'm looking forward to be get updated. Okay, so in case if I want to check whether the record has to be updated, I would first go and check whether the record does exist or not. Yeah, we have two names, user 1 and user 2. Let's go back and update part. Here I just say collections, okay, dot update 1, update. You can see update 1 here. Very simple functionality. Here you will go and tell which ID you would like to perform an update. So I say underscore ID colon. Which ID you want to consider? I'm saying 101. Okay, and what else? So I just use another curly braces and I say, sorry, dollar set. And after this, I use this colon, use the curly braces, name, okay, and use what name you want to use it. So suppose there is a user 1, I'm saying user 123. Okay, let's see. It is loading and you can see the record user123 is updated. Perfect. So your code is absolutely working fine. So you talk about either insert, you talk about what update, you talk about anything, it works. So insert, update one, delete one, insert one, as the name suggests, they'll be taking care about inserting, updating and deleting one records. But the moment you use many, they'll be performing multiple records. So this is a very simple way like how the Python will connect with your MongoDB.
In this video, we're going to learn about the differences between MySQL and MongoDB. Now, I'm sure you must have heard about these database management systems, but do you exactly know what set them apart? Don't worry, I'll help you in this video. First, let's look at what exactly is MongoDB. Now, as you all know, MongoDB is an open source, document-oriented NoSQL database. It is document-based, which means that the data stored is represented in a hierarchical relationship using a single record. And also, MongoDB is schema-free, which means there's no set schema to define how the data is being stored in the database. This causes lesser data migrations. But what exactly is MySQL then? Now, MySQL is an open source relational database management system. Unlike MongoDB, which is document-oriented, MySQL is a relational database system. Now, this uses something called as a structured query language, and this is used to access data which is stored in the form of rows and columns. Now, as mentioned earlier, data here is stored in the form of tables with rows and columns, and each data field comes with an index representing the data in the table. And SQL is developed and maintained by Oracle. So then what exactly sets them apart? So in the coming section, we'll look at some of the differences between MySQL and MongoDB depending on certain features. First up is the data structure. Now, MySQL requires you to define your tables and columns before you can store anything. And every row in a table must have the same columns. In MongoDB, you just drop the data in these documents. Also, the data in the MongoDB database is stored in a binary format called as BSON. Next up, we have schema. Now, as discussed earlier, MySQL requires a set schema to define the tables in the database. Now, the database administrator is requested to define a schema which defines how the different tables are being stored in the database. Now, this schema is crucial in case of MySQL. On the other hand, MongoDB doesn't require a prior definition of a schema. Next up is languages. MySQL uses the structured query language to perform actions on the database. It is used to retrieve data, add data, update, create a new dataset, etc. In case of MongoDB, it supports a JSON query language to work with data. Next up is foreign keys. Now, MySQL supports the usage of foreign keys. Now, if you don't know what exactly a foreign key is, then SQL uses foreign keys to link one table to another. Now, these foreign keys make data retrieval easy, especially when there are multiple tables interlinked with one another. In case of MongoDB, there's no support for foreign keys. Next up is replication. Now, MySQL supports the master-slave and the master-master replication. In this setup, data set from one master database server can be copied to other servers. In case of MongoDB, it uses something called as sharding. Now, sharding allows partitioning of data across multiple servers using a shard key. Don't worry if you're not able to understand these concepts well. In the coming videos, we'll explain these concepts in detail. Next up is scalability. Now, SQL database can be scaled vertically, while MongoDB can be scaled both vertically and horizontally. Now, horizontal scaling means scaling by adding more machines to your pool of resources, while vertical scaling refers to scaling by adding more power, like, for example, CPU or RAM. Moving ahead, let's look at performance. Now, MySQL is optimized for high-performance joins across multiple tables, while MongoDB is optimized for write performance. Talking about community support, some of the popular GitHub repositories on MySQL currently are mysql.js/mysql, and then there's MySQL server. And at the time of writing, there were about 222,000 repositories on GitHub with 7 million commits for MySQL. In case of MongoDB, few popular GitHub repositories are MongoDB/Mongo and Doctrine/MongoDB. And at the time of writing, there were about 177,000 repositories with about 923,000 commits. According to Google Trends, MySQL is largely used compared to MongoDB. So now the question arises, which one should you choose? Well, if your application requires multi-row transactions, like for example in accounting system, then a relational database would be more ideal. But if you're using MongoDB, then it is more suitable for real-time analytics, content management, Internet of Things, mobile applications, and so on. Also, MySQL is a great choice if you have structured data and need a traditional relational database. In case of MongoDB, it is an ideal choice if you have an unstructured set of data. So you could pick your choice. And if you're partial towards one DBMS, let us know in the comment section below as to why you like that particular DBMS. And so with that, we come to the end of this session. Thank you so much for watching this full course. We hope you enjoyed watching it. If you have any queries, let us know in the comment section below. Thanks again, stay safe and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.